which perform this water splitting reaction. This is the solar absorbing material, like solar light absorbed in here. It is also called photoelectrocatalyst. There are some key properties that needs to be maintained for an efficient hydrogen production via water splitting. Those requirements are, for example, appropriate band gap. What it means by that, this water splitting minimum energy that is needed is about 1.23 volt. Hence, the band gap of the material should be above 1.23 electron volt. Usually, because of the overpotential, it is recommended that it should be around 2 electron volt. The second is separation of photoexcited electron and hole pairs. What it means that once the electron and hole pair is created, let me use my laser pointer. Once these two are created, then there is always a possibility that these two recombine, and hence no free carriers are available. And this recombine can happen in a picosecond level. So we need to break the pair. This is called exciton pair. If they still see each other, interact, we need to break the exciton to have an efficient free carriers. Usually materials which has higher dielectric constant, they have lower exciton binding energy. So that helps, and also some other inbuilt electric field like PN junction kind of technology is also used, like in photovoltaics. And the third thing is the charge transport, meaning once you separate the carrier, the charge should be efficiently transported through the materials up to the interface, up to the solid liquid interface. Now, today's work is basically focusing on the third, the charge transport part on metal oxide photoelectrocatalyst. The point that we will be focusing today is polaron. In metal oxide, especially in 3D metal oxides, which have strongly correlated electrons, the electrons can interact with the lattice. That means, we know that at non-zero temperature, finite temperature, there will be lattice vibration, which we call phonon. Then electron can couple with the phonon, and that coupling together, we call them polaron. These are quasi-particles. Pictorially, if we look at this figure, electron can be trapped due to lattice distortion. This lattice distortion creates enough negative potential or a kind of a potential well to trap the electron. And this shaded area is kind of an indication of the extent of the wave function for this electron and phonon coupled state. In terms of the extent of the polaron wave function, this can be divided into two with some obvious name. If the localization is less than the lattice parameter of the unit cell for a crystal, we call them small polaron. Sometimes it's also called Holstein polaron. And if the extent of the wave function for the polaron is larger, it could be larger than few unit cell, then we call them large polaron or frolic polaron, because those two names, they made the mathematical model for these two polaron, which we have a very quick review in the next slide. Just to give an idea that why we are calling this thing related to transport property. If we consider diffusion length, silicon has diffusion length in order of 100 micrometer. Tungsten oxide, which is not strongly correlated 3D oxide, it's 5D oxide, it still has larger electron diffusion length, 400 nanometer. On the other hand, if we consider the oxide which has 3D electrons, bismuth vanadate with vanadium, iron oxide with iron, as you can see that the electron diffusion length decreased significantly, 75 nanometer and 2 to 4 nanometer. This small electron diffusion length other ways we can call that, or you can say that these have very high resistivity. These are these are the consequences of polaron formation. This polaron can only hop from side to side to conduct electricity. And hopping, as you can understand, that hopping means not only the electron, also the distortion is transmitted with it. Hence, the charge transport is very slow. A quick history of polaron. Polaron, the concept was first introduced by Landau in 1933, and then Baker in 1946 just modified this model and then published a paper, which is usually called Landau-Baker model. This model is developed by considering dielectric continuum. Don't get into the solid crystal or the band model of the solids. Frolick, on the other hand, he based on the Bloch equation, apply the second quantization to write the Hamiltonian for polaron, where the first summation is the contribution from the particles, electron or holes. Second one is from phonon, and this is a linear coupling term between the particle and the phonon, electron or phonon or holes and the phonon. The V term, which is the coupling, which signifies the strength of the coupling, this is taken as a long-range average within certain volume V. Here, alpha is the electron-phonon coupling constant that is used in here. It's a dimensionless quantity. Small polaron, that model was proposed by Holstein. It's a similar Hamiltonian. The only difference is that instead of this VQ, this has G and N. G here is a short-range electron-phonon coupling, and this N is the number of unit cell used in the calculation. Now, the computational methodology that we have used in our work is density functional theory with Hubbard kind of U electron repulsion energy. This is added to localize the electron on a certain site. How we did it, it's a very easy process. Let's say this is a ground state crystal, which is a bismuth vanadate. We can add electron or a hole to this unit cell to ensure that this extra carrier gets into a preferred position. That position can be perhaps slight, and then it can be relaxed fully. If we add an electron, we get electron polaron. The localized wave function can be seen in here. Or if we add a hole by taking out an electron, basically, then that creates a hole polaron, and that can be localized if in metal oxide at the oxygen side. All the calculations were done with the fast code. We will start with bismuth vanadate. Hence, this is just an introduction slide of bismuth vanadate. We checked the crystal relaxation and everything. As can be seen in this table, our calculated lattice constants are agreed pretty well with the experimental ones. There are many other experimental work. We just pick one. Now, this is a band structure. After relaxation, we calculated band structure for bismuth vanadate. The feature that I would like to point out in this density of state plots, the valence band maxima, as you can see here, these are mostly composed with oxygen p orbital. And the conduction band minima, these are mostly composed with vanadium d orbital. Now, why I'm pointing out this? Because when we localize or stabilize polaron, we know that whole polaron will be stabilized near the valence band. So it will create it mostly on the oxygen, include oxygen p orbital, and similarly electron will have vanadium d. So this kind of information immediately tells us that which orbital will be involved in polaron formation. Now, in bismuth vanadate, we also quickly calculated some of the features, the electron effective mass. And electron effective mass for bismuth vanadate without any doping is around at least 2 times more than the rest electron mass. That means 200% more than electron effective mass. We try to do manipulation with pressure and some delocalized doping, we can reduce up to such some extent, but not too much. These are the experimental indications. I think I will not go into the details of it because of the time. This tells us that there are some possibility of forming polarons in oxides. So basically, we ask this question that can we confirm polaron formation in bismuth vanadate, and then how it affects the transport. First, the way we mentioned, we localize or we stabilize electron polaron, and as expected, it stabilized at the vanadium site. The charge state of the vanadium ion changed because of electron trapping in the lattice, and this shows the lattice distortion, which create the potential to trap the electron. Then we look for the electronic signatures. This is the DOS plot with the band gap for pristine bismuth vanadate, and this is electron stabilized or electron polaron stabilized density of state plots, where the polaron state, as you can see, is created about 0.4 electron volt below the conduction band minimum. Then we tried on bismuth. This is just a test case to see if something happens with bismuth, but something happens. Yes, we see some unoccupied states just above the valence band, and the wave function of the charge density is perfectly spherical, as you can see in here. These are basically bismuth 6s orbital, the anti-bonding 6s orbital that presents on the top of the valence band. And this is not definitely a polaronic band. This is just some kind of pseudo-metallic structure. Then, of course, on oxygen side, we tried the the hole polaron formation. We stabilized hole in one of the oxygen side. As you can see, this only oxygen side shows this localization. None of the atom has the contribution. And it's from the look of it, we can see this has the oxygen P type of character, the dumbbell P type of oxygen 2P character. Then also we calculated the electronic signature. We have found that the polaron formed about 0.8 electron volt above the valence band. This is the polaronic state. Now we compare our results to the experimental results. These experimental results were from our colleague in Darmstadt University in Germany. So from our theory, what we have found that the electron polaron formed at 0.4 approximately from conduction band minima and valence band minima. The whole polaron created about 0.8 electron volt. If we compare the numbers, 0.38 versus 0.3, 0.80 versus 1.02, I would consider them, these are good agreement, given the fact that DFT does not have very good reputation in reproducing a strongly correlated system. But for the polaron, the modeling technique we have used serves us well. This is the published figure. I just copied it from the paper. Now, because in polaron conduction, one of the important things, when polaron hop from side to side, there is an energy barrier. We call it activation barrier, and we calculated activation barrier for both electron and hole polaron. When the polaron hop from one side to another, it goes through this activation barrier, and the calculated activation barrier are shown in here. This is the whole activation barrier, about 0.3 electron volt. Electron polaron activation barrier, about 0.4 electron volt, which shows that whole polaron will be more probable in bismuth vanadate than electron polaron. In fact, several recent experimental papers, not within our collaboration, has shows this feature. Then we calculate polaron mobility. For polaron mobility, we use an empirical formula. Dispersion and the phonon density of states, we know that whole polaron stabilize that oxygen. You get the oxygen characteristic frequency, and electron stabilize at vanadium, get vanadium characteristic frequency, and calculated these two mobility, electron mobility and hole mobility. As we can see, consistent with the activation barrier results, hole mobility is higher than the electron mobility. Just to put things in perspective, if we consider silicon, the mobility of charge carrier in silicon is 100 to 1,000 centimeters squared per volt per second, where these are, as you can see, in micro level, 0.3 times 10 to the power minus 6. So these are almost 1 million times smaller, the mobility, and hence polaron creation does create problem in terms of transport property, as well as performing those catalytic properties that we started to improve. Just one slide, we also calculated for delphosite materials, copper iron oxides. We compared the theory.
Sorry,
yes.
Dr. Nurloda, you have 2 minutes left. Sorry.
I have only one slide left, so I'm done.
Okay, thank you very much.
Anyway, so from the copper iron oxide, we calculated the polaron in here, and this figure summarizes our calculated and experimental results together. We are not as successful as we had in vanadium oxide, or bismuth. As you can see that we get the electron polaron created at about 0.55 electron volt. No, sorry, we had problem with the whole polaron, but the electron polaron was pretty good in here. 0.55 electron volt versus the experimental value of 0.6 electron volt. But for the whole polaron, we did not get good correspondence. Now, this is the conclusion slide. We basically have found that polaron usually forms in a strongly correlated system, especially in 3D transition metal oxides and 4F rare earth oxides or sulfides. Polaron formation is very common. Polaron conduction is different from the band conduction. Band conduction is represented by the band feature of solids, for example, materials like silicon, gallium arsenide, zinc oxide. They have pretty much band conduction. One of the most popular oxide, titanium dioxide, which was the first one almost 50 years ago, was shown for this photoelectrochemical process. That also has polaron conduction. So polaron is coupling with electron or holes with the phonons. Electrons form below the conduction band minima on the cation side. Hole polaron forms at the anion side above the valence band maximum. Now, I did not discuss today because of time constraint. We have shown, and this work is published, that the polaron gap, the polaron state for the electron and hole, they create a polaronic gap within the band gap. And that gap actually determines the photoelectrodes photovoltage that we know. Final point is we're in search to find a mechanism to suppress polaronic states from within the gap. We have some initial results from our California collaborators, which are showing promising indications. Lastly, I would like to acknowledge Texas Advanced Computing Center for the computing time and National Science Foundation for the funding of this work. Thank you very much. I really appreciate the opportunity to present my research. I'm now open for questions, if there is any. Can you hear me?
Yes, I think Sir, Professor Dr. Ghulam Mohammad Ruheba is here. Sir.
Thank you very much, Dr. Huda, for your excellent presentation. And now the floor is open for question, comment, or any discussion. Okay. Is there any question?
I saw a raised hand.
Sorry. Hello.
Okay.
May I ask one question? Oh, thank you for your nice presentation. Actually, I just need to ask a question. Your methodology. So, if you're just adding one electron or just hole. So, in case of if you add one electron the system and optimize, maybe the structural change should happen, and just like as a UV irradiated system. Am I right?
Yes, of course, you're right.
So in that case, what types of any effect of this result?
Okay, let me go to the slide. If I can go quickly, sometimes I think, yeah, we're almost there. Let's go to the next slide. Yes, for example, in this slide or in this scenario, a hole is created on a certain site. Of course, how do we create hole? We basically take an electron from the supercell. So this is a 2x2x2 supercell of bismuth vanadate. We take one electron, that means we create a hole, and then we make a slight perturbation on one of the anion side because we know it will be created on anion. If we do that, then of course we imbalance the forces within the system, between the ions. And then we relax it completely. When you relax it, then this happens down this side. So these are the lattice distortion. We also mentioned, I did not go through in detail. For example, the vanadium-oxygen bond length, the equilibrium bond length was 1.74 angstrom. But after the relaxation, that bond length, as you can see, this oxygen and vanadium over here, this bond length is now extended to 1.84. Similarly, bismuth-oxygen bond length was 2.50. Those are also changed, depending, not uniformly, it depends which direction we are getting for the bond. So yes, there is a distortion. In fact, this local distortion where the hole is trapped now, that facilitate this charge trapping. But if we come far away from that localization point, let's say a suitable point where we are not even close to the periodic image of the site, then the deviation of the bond lengths from the equilibrium bismuth vanadate bond lengths are negligible. But yes, we do need to relax it completely. One more point, which is slightly more detail of the methodology, is that because we are adding or taking out electron, this is a charged supercell. And because of the infinite nature of periodic boundary conditions, it will be an infinitely charged system. The technique is to add a background charge density so that that artificial infinite charge is neutralized.
Thank you.
Thank you. I'm not an expert in this area, but I have a small question for you. Is the polaron and polariton same or different?
Polaron is just what this is. It's just a electron will get trapped due to the lattice distortion. That is, yeah. Okay. They create kind of a negative potential. So that's all is polaron, nothing.
That's it. And polariton?
I don't remember right now about polariton. So I will not.
Okay, so now just my question was that is there any interaction between polaron and polariton? No. Okay, thank you very much. Okay. If there is no more question,
sir, I have a question, sir.
Okay. Okay. Ask.
Yeah. Thanks for this wonderful.
Okay. Allow them to.
Thank you, sir. Thanks for this wonderful presentation. I have just one question that you are using this DFT plus U approach, right, to calculate the. But usually in the literature, people use like the post DFT method to analyze this sort of boron because they are kind of excited states, and DFT always go for the ground calculation. What's your comment on that? Do you have any plan to extend your work like GW, some other methods for more accuracy? Thank you.
No, thank you very much. It's a good question. For this particular type of calculations, we don't need to go GW. One of the problem with GW, or two problems. One is that it's a very expensive calculation. And second, those are not variational, meaning it just calculates one step single point kind of energy about band corrections. Hence, if I want to stabilize in a crystal, the GW, we have to first get the structure, the polaron containing structure, and then I can apply GW just to get the, that GW is basically pseudo particle corrections, many body corrections on that particular sense. But it is not a total self-consistent energy calculation. So it will not give me, let's say, that activation energy that I have calculated. I shouldn't say we have calculated, or the mobility in that sense. If I want to, let's say, I'm only interested to the correction of the band gap or the exciton binding energy, that exciton is broken for electron or hole mobility, then GW would have been a better method. Yes.
And what about the hybrid? Why don't you try hybrid like HSE06 to get a more accurate description?
We did hybrid on many other materials. For this particular one, to localize this electron or hole at a certain site, hybrid doesn't do well. It tends to localize things at arbitrary position. And also hybrid for this large supercell is extremely expensive calculation as well. But we did try hybrid and did not. One of the good thing about DFT plus U, despite tons of limitations, is that we can use DFT plus U in a very preferential way. And also nowadays, we can calculate U in self-consistent manner, not like as a parameter.
Thank you, sir.
So may I ask you a question? Yes, sir. Okay. So, yeah. Sounds like, can I proceed?
Yes, it's your turn.
Okay, thank you very much. Thank you very much for your nice talk. Just for photocatalytic water splitting, either by photochemical or photocatalytic, whatever you say, the effective mass of hole and the effective mass of electron, this ratio actually play a good role to reduce the recombination rate of charge and hole, right? So so far it is believed that from the theory of Chang et al. Published a paper in 2012. So this is so far the established theory. They are saying that the ratio of the whole effective mass of hole should be much larger than the effective mass of the electron. But is it not always also true in the other way? The effective mass of the electron would be greater, and their mobility will be higher, and their separation will be larger, and their recombination will be less. So do you think that is it not possible? Also, is it not expected also in the other way? Right? What do you think?
It has to be. It has to be. Most of the common experimental work that I have seen so far are considered metal oxide photoelectric catalyst as photoanode material. In that sense, the first scenario that you have mentioned, that electron mobility should be better, as meaning it has lower effective mass and hole should have higher effective mass. That kind of scenario can be considered, even though I'm not very supportive of this kind of a statement because of other reasons. We have considered those things theoretically as well. But if we take that argument for granted, then if we get a photocathode, but unfortunately in metal oxides, there are not much metal oxide that can work as a photocathode. People tried using copper oxide, Cu2O, Q plus oxide, but Q plus oxide has a problem with the spontaneous copper vacancy formation. It makes it a degenerate semiconductor. So it cannot be used. Recently, we published a paper on a quaternary metal oxide, copper bismuth tungsten oxide, that can be, and that experimentally verified our prediction of the materials, that can be used as a photocathode. So when we get photocathode, then you should think of the other way, because now majority carrier will be holes rather than the electrons.
So recently we did an experiment actually on photocatalytic water splitting, not for photoelectrochemical. And here we use the cesium tin chloride. And according to the theory, right, we should not get photocatalytic water splitting for cesium tin chloride. But we certainly found both by using ultraviolet light, but also using UV visible light, we could degrade the rhodamine B and we could successfully split the water, right, and produce the hydrogen. So then I think that yes, we should propose the modification of this established thing rule for this.
Yeah, meaning, you know, sometimes I have seen those kind of statement. My always question is, if someone tells me that electron effective mass has to be higher than the whole effective mass, then my question is why?
Exactly.
And then definitely we explored those scenarios. And if we calculate from excited state point of view, if holes are slower than the electron, meaning hole effective mass are the higher, then because the recombination takes place within picosecond time limit, the electron hole recombination is higher. So it's my understanding, and I work with John Turner in National as a postdoc, and you can find his seminal work in photoelectrochemical water splitting. So my understanding and my work also shows that electron and hole should have comparable mobility. Exactly. So that because minority carrier has to move, other than I cannot get the second half of the reaction.
Thank you very much. I think we should not propose for the others.
Sir, Professor Nokib হাত তুলে আছেন কিন্তু সময় কি হবে?
Thank you very much. Thank you very much. Thank you very much. So actually, I have one comment and one question. The comment regarding the effective mass is that you have the dispersion relation. You can calculate the effective masses, right? So have you tried to do that?
Yes, we did. I think there is a plot in there where, because of time, I went so quickly. Let's see if I can. Here you go. So this one, for this one, effective mass, there are two lines in here. One, it says without pressure. So the effective mass of bismuth, pristine bismuth magnetic electron effective mass is 2.05 times ME. M is the rest mass of the electron. And then what we did, we started applying hydrostatic pressure to see if pressure has any effect, because we had a collaborator in a national lab who had this diamond unveiled high pressure experimentation facilities. So for that reason, we calculated the electron effective mass with pressure. And then also we doped niobium, which has 4D electron. We take out some of the 3D, replaced by 4D niobium, and we see that effective mass dropped even further. Still, as you can see, effective mass is higher than almost 1.5 times the electron rest mass.
Okay, so yeah.
No, it is just.
Yeah, I'll just.
Time to maintain.
Okay, so actually it should be the bare mass, right? Not the rest mass, if I am correct.
Well, the bare mass means, yeah, meaning bare mass in the Schrodinger equation, or Kohn-Sham equation.
Yeah. Okay, so my next question is, for the formation of polaron, you need quite strong coupling between charge degrees of freedom and lattice degrees of freedom. Yeah. So have you made any attempt to calculate the electron phonon coupling constant from the transport sense?
Well, when we use this, not explicitly, but it can be done, because we calculated almost every possible thing that we can do from this kind of ab initio method. So
yeah, that is why I was asking, because that would be a useful parameter to know, I think.
Yeah, because sorry.
Thank you very much, because we are running out of time.
Thank you very much. Thank you very much.
And also, I'm happy to talk with Dr. Nokib, I think after 20 years.
Yes.
Over telephone.
Yeah.
Email. You can communicate.
Nurul Hida bhai, it's very nice to see you. Yeah.
Thank
Good
you.
to talk
Thank
to you.
you, the invited speaker, and for your nice talk. So we have to move to the contributor talk papers.
Thank you.
Now.
So stop sharing right now.
Okay. Now our first contributing paper will not be presented. Ratan?
Yes, yes, sir.
I
have got a message.
So the second one, I think, the contributing papers on atomic transport properties of liquid simple metals, a perturbative approach. Mahir Manna and RC Ghosh, who will present it? Mahir.
Yes, sir. Sir, can you see my screen?
Yes. Okay.
Good morning, everyone. I'm Mahir Manna. Currently, I'm a fourth-year student of Department of Physics, University of Dhaka. Thank you for providing me the opportunity to present my research work in the National Conference on Physics 2021, organized by Bangladesh Physical Society. I have done my research work under the supervision of Associate Professor Dr. Ratan Chandra Ghosh. The title of my presentation is Atomic Transport Properties of Liquid Simple Metals, a Perturbative Approach. And now I'm going to present my work. I have organized my presentation into 4 main categories, which are introduction, theory, results and discussion, and finally conclusions. So we know that atomic transport properties, for example, self-diffusion coefficient, plays a major role in metallurgy, technology, and industry. It's an important variable in many equations, including Fick's first and second laws. It's also an important property that describes the motion of individual molecules. So if we look at the properties of liquid simple metals, then we can see that they can be explained with free electron model. All electrons at Fermi surface are s electrons and p electrons. They're similar in characteristics to the solid metals, except liquid metals have short-range ordered nature. And the total energy of simple metals consists of structure-independent energy and structure-dependent energy. The background and motivation for my study is that recently RC Ghosh et al. Applied hard-square theory for calculating the diffusion coefficients of liquid simple metals. So far, very few theoretical work has been reported for the study of atomic transport coefficients of liquid simple metals. Among them, linear trajectory and small-step diffusion theory have been received very little attention. So this is a study to test whether linear trajectory and small-step diffusion theory work well for calculation of diffusion coefficient or not for liquid simple metals. So if you look at the basics of linear trajectory theory, then we can see that here an atom is assumed to travel along a linear trajectory without acceleration during times of interest. The interaction potential V of R between ions is pairwise additive, and here this potential is split into a hard sphere repulsive part and a long range soft part, and then is considered to calculate friction coefficient for the diffusion coefficient, which are represented in equation 1, 2, and 3. And from equation 2, we can see that when R is smaller than sigma, which is the effective hard sphere diameter, then the hard part of the potential is infinite, whereas the soft part of the potential is 0. And in the region R is greater than sigma, the hard part of the potential is 0, and the soft part of the potential is V of R. So the expression of diffusion coefficient in linear trajectory theory can be represented by equation 4. And from equation 4, we can easily understand that this friction coefficient here is divided into 3 parts. The first one is the hard part, the second one is soft part, and the third one is the friction coefficient due to the cross part of hard and soft forces. Here n is the number density, G sigma is the value of pair correlation function at R equal to sigma, and Vs of Q is the Fourier transform of the long range part of the potential, and Hs of Q is the Fourier transform of the total correlation function, which is nothing but the pair correlation function minus 1. For small step diffusion theory, we have assumed that the gradient of the pair interaction potential between molecules at time t plus s can be expanded in a Taylor series about the gradient at time t, and terms higher than the second may be neglected. The distribution function in pair space may be approximated as the product of the local equilibrium radial distribution function in coordinate space and the zeroth order distribution function in momentum space. The diffusion tensor in pair space may be approximated as the direct sum of the diffusion tensor in singlet space, which are diagonal. The expression of diffusion coefficient in small step theory can be written as equation 8, and here diffusion coefficient is divided into 2 parts, which are the hard part and the soft part. So it's obvious that the difference between linear trajectory and small step theory is that in small step theory, the zeta sh, which is the cross part of the friction coefficient, arising due to the prospect, which is neglected here. And From the above expressions of friction coefficients from small step and linear trajectory theory, we see that we need actually two ingredients to determine those friction coefficients. The first one is the potential, for which we have chosen the Bretton-Silbert pseudopotential, and for the pair correlation function, we need a liquid structure theory, and for that we have chosen LWCA perturbation theory. And also to determine G sigma, we have taken an approximation which is called Carnahan-Stirling approximation. And according to this approximation, if we know the sigma, then we can determine the value of G of R at R equal to sigma, which is represented in here. So the first ingredient was the potential, and now I'm going to talk about it. Bretton-Silbert pseudopotential model, which includes SPD hybridization, can be written like equation 11. Here A is the surface parameter, R is the core radius, and Z is the S electron occupancy number. So these are our input parameters, and if we use the input parameters, then the effective interionic potential may be written in atomic units as follows from equation 12. Here Fn of Q is the normalized energy wave number characteristic, and for that we need actually dielectric screening function and the local field correction function to determine Fn of Q. And for the dielectric screening function, we have used Ichimaru and Utsumi as local field correction in this study, and G of Q is the local field correction. The screen form factor is V of Q, which is W of Q divided by epsilon of Q. And if we look at the V of Q from this figure, then we can see that the maximum peak is for cadmium and the lowest peak is for zinc. Now comes the LWCA perturbation theory. This theory is used to explain the pair correlation function G of R of liquid metals. The graphical solution of transcendental equation provides sigma, where U prime is the first derivative of pair potentials and Y is the cavity function. And in this figure, I have just given an example for determining sigma using LWCA with Bretton-Silbert pseudopotential model for tellurium. Now comes the results and discussion part. First, the pair correlation function. From this figure, we can see that the calculated G of R values for lead, zinc, antimony, and cadmium are found good in agreement with the experimental data. The principal peak values of the calculated G of R values
left.
for stannum, indium, tellurium, and bismuth are observed a little bit different than that of the experimental data. The long Friedel oscillations of antimony and stannum are slightly deviated from that of the experimental data. After R equal to 10 angstrom, G of R becomes almost 1 for all the constant systems. That is, the atoms become uncorrelated. For the static structure factor, we see that the calculated S of Q values for lead, antimony, zinc, and cadmium are found in good agreement with experimental calculated S of Q values. The theoretical values of S of Q for stannum and tellurium are found in poor agreement with experimental ones. So this table represents the calculated values for friction coefficient zeta of concern, which are compared to the friction coefficients for hard and cross term, and B star and D star represents the friction coefficients for soft part respectively. So we see from this table that if we use Carnahan-Stirling approximation, delta H, the hard part of the friction coefficient, increases significantly, and which reduces the diffusion coefficient. Now comes the diffusion coefficient. So the graph in the left represents the diffusion coefficient without Carnahan-Stirling approximation, and the graph in the right represents the diffusion coefficient with Carnahan-Stirling approximation. Option using energy theory, cadmium, lead, and antimony. The theory with Carnahan-Stirling approximation provides comparatively better results except for zinc and indium. With Carnahan-Stirling approximation, small step theory provides excellent results except for indium. And for indium, the peak position of the calculated structure is found at earlier than that of the experimental data. So we say that may be the reason of the deviation of indium from the experimental data. So the conclusions are both linear trajectory and small step theories can be applied to determine transport coefficients with the combinations of BS pseudopotential model and LWCA theory. Without CS approximation, LT theory slightly overestimates the experimental data for most of the systems, whereas SS theory overestimates almost every of them. SS theory with Carnot-Starling approximation provides excellent results, whereas linear trajectory theory is found reasonably good in calculating diffusion coefficients. Thank you for your attention.
Thank you for your very beautiful project presentation. And now the floor is open for questions, 1 or 2 questions. Any question, comment?
Sir, I didn't say any hand raising.
No, there is no question.
Can you ask any question for Mahir?
Oh,
Yes,
so Mike, okay, very simple. May I ask you one question? The question is that you have shown that the small step approximation and linear trajectory approximation, you have neglected the cross term in the friction coefficient, and when it is valid?
Sir, in small step diffusion theory, actually, the cross effect is not considered here because the derivation comes from the small step. Is like that they didn't take any cross term when it's considered like near the vicinity of the R equal to sigma. Actually, the cross term arises due to the
no, this is your approximation. This is your approximation. That's okay. But when it is valid, yes, so the question is when it is valid. No, question is a little bit hard for you, maybe. Okay, thank you. Can you hear me? Hello?
Yes. Sir.
Okay, so if there is no more question, then we would like to thank you again. And let us go to the next presentation. Okay, thank you very much. Mahir, can you hear me? Hello? Hello?
Sir, maybe disconnected.
Thank you. Oh, maybe. আমার ইয়েটা ফ্লাকচুয়েট করছে আজকে এই ইন্টারনেটের এই জিনিসটা কানেকশনটা। আচ্ছা এনলে আমরা রতন সেকেন্ডটাতে যাই না পরেরটাতে।
Okay sir, thank you sir for your.
Okay, thank you. So let us move to the second presentation. The title of the talk is boron-rich chalcogenide semiconductor materials prospects for device applications via DFT study. M.M. Hussain, M.A. Ali, M.M. Uddin, S.S. Nakib, and A.M.A. Islam. So, present the talk. Who will give the talk? Maybe M.M. Hussain. Hello.
Hello.
Hello. Can you hear me?
Yes, sir. I am hearing you.
Okay. Okay. Thank you. Then please begin your deliberation.
Assalamu alaikum. Very good morning to all. I hope all of you are hearing me. I am Dr. M. Mukhtar Hussain, Assistant Professor of Physics 2. My presentation title is boron-rich chalcogenide semiconductor materials prospects for device application via DFT study. Before studying my presentation, I should acknowledge to all of my co-authors for their valuable contribution. At present, we are giving much attention to boron-rich chalcogenide compound. In this year, in this year of May of 2021, we have published an article to the Journal of Applied Physics with some excellent properties. Today, I will show very few results on this compound along with boron 12 chalcogenide compounds. So the question is why we study the boron-rich chalcogenide compound. To get this answer, we need to know at first the structure of the boron-rich chalcogenide compound. The structure of boron-rich chalcogenide compound contains icosahedra structure. Icosahedra means a three-dimensional rigid network of boron elements. This kind of structure is very uncommon. This structure sometimes called unusual structure. It is like P12. It is sometimes also called P12 closed case structure. So unusual physical and chemical industry requires some metals chemical properties to meet present technological demand. Boron-rich chalcogenide compounds might have some ability to show achieve this demand because these materials have some exceptional properties like high hardness with good mechanical strength, low density, very high melting point, and superior thermal and chemical stability. This compound can be used in various fields can be used as garments. This material can also be used as a solar materials. Today I will show some data in favor. Russian group, some researchers of Russia have synthesized boron-rich chalcogenide compounds, boron-6 chalcogenide and boron-12 chalcogenide compound at high pressure and temperature condition. They reported that boron-6 chalcogenide compounds are structure and B12 chalcogenide compounds have a hexagonal crystal structure. So this what, as I already mentioned that in the previous report, their research only involved with make stability, structural stability, and dynamic stability. So electronic properties, optical properties, mechanical properties, to unlock the full potential of this chalcogenide for possible application. So for this, we have used cascade module actually, and since our compounds are semiconductor materials, so we have used local and non-local function. For limitation of time, I am skipping this slide. Now I am showing some results. At first, I am showing structural properties. Boron-6 chalcogenide, and we have calculated lattice parameter for both for boron-6 chalcogenide and boron-12 chalcogenide. You will see that our calculated lattice parameter are well consistent with the experimental result. So accuracy of our calculation is well justified. And this is the crystal structure here. I show as a prototype the structure. And this slide showing the electronic properties. Here is the electronic band structure, and here we usually see that this is a indirect band gap because K point, the value bottom of the conduction band and top of the valence band are at defined K points. So both compounds, boron 6 chalcogenide and boron 6 selenite, both have the indirect band gap semiconductor. We can also say that it is a wide band gap semiconductor. And in the point of view of conductivity under external stimuli, we see here that the p orbitals electron will be the dominant contributor.
Hello, Dr. Abdul Mukhtar Hussain. Can you hear me? You have 2 minutes left.
We have calculated local blue color is a high set. Yes, sir.
You have 1 minute left. Sorry. Thank you.
Okay. So the band gap of sulfur is 2.27 and selenium is 1.3 electron volt. And I'm showing some exceptional result. The absorption coefficient of boron disulfide compound showing and visible light region then 001, and this anisotropic behavior is very interesting. And I also show here the reflectivity spectra, very static low value of reflectivity, static value of reflectivity spectra here shown, and the reflectivity value is around less than 15%. So most of the light are compound here. The here I plotted with our boron disulfide compound. You see that the static value of refractive index are very close to this compound, especially in corundum and pericles. So this compound can also be used as an optical guide materials. And if we focus the hardness, this compound we can consider this compound is a member of a hard family, exception of boron 12 selenium compound. And the question is, what is the origin of this high hardness? So here you see that non-selenium compound, selenium element, charge deflation is occurred here, and around the boron element, charge accumulation is occurred. So a strong covalent bond is expected. That might be the reason of high hardness. Similar phenomena we also found in DOS curve. Here you see that the peak of the selenium, boron 6 selenium compound is shifted along the lower energy. So lower the energy will higher the bond distance. This might be the also reason for high hardness. Similar phenomena is also found for boron 12 chalcogenide compound. So and this is the conclusion. I guess I already said. Hello.
Yes, we can hear you. Please continue.
This is the conclusion slide. The boron 6 chalcogenide compounds are indirect semiconductor and they are brittle material. This material can be used as a photovoltaic application also, because this material has visible light absorption coefficient and very low reflectivity spectra, low value of reflectivity spectra. So it has a great prospect for photovoltaic application also. And this material has a high hardness value, and it is a prominent member of a hard family. and especially B12 sulfidonide compound has have shown is extremely anisotropic behavior or optically anisotropic behavior. Thank you very much, sir.
Thank you for your excellent talk. So the floor is open for one question, comment, or suggestion. Is there any question, or comment, or suggestion? Hello? Hello?
Sir, I didn't see any hand raising
I see.
from
So
the audience, so we
okay.
can.
May I ask you one question,
Yes, sir.
Dr. Hussain?
Okay.
One thing, your compound is very hard, as you said, and is it harder than the metallic glasses?
Our compound hardness value is around 30 gigapascal, but I don't know the hardness level of metallic glass.
Because metallic glass are used at the height of the rocket when it goes at high speed. So okay, thank you very much. Thank you. So thank you very much. And our next contributed paper is the following. This is the magnetic flux dynamics of high quality YBC or single crystal inserts from field and frequency dependent AC susceptibility measurements. Rakibul Hassan Sarkar and Assis Nakib. So please go ahead with the presentation.
Can you hear me, sir?
Yes.
Yeah, please start, sir. May I please start, sir?
Yes.
We can hear you.
Yes.
Thank you very much, sir. Respected chair and co-chair of this session and dear audience, Assalamu alaikum and good morning. I, Rakibul Hassan, welcome you all to my presentation. The title of my talk is Magnetic Flux Dynamics of High Quality IPO Single Crystal Insights from Field and Frequency Dependent Susceptibility Measurements. Nowadays, among all Kuiper-Head superconductors, the double copper oxide layer IPO is considered as one of the most promising systems for high critical current density applications. So the study on temperature, field, and frequency dependent susceptibility are of great importance for understanding the magnetic flux dynamics and potential applications of high-TC Kuiper superconductors. In this study, we have investigated field and frequency dependent susceptibility data for both S-C and S-AB configurations, and hence analyze the magnetic flux dynamics of high-quality IPO single crystal. The findings are also compared with the existing theoretical and experimental results. To cover my presentation, the sequence I am going to follow, as you can see on the screen. Very high quality, optimally doped plate-like IPO single crystal was used in this experimental process. The susceptibility of a sample was measured as a function of narrow temperature ranging from 85 to 95 Kelvin, which is just below and above the superconducting transition temperature. The experience of our sample was measured at 1, 3, 10, and 30 wasted with the frequencies of 33, 333, 666, and 1000 Hertz. The susceptibility was measured using a commercial AC susceptibility, and the appearance of the crystal was like a little bit square shaped with thickness of 0.4 millimeter. This is the AC susceptibility equivalent equation, so obviously it has a clear physical meaning. So its real part is a measurement of magnetic shielding capability of the superconductor, which is generated by supercurrent, and the imaginary part corresponds to the AC losses. Later approaches have been adopted by the researcher to analyze the AC susceptibility data. Herzog and Brandt used equation 1 and 2 to express field-dependent real and imaginary part of susceptibility data for a thin disk in a perpendicular field. Sanchez and Clem deduced equation 3 and 4 to represent chi and chi prime for a thin field in a perpendicular in a thin field for perpendicular field. Brandt found equation number 5. But most of the studies are on the basis of a thin sample, but the comprehensive study on extreme susceptibility for single crystal is very rare. From this backdrop, we have investigated field and frequency dependent real and imaginary part of susceptibility for analyzing the magnetic flux dynamics of high quality single crystal. Here you can see some representative field and frequency dependent susceptibility plots. These two are experimental. These two are experimental chi and chi prime plots over a certain temperature range for S parallel to C configuration at 33 Hz for 1, 3, 10 and 1, 3 and 10 Oer state. So these are similar types of curve for S parallel to AB configuration. These are also similar types of curve for S parallel to C and S parallel to AB configuration in different applied frequencies. Here you can see few representative normalized plot. These two are a normalized susceptibility plot for S parallel to C configuration at 33 and 1000 Hz in different applied fields. These are similar types of graph for S parallel to AB configuration. So from this curve, it is clear that the values of prime rises sharply when the diamagnetic shielding capacity increases with the lowering of temperature. Chi double prime shows a peak just below the transition temperature. In the lower temperature range, both chi prime and chi double prime became flat. So from all this graph, it is clear that the peak temperature of imaginary part shifts to the lower temperature with the increasing of applied field. These are also similar types of curve for S parallel to C and S parallel to AB configurations in different applied frequencies. So from this graph, it is clear that there is no significant effect of frequency on the real and imaginary part of AC susceptibility. But the peak temperature is insensitive to the frequency, and the width of the imaginary part is increasing with the increasing of applied field. Here you can see peak temperature versus applied field graph. That means peak temperature for both S parallel to C and S parallel to AB configuration. Peak temperature is decreasing with the increasing of applied field. And from this graph, it is also clear that the peak temperature is higher for S parallel to C in comparison with S parallel to AB configuration, which shows that the anisotropy in the magnetic flux dynamics in our single crystal. This is transition temperature versus applied field graph. That means in a specific applied field for both S parallel to C and S parallel to AB, the transition temperature is remaining same, and the transition temperature is decreasing linearly with the increasing of applied field. Here you can see some representative cold plots for S parallel to C configuration. So the peak values of cold plot are increasing. The peak values of cold plot basically depends on the magnitude of applied field. That means peak values are smaller for 1 Oer, but there is a little differences in the peak for 3 and 10 Oer. So from these two graphs, it is clear that the applied frequency has little influence on the shape of cold plot. These are the cold plots for S parallel to AB configuration. So from these two graphs, it is clear that the peak values are smaller for 1 and 3 Oer, but there are significant differences in the peak values for 3 and 10 Oer. For this graph, it is also clear that the frequency of light field has little influence on the shape of cold plot. Now we'll compare our experimental cold plot with the.
Islam, I actually have 1 minute left. Thank you.
10 minutes, sir.
Now 1 minute left. Thank you.
Okay, sir. Finishing, sir. So now we are comparing our experimental focal part with the recent theoretical result. So for our sample, the peak value is that means the peak value of chi double prime is occurring at 0.34, whereas Brand found in this value at 0.35, and finally according to critical state model, this value is 0.38. So our result is almost close to the Bean critical state model. So if we recapitulate, then we can say that temperature field and frequency decrease susceptibility has been analyzed for both S parallel to C and S parallel to AB configuration, and we have seen the significant shift in chi prime and chi double prime to lower temperature when field is increasing for both S parallel to C and S parallel to AB configuration. TP is higher for S parallel to C in comparison to S parallel to AB, which shows the anisotropy in the magnetic flux dynamics. At the same time, we can say that the TP is insensitive to the frequency. For our sample, the width of the imaginary part was also increasing with the increasing values of applied field for both S parallel to C and S parallel to AB configuration. And for our sample, the magnitude of peak ratio was lying within the 0.22 to 0.26. And the onset temperature was insensitive to the field orientation. As you know, close to the transition temperature, flux tip and flux flow phenomena, it is basically observed for the thermally assisted. For our sample, that means for our IPCO single crystal, we haven't, there is no appreciable effect of frequency on the real and imaginary part of AC susceptibility data. So from this, we can say that this implies that the for our sample, there is no flux tip. According to the Bean critical state model, suggested a peak value for chi double prime is 0.24 and the corresponding chi prime is minus 0.38. Whereas for our sample, the peak values of chi double prime is 0.26 and the corresponding chi double prime is minus 0.34. So which is consistent with the Bean critical state model, which is suggested by the Bean, and as there is no flux creep in the Bean critical state model, so we can say that no clear indication of flux creep has been found for our sample. So thank you very much, sir. We have used these references to cover our presentations.
Okay, thank you very much for your beautiful presentation. So it is nice to see that Professor Nakib has started doing experiment. So that's nice. Okay, now the floor is open for question, comment, or suggestion.
Sir, I have seen two hand raising. First of them is Imtiaz Ahmed. So,
okay, let him ask.
Thank you, sir, for this nice presentation. I have two questions. One is, why did you pick this like specific frequency below 1 kilohertz to analyze your susceptibility in the superconductor? And the second one is that in the superconducting state, in this frequency range, what's the origin of the losses that you're explaining? Thank you.
Actually, I was not involved with the experimental process. Sir, as you know, I am continuing my program in the University of Rajshahi under the supervision of Professor Dr. Saleh Hassan Nakib. My supervisor, Professor Dr. Saleh Hassan Nakib, actually he has done this experiment in his PhD program when he was continuing it in the University of Kent. Just I have taken his data and just analyzing. Actually, Sir said, and for his own purpose and for the interest of his program, he used this data. Actually, I was involved with this experimental process. Just I have taken this data and under his supervision, just we are analyzing it, sir. Because at present, we had no control over the selection of this frequency, sir.
And any comment on the losses that you're expecting in this frequency in the superconducting state?
Yes, obviously there is a loss. We are getting certain value, but it is almost close to the which is suggested by the critical estimate. That its loss is very limited, sir.
I mean, do you expect some sort of quasi-particle excitation in this frequency in the superconducting state? I mean the origin of these losses. Do you expect that in the YBCO in the below 1 kilohertz you will have these excitations?
Yes, sir. We didn't study in this aspect, sir.
Okay, next question.
Next question is Professor Rafiqul Islam, sir, I think.
Thank you, Mr. Speaker, contributor. আমি সহজ একটা প্রশ্ন জানতে চাই যে বারবারই peak value peak it means a temperature. What is the physical meaning of peak temperature or peak value?
Here you can see, sir, peak temperature. Here actually we have used S parallel to C and S parallel to AB configuration. So peak temperature is decreasing with the increasing of applied field. That means if you consider field is increasing, so we'll get field is increasing. So peak temperature is lower.
Well, আমি যেটা জানতে চাই সেটা ছিল যে peak temperature ফিজিক্যালি কি বোঝায়? যদি এটা কোন একটা এনার্জি গ্যাপ থেকে আসে।
আমি কি একটু
হ্যাঁ অবশ্যই নকিব স্যার প্লিজ।
আমার মনে হয় যে কতগুলো কনফিউশন সৃষ্টি হয়েছে, আমি জানবো।
হ্যাঁ
হচ্ছে যে কেন 1 কিলোহার্টজ পর্যন্ত করা হোক, এটা আসলে ইনস্ট্রুমেন্টাল লিমিটেশন এক ধরনের। আমরা যে এসি মিটার ইউজ করেছি তাতে 1 কিলোহার্টজ এর উপর যাওয়াটা বেশ কঠিন ছিল আর কি। সামথিং লাইক 1000 হার্টজ এর উপরে যাওয়াটা এটা পসিবল না, এটা হচ্ছে 1 নম্বর। সো আরেকটা ব্যাপার হচ্ছে যে আপনি যদি ফ্লাক্স ক্রিপ অথবা ফ্লাক্স ফ্লো দেখতে চান তাহলে এই টাইম স্কেলটা আসলে খুব যদি মানে ছোট হয়ে যায় দেন ইউ উইল নট সি ইট। তাহলে এই যে ফ্লাক্স ক্রিপ বা ফ্লাক্স ফ্লো এফেক্টটা যদি দেখতে চান তাহলে আপনার ওই ফ্রিকোয়েন্সিটা একটু নিচের দিকেই রাখতে হবে। এট এক্সট্রিমলি হাই ফ্রিকোয়েন্সি
কেটে গেল নাকি?
উনি কোনো কারণে ড্রপ হয়ে গেছেন, মানে নেটওয়ার্ক রেকর্ডিং বন্ধ হয়ে গেছে কোনো কারণ
হতে পারে। কিন্তু আমার ওই প্রশ্ন ছিল যে আসলে পিক টেম্পারেচার শব্দটার সাথে রিলেটেড যে কোন মেকানিজম কোন এনার্জি রিলেটেড কিনা, যা থেকে আমরা এটাকে এই টেম্পারেচার নাম দিয়েছি। পিক টেম্পারেচার তো এরকম কোন স্পেসিফিক না, যেহেতু সুপার কন্ডাক্টিং ম্যাটেরিয়ালস।
রিকর্ডিং ইন প্রগ্রেস।
আমার নকিব সাহেব ডিসকানেক্ট হয়ে গেছে। না ঠিক আছে, আপনার চালে সামনে আগে।
ওকে, থ্যাংক ইউ ভেরি মাচ। ইজ देयर এনি more question? Ratan?
Sir, actually also disconnected. Sir, Abul Asnad, sir, mona ache.
একটু কোশ্চেন দিয়ে দাও, let him.
Yes, please. Are you hearing? Abul Asnad?
আচ্ছা, আমি সাহেব 1 মিনিট লাগবে। হ্যাঁ, যেটা বলছিলাম যে আপনি যদি ফ্লাক্স ক্রিপ দেখতে চান তাহলে আপনার ফ্রিকোয়েন্সিটা নিচের দিকে রাখতে হবে। আচ্ছা, এখন আমি এই যে পিকটা আসে কেন, এই পিকটা তখনই আসে যখন এই যে ফ্লাক্স ফ্রন্ট যখন ইউ আর ভেরি ক্লোজ টু টিসি, তখন ক্রিটিক্যাল ফিল্ডের ভ্যালু অত্যন্ত কম এবং হোয়াট এভার ফিল্ড ইউ অ্যাপ্লাই ইট পেনিট্রেটস দ্য স্যাম্পল, এবং এই ফিল্ড প্রোফাইলটা যখন স্যাম্পলের সেন্টারে যে পৌঁছায় at that particular temperature imaginary part of the AC susceptibility পিকটা তৈরি হয়। এই পিক তৈরি হওয়ার অর্থ হচ্ছে যে আপনার ফ্লাক্স ফ্রন্ট গুলো আপনার যে সেন্টার আছে ডিপেন্ডিং অন ফিল্ড কনফিগারেশন, যে আপনি এবি প্লেনের প্যারালেল আছেন নাকি পারপেন্ডিকুলার আছেন, আপনার সেন্টারে ফিল্ড প্রোফাইলটা পৌঁছে গেল। যখন সেন্টারে ফিল্ড প্রোফাইল পৌঁছে যায় তখন দ্য লস ইজ ম্যাক্সিমাম, এবং এই লসের কারণটা হচ্ছে যে ওই রিভার্সিবল মোশন অফ দ্য ফ্লাক্স লাইন্স গুলো যখন মুভ করে তখন এই ডিসিপেশনের সৃষ্টি হয়। আপনি যখন লো টেম্পারেচারে চলে যান তখন দ্য ফ্লাক্স লাইন্স আর ভেরি স্ট্রংলি পিন্ড, এবং যখন পিন্ড হয়ে মুভ করে না দেয়ার ইজ নো লস। এবং ওই যখন কোনো লস নেই, ফ্লাক্স লাইন্স আর টোটালি পিন্ড, আপনি ফুল ডায়াম্যাগনেটিক সিগন্যালও পান, সেটা রিয়েল পার্ট অফ দ্য সাসেপ্টিবিলিটি থেকে দেখা যাচ্ছে। আমি খুব দ্রুত অনেকগুলো কথা বললাম, আমি জানি না এগুলো যারা কোশ্চেন করেছেন তাদের কোশ্চেনকে অ্যান্সার করলো কিনা, বাট দ্য ফিজিক্স ইজ দিস।
Okay.
Thank you, sir.
Thank you very much. And so, there is Hasnat. Hasnat was trying to ask.
Now
okay, let him ask his question.
Thank you, Presenter Rakibul Hassan. It's a very informative presentation, I would say. Actually, what I could understand that you explained the susceptibility with respect to the temperature and frequency. And I have actually the similar question, and Professor Noki has already explained it very nicely in the origin of actually the TP here, and he explained that it comes from kind of being of flux. So I have another question that is used here. That YBCO in your example, this is less field component dependent. What you can understand. So what we expect that the superconductor should more field dependent, or what is the applications less field dependent YBCO? Thank you.
আমি কি একটু দ্রুত অ্যাড্রেস করব?
Professor Hassan, yeah, Professor Latif.
আমার মনে হয়
we are running out of time, so I think they will discuss with you, I think, later. Hassan, you just talk with Professor Latif later, okay?
Okay.
Thank you. So before concluding this session, I'll request Dr. Ratan to summarize the session.
So thank you, sir. Actually, a very good morning to all. This is the first session of 7th August, second day of our conference. Actually, we have one invited talk and 3 contributory talks already presented. So firstly, I would like to thank Dr. Nur for his amazing lecture. It's very, very good. I feel very good. He actually started with very basic of polaron formation, and then with its history, and then explained its transport through materials, for example, like silicon, iron, copper oxide, and using DFT plus approach. So, and then Mahir, I will go to our first contributory talk. Mahir Manna also is the only 4th year student. He explained his study very brightly. And then he actually explained the applicability of pseudo-potential model and LWC theory to calculate transport properties, transport coefficient, like diffusion coefficient for simple liquid metals. So it was a taste of his study, and then I will go to the our second contributory talk, which was presented by Dr. Mukhtar Hussain. He presented very brightly various properties of boron rich semiconductor materials, and then discussed various applications. And finally, the credit goes to Rakibul Islam. Also, he is a student, I think. He also presented very nicely the dynamics, magnetic flux dynamics of high quality of YBCO crystal, single crystal, and explained the behaviors of real and generic part susceptibility with frequency. So I found a very nice from them, from the contributory talks, and especially presentation. Nice to us. I think our dear participants, we all learn a lot of physics from them, and then I hope we will apply them in our research oriented topics. And thank you, sir, for giving.
Okay, so with this, I would like to conclude this session, and the people of the next session are waiting for, and we spent few minutes more than the scheduled time. Okay, thank you all. Thank you, invited speaker and all the contributor speakers, and hope you again in any other conferences. Okay, thank you.
Thank you, sir. Thank you, all of you. Our next session is Environmental Science and Meteorology. I want to invite Professor M.D. Mahbubul Alam and Dr. M.A.K. Mullik to take over the charts. Mahbub, sir.
Assalamu alaikum. Good morning, everyone. This is our Environmental Science and Meteorology session, session 8, session 7, National Conference on Physics 2021. This is just in this session, we have one invited talk. Invited talk will be given by Engineer Nasir Ahmed. Is Nasir Ahmed is present?
Yeah, of course, I'm present here.
Okay. The topics is sustainable management of water resources using isotope technique application and active research area in Bangladesh. Engineer Nasir Ahmed started his career in BSc as senior engineer and head Isotope Hydrology Division, Institute of Nuclear Science and Technology, Sabar. Throughout his career in BSc, he has contributed to research and development activities of BSc. He was responsible for all hydrology research activities at BSc and for technical support and quality control of hydrology field, investigations, groundwater resource assessment, and isotopic participation, precipitation associated with climate played an important role in popularizing the application of isotope technique in hydrology among various national and end-user departments, public universities. He obtained his graduation in BUET in 1988 and master's in 1996. Now I am requesting Dr. Nasir to give his invited talks.
Good morning to everybody. So already, Professor Mohran said he just a bit about my position in the Ability Commission. I'm just giving this Islam and this is the greetings to for all the participants. So my topic is the sustainable management of water resources using isotope techniques, application and active research areas in Bangladesh. So first I'd like to start with the what are the research areas where isotope hydrology. There is areas where isotope hydrology or isotope techniques can be worked for. So then you see it's in the screen. This is the start with the paleoclimate, meteorology, planetary science, and hydrology, oceanography. So and the paleontology. So we are actually confined with only the one part. This is the part of hydrology. This is the groundwater and surface water hydrology. We are working in Bangladesh, and also we are working in precipitation, the sources, and isotopes in precipitation. So there are other areas to work with. So but now you need to have every area need to have some expertise, some laboratory facilities. So these are the main things for particularly to work with the isotope hydrology. So this is the one of the disciplines. This is the interdisciplinary. So many disciplines are intermingled here. And geology and chemistry, physics. So all are integrated. And in single term, you can say this is an isotope techniques. And isotope, this is actually it comes from the physics and as well as from the chemistry. So anyway, and now actually why we use the isotope techniques? This actually gives us a relevant understanding of the hydrologic system. So that actually might not be possible for any other techniques or any science or this science is very useful tools. So this is this can provide unique information and also it is mostly cost effective also. So what do you know? This is the key for the development of life. So as I just actually quoted one thing, about 1/3 of the global foods that come from the irrigation, we know that, which equals sustainable groundwater resources, which is very much concerned. and the SDG goal to fulfill. So this isotope techniques will help us actually in performing the sustainable resource and water resources management. The other thing is that about 1.1 billion people today without fresh water, and 2025, 2/3 of the world's population may live in countries with the highest shortage of water. So there might be some challenges. So there is a sustainable water resources. And water, actually, we know that this is a cycle. I mean, the water comes from the rainfall to and it goes and it goes to the river, and again, it's a big cycle is going on. So this is I've shown you this is the quality, quantity. So first quantity, quality, and sustainability. So if so, isotope techniques with the help of isotope scientists can find out how to actually solve the problem of the water. Actually, to find out the problem, actually where it existed. The sources and the problem, the contamination, and the quantity of the water and the quality of the water, and then it lastly comes to sustainability. Here, actually, one of the things related is the groundwater recharge, where the recharge come from, where is the origin of the water, and water salinity level, the salinity sources where. And the third one is age and the movement of the water. And age is the groundwater resources. This is from the aquifers age of the water. Even the age of the residence time of also this for the precipitations also. So this is isotope information, which is some of the isotope hydrologists and some of the big scientists who actually work previously in isotope hydrology. Isotope works. The use of isotope tracers has been the most useful tool in studying the catchment hydrology. This is actually discovered by the Kendall and McDonald. And the second one, the tracers have been able to provide valuable insights in days, pathway, and origin of water in isotope hydrology system. And the radioisotopes, which is tritium, sulfur 34, even the carbon 14, have proved to be useful when studying the hydrology. So that was quoted by Cooper. So what is actual isotope hydrology? It's just a nuclear technique. They use the both stable and radioactive isotopes to estimate the age and origin of the water and to trace the movement of water with the hydrology system. The isotope in water can be traced from water sources to determine the water, where the source is and how it is recharged and how and where it is getting discharged. And so and even the risks of the contamination also. Here you see there are the three types of isotopes. This is the basic isotopes we just used in our actual hydrological study and precipitation study also. So hydrogen isotope, hydrogen is the three form, the protium, the deuterium, and also tritium. Tritium is the radioactive, as we know. I'm not going to detail on this one. Carbon is this is the carbon 30 and carbon 40 and carbon 12. So this is the carbon has the 3 isotope and oxygenating has a 3 isotope. So particularly I'm just talking about here water actually and an H2O. So this is the isotope actually, this is the area of the work where we just actually we can look at this thing and we just go look at the around there. There's the isotopes here. This is the nitrogen. This is the carbon, hydrogen, oxygen, helium, argon, so chlorine, krypton, uranium. So all these isotopes actually just gives us some information and some fingerprinting also. So here are the areas that we can work for actually. This research area, the rates of water origin, mixing and flow paths, as I told you before. And the water budget, climate change here you see, residence time of the water, surface groundwater interaction, and groundwater dating. So in isotope hydrology, the laboratory has been established in IST and Harvard actually. This is which is from the support. Promote and support the development of practical application of nuclear and isotope techniques in water resource and related sciences. Isotope tracers are essential tools for better understanding the groundwater origin, for quantifying the water interaction, mixing process recharge, as well as for providing thanks to the groundwater system and on large scale, spatial and temporal scales. So all this information actually this is used for the staying with the water resource and water resource management also. And this is a fingerprint. We said isotope is a fingerprint. You just see the water cycle here. How does it work? Actually, the water actually gets evaporated and it's and so all these processes with the total water cycle we know. I'm not going into detail here. So if the water first it just comes from down the ocean, it just evaporates, then it condenses into rainfall. Again, it just moves to the inland. So how the isotope variation here? It just gives some of the information. This is called actually the fingerprints. When it moves to the ocean to the inland, and again it's going downward, I mean, to the percolation, the groundwater flow. Every time you give the fingerprint, so from 3 to fingerprint, we can give a lot of information we can get from that, using the isotope techniques actually. So this is called the fractionation. You see, this is from the zero. Actually, when 0 part meal, when it's where there is stabilized, what we say, and here the red marks actually is accretion actually. So this is the isotope fractionation of amine oxygenating and all occurs during the evaporation and condensation of vapor transport. So here actually the science to understand, I mean, the isotope techniques, increasing the oil in the water, particularly here and the focus in the stabilizer. Here actually the identify the different water bodies in the ecosystem, where understand the groundwater solution patterns, so identify possible discharge and discharge areas. You just look at the same heavy isotope, just fall down. Heavy isotope means oxygen-18. We are saying this is the neutrons are actually a number of neutrons are higher, and oxygen-6 is lighter isotope. It's going upward and moving. So this is the isotope actually is giving, I mean, some of the information see here about the water bodies, how the water bodies are interconnected with the groundwater. So all this information you're getting, this is one of the very important tools and isotope techniques. So here this is the science to understand, I mean, reading the water rays actually. So this is particularly using the radioactive isotope here. So what isotope actually here we are using, particularly for using tritium, carbon-14, and helium here. So tritium is particularly we just use for young water actually, young recent water actually, less than 100 years the water exists in the aquifer system. So that is we are saying about the shallow aquifers. And when you're just going to the more deeper, so this is the old groundwater. So around 40,000 years old water we can determine using the carbon-14. And more, I mean, the deeper, I mean, if you just go in the very old waters, and more than 1 million and billion years old water, so this we can use the Krypton-81 and helium. Particularly in Bangladesh, we just use tritium and carbon-14. Previously, we have so many projects. Now I will just show the applications in the next of my slides here. So this is how the isotope actually, how the stable water is a focus in hydrological cycle here. So here you see the fractionation occurs here. These are phase changes actually from here from the ocean to when the mixing is going in here. I mean, mixing is transpiration, different phase changes. Different phase changes actually. This is the fractionation occurs, and this fractionation actually undergoing here because of time constraint. This fractionation here, kinetic fractionation, nuclear fractionation actually. So this is the UC. This is the lighter isotope and heavier isotope. Heavier isotope condenses and a lighter isotope upward here. So here actually you see the 0.2. This is actually the heavier isotope. Heavier isotope abundance is in atmosphere is very little abundance. But in heavier isotope actually, so the lighter isotope, which is 16. So here abundance actually is greater actually. And during the hydrological system, the most frequent processes are the condensation and evaporation. Proxy of the actually, this is called the isotope actually, we can use a proxy for the climate study actually. So here we just see this. There are so many actually hydrological cycles we have shared with some isotope effects. What are the isotope effects? Here the contained effect, altitude effect. So we can say about this is the amount effect. So these are the effects actually already involved within an isotope actually. When isotope actually, I mean, we have to study with the climate system, and even though with the groundwater and everything, it's just like an hydrological, it's a total cycle here. So the total cycle, which specifically comprises of evaporation, atmospheric, vapor transport, precipitation, subsequent return of the melting waters to the ocean, combined with an isotope fractionation, which is called the real distillation here. So in isotope fractionation, you see, as I told you before, this is very come from, I mean, this is from different phase changes from the vapor to, I mean, this is vapor from the water to evaporation, vapor, and the condensation, the precipitation again. So this is the gas creating the liquid stage, the solid stage is called the smoke here. So different phase changes show you the fractionation of the software. And then there is also the altitude effect. Altitude effect means the very higher altitude. So there are more in the precipitation actually you will see. There might be an orographic rainfall. You can see there is some precipitation on offer. So more and more you go to the land, the more altitude go to the inland. So you get more depletion is there. So what are the key findings? Again, we're going to the key findings of our previous project, i.e. technical cooperation project and national projects we just did, what we performed in Bangladesh. So this is actually what we have now sort of hydrology, what we're doing actually in Bangladesh, done by sort of hydrology laboratory. So we just studied the research mechanism of groundwater dynamics that I told you before. So all the system, most of the system just working using the stabilizer and carbon-13 and carbon-40 and tritium. So, and saline seawater intrusion also, this is one of the big assessment we did for the last couple of years. And also the contamination of others, particularly arsenic contamination also. So this is actually the poster that was actually published in IEA, in the journal sector. This is one of the very prestigious, that was actually totally published or done by an understanding agency. And we just did an idea from the drinking water in Bangladesh. So potentially the aquifer system of that was actually found out, and so that was determined and through the aquifer system. So these are the laboratory actually, what we have in the laboratory now. This is carbon actually measurement and tritium, and also this is the stabilizer using the laser techniques, the liquid water acid and the solid actually. And this inclusion powder readily used in the carbon 14. So these are the actually the chemicals. But side by side, when you just do the hydrology, isotope techniques, you must have the such chemical, good chemical laboratory, chemical analysis laboratory that you have. You must have. So you must have the cation, anion, and other trace elements. You must know. So when we want to study for that, so I love this. So these are some field activities, some meters here, and these are environmental isotopes which we use, or as I told you before, isotope system, the carbon 14, which is a 3 actually. This is the green color. This means the cell isotope, and the red means this is the that is a really good isotope. So this is the how the actually naturally just comes from tritium. I'm not going into here. So this is the from the this is from the 14 nitrogen 14 or the neutron actually compartment. So cosmic radiation where it comes to carbon 14 and also then tritium also. So this is the one of the projects that is done in isotope hydrology project in Bangalore. The first project that was done in 2000 actually, that with the help of the IEA, International Cooperation Projects. So through this project, we just classify the water actually in our aquifer system. We just look at type 1, type 2, type 3, and type 4 water. The type 1 water, as you see, this is arsenic bearing, the shallow aquifer seems to be the same. And type 2, this is arsenic bearing, but higher salinity. And type 3, we just classify the classify low salinity and arsenic free. And the type 4, which is one of the fresh water, is here. That water is the very old water. It is just 20,000 years old and 20,000 water. So water there, the water is existing in Bangladesh. This is, I mean, you can say this is more than 200. This is one of the UC. This is a model which is developed, and that model was actually recognized by the groundwater task force in Bangladesh. So here we see the classification. What we did in this previous. I mean, this is the nicer ratios using carbon 14. This is from this figure, and we just in the model. So then the shallow aquifer, the first aquifer, second aquifer. The first aquifer 700 meters. This is most of the aquifers are arsenic laden and arsenic contaminated. Whether the water is getting during pump water going to the second aquifer or the third aquifer through isotope study, and you can find it out. So there is a mixing or not going on here. If there's no mixing, so you are getting very good aquifer. So there's a very good aquifer and very good the aquifer you are having. So anyway, so this actually from this actually stabilized sort of oxygenating as a drop water we can say. So what are the odds? You can say mixing with the seawater when it's near the zero, I mean the value. So
sorry for interrupt. You have only 5 minutes left.
Yeah. Okay. So these are the posters actually here, and this is the tritium actually what we just did here. Tritium using the oxygenating and tritium. So here is a classified low arsenic and that study was done in the Chapine Mountains area. So here the high arsenic areas. This is you see this oxygenating is more more depleted here, and more this positive oxygen value. You see this low arsenic values. Tritium is very low actually. So this water actually indicates the old water is old water is here. And when you just study it, this is in the Bangladesh actually. You see type 1 type 2 water actually. So there is no salinity. You see the oxygenating and chloride when you just make a plug here. So there is no mixing line. So mixing this mixing actually just determines there is no any actually seawater intrusion in this case actually. So anyway, I'm just going to the next. So we also do actually the geochemical characterization as well. So in order to just actually this is to confirm the isotope whether it's this is giving the true information or not. This is even then the select we just make the same isotope study we just did, and we make the classification of water type 1 and type 2. Just show mostly the fresh water is here, and we make the iso scale and the carbon 14 and tritium and stabilizer here. So this is the very, very useful tool to see here. Even in the Chittagong area, one of the very important studies that was done, we just helped the Chittagong washer to identify actually where the potential, I mean, the very good aquifer existed where. So they want to make some, I mean, deep drilling and to make the community water supply. So we just make them study, and the very good study was there actually. So we identified there's no saline intrusion, particularly from the Halda and Pornophagy. Only the shallow part of the Halda, shallow aquifers, a little bit, I mean, the same intrusion is going on from the Halda River only. So this information was very much useful to the stakeholders actually. So there is a river water, Halda River, and a shallow aquifers in 20 connection. But deep aquifer, intimate aquifer are more and more safe. So this sort of information actually might be very useful. These are the sampling what we did actually in sharing the study. So these are actually the, I mean, the operating implementation that was actually recognized by the stakeholders. This is one of the important, it's still not set criteria for considering the deep deal to be contaminated arsenic now in the future. Technically, the drinking water and the shallow is taken by the end user. And what are they actually particular for the IELC of the projects in the precipitation. So these are the precipitation, as I said before, the isolated information is just for the climate proxies actually. So this is actually the Shihu model. This is one of the model actually we say this is stabilized so you can see oxygen difference. This is very important, very powerful to actually to make some characterization of the the isolated characterization in the rainfall study. So this is done in the global rainfall analysis precipitation. We just made using the this is in the meteorological department, and we are really grateful to them. They have used sample collection. This is the Palmas rainfall. It's very special type of rainfall sample in order to step one time the evaporation. So these samples we just take the collection, and we analyze in the laboratory. So here are the games. So I mean nearly 80 stations in all over the world. So Bangladesh also included in the game. Global network analysis of precipitation. And I sort of actually this is how it helps you see the model totally and where the depleted and where the most in this water in this rainfall are actually is giving the total information. The seasonal variation also here from from summer and winter. So and all the dry and wet seasons are here. This is the sterilizer. This is the tritium. Also the most tritium actually is this is in the upper part, not in the lower in the interior also. So only in the upper part, not in the pole. So this is actually as in Bangladesh what we study with the data actually. If you just look at this thing, this is the moisture control converters. The isolate actually the elements are controlling. So how the isolation in the rain are controlled by moisture so as well as by the atmospheric process. So second question is isolation, precipitation, interest in the time is still not. So here actually we make a study actually probably to 7 stations, but here I'm just looked at and giving the same information the 3 stations here. So they're the laboratory, and I sort of actually we just actually measure. Using the it's only the unit we use the farm meal here. So standard actually we use the Vienna standard mean ocean water actually. So this is the one of the drug we just look very quickly and the same this thing oxygenating and dex. The oxygenating is just giving some information where the depleted most. So 1 minute left. Yeah. Okay. Mostly as the computer. So these are the applications I sort of here. So daily actually this is the when I use the daily sample and the monthly samples here. So we get the correlation of daily scale guess and so from here actually we can say there is no actually relation in the amount effect. So it says like this. I'm just going very quickly. This is the things actually I'm the local metal model line. From you see this is from the winter for the summer. Actually the dry season value is for mostly the English value, and the wet season value shows it the more depleted value. So from this isolated information you get a lot of information that will help you to identify. So whether this is cycling is going on or secondary evaporation is going on or not. So all this is the monthly variation of the system. Now this is the picture shows the indicator moisture flux. So this is when there is a high oxygen in so there is a divergence, but when there is a convergence. So the more depleted actually oxygenating gives you the information of light. When you do the Hope-Muller diagram, so there's from this Hope-Muller diagram you can see interseasonal variation. So from this Hope-Muller diagram you can just look at this thing. This is the more depleted case, so the more rainfall, the more actually all our health and low health of the water it means so very convective activity is going here. So this even the common, we in the way of Bengal offer, so we just make we just actually try to we got a very good opportunity to actually measure this sort of value also here. So this is one of the isoscale we just did. So through this isoscale, we get very good information from the June, July. This is the monsoon actually the variation occurs actually on Bangladesh actually. So these are the key findings actually. I just told you everything before. The isotopic variable in Bangladesh is controlled by the large scale convective rather than the local rainfall amount. Air temperature and rainfall amount have less influence on stable isotopic precipitation rather than primary controls are thought to be the different moisture sources in Bengal. And the take home message, this is my last actually, this is my year, so this is very interesting here. So the present findings now groundwater and all study indicate the more regional sampling from the deep wells is essential to declare the source of the water as alternative. If you want to know the more and more about saline water, we need to know there's more sampling in the deep wells. And the second one is this is the most of the deep aquifers found free from the arsenic contaminants presently in our case. But in some cases, salinity may be the constraint. The salinity, the source of this is very much good tool to know the salinity sources. And the fourth one is this is the using the study from the precipitation. You stabilizing precipitation the capacity and quantity revealing the atmospheric processes. Atmospheric circulation is a reference tool and relevant theories are conducive to the interpretation of the precipitation stabilizing variation. So the last one is isotope techniques and hydrology provide precise scientific and local information to help guide decisions about managing water supply. So this is thank you very much to all of us.
Thank you. Thank you for nice presentation. Yeah. Now the floor is open for questionnaire. If you have any question, please.
Sir, no hand raising, sir.
No hand raising.
Yes, sir.
So, yes, I have one question.
Yes, sir.
How just convective activity
control
this environmental isotope? Is it possible to control or it flow over the area?
Thank you, sir. Actually, isotope we cannot control. Actually, we just from our using the isotope actually information. We just we have some information of where the convection is occurred actually, and the seasonality of where the seasonality variations is occurring, and even when the cyclone actually in the Pomin time when the very deep convection was there, so only the Pomin actually was passing through the Odisha. So otherwise, most of the cases cyclone actually in the Bay of Bengal. That was really difficult to take the samples, but we were very lucky at the time. So to the cyclonic activity, the cyclonic activities. I mean the deep convections and other things. So when the samples is properly collected, so then we can get a good information about the convections and other things. Even so, the rainfall pattern, whether static form and convection, we can make a classify also in short term actually. But we cannot control anything on the rainfall actually.
Sir, one more hand raising from Mr. Noyan Chandra Ghosh.
Sir, you have shown 3 types of water, where type 2 was 200 to 300 or 400 meters deep, and it was arsenic free but not rechargeable or no recharge. It was shown that 3,000-year-old aquifer. So is it environmentally feasible to extract those water, as it is not recharging anymore? Thank you.
Thank you very much. Very good question. Actually, no natural leakage. I'm just saying about the things that actually this is in this layer we say either acute or acute. When there is an acute, there is a chance of getting the leakage or operating the leakage due to pumping. So because erratic pumping might be sometimes very harmful or dangerous. So there might be the recharge, but that recharge is very little. They're almost nil, because when there is recharge, from that recharge, if the water, we just take the samples from that level, 230 meter, and we just compare the water with the shallow aquifers. If there is a similarity between the stabilizer, then you can say there is a water is actually getting included in the second aquifer. But there is a recharge. That recharge is actually not vertical. That is mostly the horizontal recharge is going on here. So that is a very slow recharge is going on. So that's why we are getting the old water, actually, the 3,000 years old water. So the water actually is getting mixed somehow from the pumping, but if the water actually, the mostly, I mean, 20,000 or 40,000 years old water, so there is a chance of no any particular recharge. Mostly this is there, the recharge is, there's a water recharge is from the very, the distance place. And most of it is in Bangladesh, is called the quantic water. And the water actually trapped during the interglacial time. This is from the geological information actually. So so what actually is one of the question here? If there is what happened actually if we just extract the water actually? So there is a chance of the groundwater mining. If we pump the so many use water, this is called over exploitation. If you do the over exploitation of the water from the deep aquifers more and more, so there wouldn't be any chance of the recharge in that area. So there will be a chance of the groundwater mining. So this is actually classification. This tells us so we for sustainability of the water, we should be careful on that. And sometimes what happens, the artificial recharge is being done in some country. That was actually started in our country a little bit actually in Dhaka, Warsaw, with the help of the Institute of Water Modeling. So on the experimental stage, they try to just show whether the artificial recharge is working or not. It is not particularly, it's not very good information we get from that actually. So
okay. Shefai, we have the time constraint.
Okay, thank you. If anyone have any question, then you will contact directly with Engineer Nasir Sahib. So thank you everyone. Now we are going to present our contributory papers. First contributory papers in environmental science is ensemble prediction of storm surge associated with cyclone Amphan using JMA-MRI storm surge model. SM Kamrul Hassan and Syed Jamal Ahmed. Who will present the paper? Is there anyone?
Thank you. Thank you, Session Chair Dr. Mahu and Co-Chair Dr. Mollik. I'm trying to share my screen. Can you see my slides? First slide?
Yes.
Okay. So, welcome to my presentation and good morning to everybody. And as time is very short for this type of presentation, so I hope it will finish within the time. So, title of my presentation already Dr. Mahbub said that ensemble prediction of storm surge associated with cyclone Amphan using GMA-MRI storm surge model. This is actually a collaborative work with Dr. Syed Jamal Ahmed of Dhaka University of Engineering and Technology, Gazipur. Actually, he is my supervisor. And this is the first ever effort to predict storm surge in ensemble mode. And the model which is used in this study is from actually MRI means Meteorological Research Institute, and it is one of the research institute of Japan Meteorological Agency. And we are using that model since 2010 onward. So in introduction part, we all of us know that Bay of Bengal is one of the region where frequently affected by storm surges, and on average 5 to 6 storm surges formed in this that is in Bay of Bengal basins. But the casualty is very high, more than 80% in this region, and that casualties is due to mainly storm surges. So to predict storm surge in this region, especially for Bangladesh coast, is very crucial for meteorologists of Bangladesh Meteorological Department. And in these basins, that means in Bay of Bengal basin and Bangladesh coast is very complex as it is very dynamical, and shallow bathymetry, long continental shelf, and convex, that means the cone type of coast, lot of shores and islands in this area. And low-lying, very low-lying area, coastal area. So this thing actually make very vulnerable in Bangladesh coast. And all of us also know that storm surge is actually an abnormal rise of sea level caused by two meteorological forcing mainly. One is pressure drop and another is wind stress over sea surface. So as I already said that there is two main forcing for storm surges. One is inverse barometric effect, that means for every 1 hectopascal pressure decrease, about 1 centimeter storm surge occurred. And wind stress is actually there is three things. One is storm surges proportional to the v square, that means wind stress square of the wind speed. Horizontal scale wind, that means the phase of the area, and actually the inverse of water depth, that means when storm surges come towards the, that means the cyclone comes toward the coast, it amplified the its sea level. So in BMD, actually two operational model is using. One is IIT IIT Delhi model, storm surge model, which is fully parametric. Parametric means it needs input like latitude or longitude of the, that means position of the cyclone, pressure drop, and maximum radius of maximum wind. This type of information is needed for IITD model, and same type of input, that is parametric input, also can be used in JMMRI storm surge model. But additionally, other model output, that means other NWV model output, also can be used in the JMMRI storm surge model. Actually, my intention is to use other NWV model and as well as ensemble members of WRF output. So this is the schematic diagram of a whole system. Actually, firstly, get GEFS, that means Global Ensemble Forecast System data. That is, in this case, I use 20 member of GFS data and run the WRF model for 20 times, and then each ensemble members subsetting, that means for running storm surge model, two forcing data needed. One is pressure and another pressure field, other is wind field. So all of us who are the WRF, we all know that there is 138 variables in the output of WRF model. But from that 138 output, I just set two variable. One is, in fact, three variable. One is pressure field, and another is U component and V component of wind. And that forcing is used to run the storm surge model, and also it also run 20 times. And Similarly, other model output can be used like ECMWF, GSM of JMA, that also can be used in this model. Recently in this model, World Tidal model also included in the recent version, which released in February. So this is the track of cyclone Amphan.
3 minutes left.
Yeah, and this is a model setup. And this is the actually the result of two input using two input. One is ECMWF and another is GSM. And ECMWF showing that red dot is the landfall position, and ECMWF showing the landfall is the left side of the actual landfall position, and GSM showing the over almost same as actual landfall position. And this is the storm surge generated by two input data, one is ECMWF and other is GSM. And in ensemble, I want to say something about ensemble. Ensemble is like that, is used slightly differ from actual observation, and make some set of data and use that data for run the model. And it is proved that using in ensemble of that all ensemble members, the result is better than a single run. So this is the storm surge at one point using ensemble, all ensemble members, but that was 20 ensemble members. So 4 points I already showing that. And finally, actually, this conclusion, MRI storm surge model can predict storm surge generated by Amphan very well, and simulated storm surge for different data sets showing different as the landfall position and wind speed is predicted in different values. In all cases, simulated storm surge was maximum on the right side. Normally it happened, and negative in the left side of the track. Simulated storm surge was close to reported or forecasted storm surge model. There is no surge gauge along Bangladesh coast, and it is the difficulties, and it is very difficult to actually compare with observation. MRI model is very potential for Bay of Bengal. Different GBP, that means big point values, and ensemble also possible by using this model. And the experiment actually done for model tuning. So this is my last comments, and thanks to all, and thank you. Anybody has any question, I can answer that.
Thank you very much, sir, for your nice presentation. Mahbub sir, আপনি কি আছেন?
Okay, thank you for nice presentation. Is there any question, anyone? So I have one question.
Yes, sir.
Just you informed that in the left side there is a surge is negative and right side is maximum. This is negative or minimum? Which one is correct?
Actually, sea level is down from the its original sea level, so it is negative, not minimum.
Negative surge is negative in a bucket.
Yeah, if you think that says there is a normal sea level.
Yes.
Then in left side, the surge is
negative.
Below the normal. So it is negative.
Below the. Okay. Is there any question? Anyone?
Sir, no question and no hand raising.
No hand raising. Okay, thank you.
Thank you all.
Our next presentation is assessment of heavy metal distribution and contamination in water and sediments of the Kaptai Lake, Bangladesh. Biplab Das.
Can you hear me?
Okay. You will present this.
Yes.
Okay, start your presentation.
Honorable teachers and delegates, Assalamu alaikum and good morning. At first, I would like to thank the Honorable Chair and Co-Chair to give me a floor. And special thanks to my PhD Supervisor, Professor Dr. Muhammad Dalal Hussain, Departmental Head, Department of Physics at JUET, and Dr. Muhammad Amirul Islam, Chief Scientific Officer, INSTARE, RMPD Shabbat Dhaka, and the honorable teachers are mentioned here from the Department of RNPD and RNCD. The title of my presentation, I am Biplab Das presenting our research work. The title of my presentation is Assessment of Heavy Metal Distribution and Contribution in Water and Sediments of the Kaptai Lake, Bangladesh. This is the outlines of my presentation. My introductory speech contains two keywords such as heavy metals in aquatic environment, sink of heavy metals. There is a typical photograph or scenario of lake pollution by heavy metals. Now I will try to say something about those two terms. Sediment reflects the status of aquatic environment. The quality of sediments also control the water quality in aquatic environment. By analyzing sediment, it is possible to determine the provenance, distribution, extent, and also the possible hazards of heavy metals in aquatic environment. Aquatic environment pollution by heavy metals has received global attention due to their persistence, abundance, toxicity, and long-lasting availability. Heavy metals are non-biodegradable. They are not removed from water as a result of self-purification. Once they are discharged into the water bodies, they are added to the sediment particles and accumulate into the water columns and finally into the food chain. Accumulation of heavy metals can be transmitted to the trophic level of food chain by resulting the breakdown of the natural balance of the ecosystems. Entrance of the heavy metals in lake ecosystem are caused by both natural and anthropogenic sources like soil erosion, atmospheric deposition, surface runoff, sewage treatment, etc. Now I would like to explain the reasons of this investigation according to these two keywords: Kaptai Lake, a unique water body, possible sources of pollution at Kaptai Lake. Lakes, due to their dynamic nature, receive contaminants from various sources, which affect also both the sediment and water quality. The heavy metal enrichment in lake ecosystem is considered hazardous because of bioaccumulation and toxic effects on environment and also the human health. As an important source of fresh water, habitats for different living organisms, as well as the recreational opportunities for the human being, represent lakes unique from different bodies of water. Kaptai Lake is the largest man-made freshwater lake of Bangladesh, which actually is the result of creating a dam on the Konasali River as a project, as a hydroelectric project.
Are you disconnected?
Sir, can you hear me? Sir, can you hear me?
Yes, yes. Okay, you will proceed your methodology and results because time is short.
Yes, sir. We are hearing. These are the objectives of our research. Samples were collected from 32 sediment samples were collected from 32 different locations, and water were collected from 10 different locations along the Kaptai Lake. total 9 heavy metals were determined in both water and sediment sample, where cadmium was below the detection limit in sediment sample. Different analytical techniques were used for elemental determination, such as research vector-based neutron activation analysis and atomic addition spectrometry. In sediment sample, chromium, iron, cobalt, zinc, and arsenic were determined by NAA. Nickel, copper, cadmium, and lead were determined by AAS. Whereas all the studied heavy metals in water sample were determined by AS. Samples were prepared individually for different analytical techniques. Facilities was used for neutron activation analysis. Gigamark 2 research reactor at Shabar, Dhaka. There are 2 photographs of Gigamark 2 research reactor. And the facilities for sediment analysis by AAS is NRCD, AR Shabar, Dhaka, and for water analysis is PCS, Dhaka. This is the result and discussion. To study the quality control of the analysis, the elemental concentration in reference material were determined, and finally it is compared with their certified value. It is observed that most of the elemental concentration are in good agreement with their certified values, which assures the quality control of the analysis. When the mean concentration of studied heavy metals in sediment sample are compared with upper continental cluster average values, it shows that zinc and arsenic was elevated. To assess the elemental contamination in sediment sample, in this study, we used some pollution indicators. Which indicate capitalate sediment is minorly enriched by zinc and arsenic. Another important indicator is the pollution index calculated by this equation. This result suggests the uncontaminated condition for the sampling areas. Another indicator is contamination factor, which indicate capital X sediment is moderately contaminated by zinc and arsenic, and all other sampling station for rest of the elements indicate uncontaminated conditions. PLI value suggests us the sampling station as 13, 19, 27, and 28 are deteriorated, and all other 2, 5, 7, 14, and 18 presents the baseline level of pollution. MCD values suggest us the very low degree of contamination at all sampling station except station 28, which indicate low degree of contamination. Pearson correlation matrix was calculated for the sediment sample in order to establish the relationship among the metals and their behavior. Positive correlation, strong positive correlations of iron, wood, and cobalt, zinc, and arsenic indicate the distribution of cobalt, zinc, and arsenic are controlled by the same factors such as iron oxyhydroxide and clay minerals. The strong positive correlations of cobalt with zinc and chromium and iron indicate they are typical anthropogenic sources, and poor correlation of nickel and copper with other elements is due to association of those elements with organic detritus. But the percent of contribution of some standard international guideline values along with the determined values for all heavy metals are plotted in this graph. It is observed that the mean concentrations of iron and lead are exceed some international guideline values, which suggest us the Kaptalik water is not safe for drinking or cooking. And this is the summary of my study. Elemental concentration of 9 heavy metals were determined. While it is compared with UCC, zinc, and arsenic show elevated values, different pollution indicators indicate the lake sediment enriched by zinc and arsenic. PLI value indicate the station 13, 19, 27, and 28 are deteriorated, and Pearson correlation matrix indicate the correlation and the origin of the studied elements in Kaptalik system. Thank you, sir, for your kind attention.
Okay, thank you, Biplov Das, for your nice presentation. Anyone, is there any question?
Yes, I have one question actually.
Okay, please.
So my question is actually the lake water and the lake sediment. I mean, particularly for the arsenic. So arsenic. You have performed the analysis. I mean, this is for the lake water or the lake sediment?
Sorry, this is lake sediment.
No, lake sediment.
This is not for water.
Not for water actually.
So actually what I want to know, so you just actually make a little bit some differentiate neuron activation analysis and atomic absorption spectrometer. So why didn't you just make analysis the arsenic particularly using the hydride actually? I mean, diluting the sample or some other, so many methods are here. So do you think this is the neutron activation is the more better or more authentic than any other chemical methodology?
Sir, it is more helpful for the sample preparation, such as in atomic absorption spectrometry, the sample were destructive. There is no destruction. And we used AS for some environmentally important metals such as nickel, lead, cadmium, or zinc, which cannot be determined by neutron activation analysis. So we will help with the AS.
Yeah, but actually, yes, but you have to. I think you have to, in order to ensure some comparison, because arsenic. I mean, this is one of the elements. You know, this is a little bit. You know, it might be contaminated to other water bodies or water actually. So there is a chance. So in order to, because you are getting the high enrichment factor. So in order to just, I mean, the more, I mean, sure or more better result. So or compare, you must actually, I think,
between neutron activation analysis and AS.
Yeah, AS.
Yes, sir. Yes,
you have already mentioned you have done some elements through the AS using the AS.
Yes, sir.
Okay.
Okay, thank you.
Sir, many hand raising from Dr. Noyan Chandra Bose and Dr. Suranjan Kumar Das. But for time constant, sir, you can say.
Okay, due to time short, you will discuss with Biplab Das over telephone other way, but because we are very delayed. So thank you everyone. Now our next presentation. So, but before starting our presentation, we'll inform everyone, next presenter, that because due to time shortage, within 8 minutes, everyone will try to complete your presentation. Next presentation is predictability of monsoon depression over the Bay of Bengal using weather research and forecasting model. Mohammad Abul Hussain, M.A.K. Mollik, M.M. Chaudhuri, Mohammad Abdullah Ilyas Akhtar, Syed Jamal Ahmed, and S.M. Kamrul Hassan will present the paper.
Yes, sir.
Mohammad Abul Hussain.
Yes, sir.
Okay, start. You will omit the introduction. You will omit the introduction, just objective methodology and results and discussion.
Okay. Assalamu alaikum. Good morning to all. I am Mohammad Abul Hussain, Assistant Professor, BCS General Education and PhD student at Department of Physics of Jamia University, Shabat, Dhaka. And here present Honorable Chair and Co-Chair of this session and distinguished guests, honorable participants, welcome to my presentation. The title of my presentation is Predictability of Monsoon Depression over the Bay of Bengal using weather research and forecasting model. Actually, it is a group work. I myself presenting the paper in front of you. Here, outline of the presentation, introduction, experimental setup, data used, methodology, condition of a monsoon depression, result and discussion, conclusion. I skip introduction. Here, seasonal distribution of depression over the Bay of Bengal during 1901 to 2018. Here, from the seasonal distribution of depression, we see 65.13% monsoon depression formed in the monsoon season, and 7.7% in winter, and 5.6% pre-monsoon, and 21.8% in post-monsoon season. Next, location of formation and track of the monsoon depression over the Bay of Bengal. Monsoon depression formed actually over North Bay of Bengal, over the head Bay of Bengal, over the head of Bengal, season trough of low formed and intensified into depression. Actually, normal track of the depression is northwestward, and a few of depression recurve and move northeastwards, and some towards the northward direction. Next, experimental setup, data used and methodology. That WRF model, I skipped it, and domain of the study. This is my domain area of WRF model. My NWP domain area is single domain, and horizontal resolution is 10 kilometer, and a central point of the domain is 23°9 latitude, 23 north latitude, and 90° east longitude. As data used, NSF high resolution global FNL analysis data on 1 degree in 1 degree grids covering the entire globe every 6 hours were taken as the initial and lateral boundary conditions, and the observed rainfall data of PMD and TRMF were used to compare the model predicted rainfall. Here the model setup, here WRF version was 3.9.1 and input data NSF FNL. I finally select after the sensitivity test, microphysics, Morrison scheme, cumulus physics, Kane-Free scheme, planetary boundary physics, Jens University scheme, and another default scheme. Synaptic condition of monsoon depression. At the synaptic condition, I skip that. Now result and discussion. Analysis of the mean sea level pressure. Model simulated the landfall center very well using defined initial condition, and it is remarkable that the convergence zone slightly varies with the lead time. And model simulated minimum central pressure is found at 52 TC of 11 June 2017 is about 987 hectopascal at 24-hour model run, and another 984 984 982 at for 48, 72, and 96-hour model run. And the model simulated center of the system at the time of landfall is about 20° north latitude and 90.2° east longitude. Here, the validation of 3-hourly model simulated of mean sea level pressure of monsoon depression of 11 June 2017 with PMD observed data of stations Chattogram, Cox's Bazar, Hatia, Kavupara, Kututia, and Teknaf. Actually, it is found from the 3-hourly model simulated mean sea level pressure is very close to the observed value of PMD with minor biases. It is also mentionable that model simulated sometimes overestimated and sometimes underestimated. Analysis of 8 hectopascal level wind flow. Here, it is found the model simulated wind flow distribution at 850 hectopascal level valid for 15 UTC of 11 June 2017 for 24 hour, 48 hour, 72 hour, and 96 hour respectively, based on the initial condition of 0 UTC of 11, 10, 9, and 8 June respectively. It is found that the cyclonic circulation lies over the southern part of the Bangladesh and adjoining area, and it is center of it is 20° north latitude and 90.2° east longitude. It is found that the model simulated wind speed is favorable for the intensification of the monsoon depression. Here, analysis of 500 hectopascal level wind flow, I skipped it because it is also same as 850 hectopascal level.
2 minutes left. শুধু ভ্যালিডেশন পার্ট দেখালেই হবে।
Okay. Here the analysis of relative humidity. The strong southeasterly flow transports a high amount of moisture in the order of 80 to 100% to the center of the southern part of the Bangladesh and surrounding area is important for cloud formation and rainfall process. Here the analysis of relative humidity and its vertical cross section. Here from the analysis is found 80 to 100% vertically extended up to 400 hectopascal level, and then 60 to 70% vertically extended up to 200 hectopascal level, which is favorable condition for cloud formation and later precipitation over this region. Here the validation 3-hourly model simulated relative humidity of 6 forestations. It is very close to the observed value of DMD. Here the relative bodicity at 850 hectopascal level, valid for PPUTC of 11 June 2017 for 24, 48, 72, and 96 hours based on the initial condition of 11, 10, 8, 9, 8 June respectively. Here it's found from the surrounding areas of the system center, the bodicity positive, which is very much supportive for the formation of deep convection cloud, and then here the analysis of reflectivity. Model simulated radar reflectivity is found 3 to 60 dBz. When the magnitude is greater than 50 dBz, it is associated with the severe thunder activity. Next, analysis of EM cave. The EM cave is found in the surrounding of the southwest part of the system is 200 to 2000 joule per kg, which is very much supportive for the formation of thunder activity and lightning process. And here the vertical wind shear. Surrounding areas of the system center, the area average vertical wind shear in the order of 8 to 20, which is very much supportive. With very much supportive higher positive value, it cannot be. For this higher value, the system cannot be intensified into the cyclone. And here the analysis of temperature at 2 meter height. The model simulated temperature at 2 meter height valid for PPUTC of 11 June 2017 for 24, 48, 72 hours and 96 hours respectively. From the analysis,
please go to the last slide because for time constraint.
Okay, due to the lack of time, I present overall summary of all cases like this, and then my conclusion is on the basis of simulation of motion depression of 8 to 11 June 2017, the following conclusion can be drawn. The model simulated pressure is very close to observation. It is found that the model simulated bodicity at 850 hectopascal level is in order of 1040 into 10 inverse 5 per second, which is close enough to the theoretical values. The model simulated vertical wind shear is in the order of 8 to 20 meter per second at 15 UTC of 11 June 2017 for 24, 48, 72, and 96 are model land. Model simulated radar reflectivity is found in the order of 30 to 60 dBz, where it's greater above 50 dBz is associated with severe thunder activity. Next, the model simulated rainfall amount of associated areas of sensible well compared with the data observed by Bangladesh Meteorological Department and Tropical Rainfall Measuring Mission. The convergence of strong southeasterly flow transports high amount of moisture, 80 to 100% from the Bay of Bengal towards the eastern and southeastern part of Bangladesh, which is supportive for extreme rainfall. All parameters simulated by WIF model are consistent to the observation. Finally, it can be concluded that the WIF model is capable to simulate and predict the motion depression over the Bay of Bengal and its associated rainfall over Bangladesh, even up to 96 hours advance. Thank you for listening. Well.
Okay, thank you for your nice presentation. Now it's open for question. Is there anyone?
No hand raising, no question.
Okay, I have one question.
Yes, sir.
I have one question.
Sir.
Predictability of monsoon depression. You will run the model when monsoon depression is formed. So for predictability of monsoon depression, when monsoon depression will form, we will need to start before at least 8 to 10 days. Is it possible to run this?
Yes, sir.
Have you run?
Yes, sir. No, sir.
Yes,
I only simulate. Simulate.
Only simulate, but not predict.
No, sir.
Not predict. But so if you need to predict, then you start before the formation. You start before the formation, the depression is formed.
Sir. Sir, I can predict from data collection from the NSEP FNL data.
Okay, I know, but my question is, because it needs to start, so since today is the formation depression, we know that there is a depression formed in the Bay of Bengal. Then I run the model. This is not the prediction. Prediction means when monsoon depression will form, so at least few days before to start the model run. Have you got this, or have you run the model before that?
I want to answer this question. Actually, it can be just is simulating the past historic depression, and you will use the result of the predictability of the WF model, so that even 10 days, 16 days WF model can be done. It can be, sir, and he is experienced the historic knowledge actually, so it is possible, sir. Thank you.
No, Mr. Mulli, that because there is a predictability, that's why I call. So for prediction, it needs to start before that time.
Yes,
96 hours before that time.
Okay, sir. It is very important because he used the predictability term. Okay, thank you, sir.
Okay, thank you for nice presentation. Now our next presentation is.
Thank you, sir.
Now our next presentation is sensitivity of microphysical parameterization scheme for the simulation of orbit rainfall event of 18th April 2050 over Bangladesh using WRF model. Mohammad Umar Farooq, M.A.K. Molli, M.M. Choudhury, Mohammad Abdullah Ilyas Akhtar, Mohammad Sadiqul Alam, S.M. Kamrul Hassan, and Mohammad M. Arif Hussain will present the paper.
Probably Umar Farooq, sir. Umar Farooq, are you here? Hearing me? Do you hear me?
Then you can present.
I can, but the presentation is not my answer.
Umar Farooq is not there.
I found him, but now.
Okay.
You can go
then we can move for our next presentation.
Okay.
Hydrogeochemical evaluation in deep aquifer system.
Sir, আসছে ওমর ফারুক আসছে স্যার।
আসছে, okay.
ওমর ফারুক শেয়ার করেন।
He's not connected now.
Okay, if he comes, then we will start next.
Malik bhai, with connected hoy nahi budhai.
উনি মনে হয় বানানো হয় না, সেটা পারতেছেন না।
পোস্ট লাগবে না তো, ওটা তো ওই যে ইয়া দিয়ে দিছে, তো ওরা তো লিংক দিয়ে দিছে, ওই ইয়া
শেয়ার করতে পারতেছে না, বললো আমাকে ফোন করতেছে এখন।
ও নাহলে তো একটা কাজ, যে ইয়াটা প্রেজেন্টেশনটা আপনাকে মেইল করে দিক।
হ্যাঁ, আপনি ফাঁকে আমাকে মেইল করেন, আমি এখান থেকে শেয়ার করব, আপনি শুধু বলবেন, ঠিক আছে?
হ্যাঁ রাইট, ওটা ভালো।
পরের জন্য দেখ। ওকে,
আচ্ছা,
আপনি মেইল দিন।
ওকে, next presentation, hydrogeochemical evolution in deep aquifer system of Kumilla, Bangladesh. F. Islam, A. Jahid, A. H. A. N. Khan, M. Monirujjaman, M. Q. Bhuya, M. A. Hassan, Sultana, and R. K. Mujumdar who will present this paper.
Assalamu alaikum, sir. Can you hear me?
Yes, yes.
Okay. I am Fahna Islam, working as a geologist in Isotopology Division, IST Arishabad, Dhaka. The title of my today's presentation is Hydrogeochemical Evolution in Deep Aquifer Systems of Kumilla, Bangladesh.
Kumilla bananta ki thik ache, spelling is okay?
Yes, sir. Now administratively it is written as KUMA, not CO.
From where?
No, because now presently it is okay, sir. Because yeah, previously it was CO, but now this is already from the ministry. Actually, they have given the instructions. Some of the district like a Chattogram, you gotta write the Chita. So Kumilla,
Chattogram, but Kumilla ki KU?
Yeah. Kumilla, Jessor. These are some of the spelling has been corrected by the government actually.
It is CU probably. It is CU.
CU.
The Kumilla to KU now. I know that this is Kumilla, not KU. Okay, you start.
Sorry, sir, I can't go to the next slide. Okay, here is the contents. Okay, introduction. As our present investigated aquifer system is confined to the deeper one, so it's expected that it is free from any anthropogenic contamination. So the localized geology of the aquifer and its overlying aqueducts mainly control its chemical composition. So I set my today's objective of my today's presentation is to deduce the mechanism that controls the groundwater composition. Okay. Here is the study area, Kumilla, marked as 14. Geographically, it is located in the central eastern part of Bangladesh. On the surface, it is bounded in its western side, Tapin, and in its eastern side, Tripura Hills. And physiographically, it is known as Tripura surface. Subsurfacely, it is composed of sequence of deltaic sediments, that is sequence of sandy and clay sections. Here, 3 aquifer systems have been identified, but our present investigated aquifer system is only confined to the deeper one. Here, 25 number of deep groundwater samples have been collected. All of are from deeper aquifer. Physical parameters were tested in the field, and measure ions, that is measure cations and anions of water sample were measured in a laboratory of Technical University of Darmstadt, Germany. Cations were analyzed by using ACE, and anions were analyzed using ion chromatograph. Now there is some discussion. Here we see the large spatial variation of hydrogeochemical composition of groundwater. Here EC varies from 288 microsiemens per cement to 5,640 microsiemens per centimeter. Salinity also varies greatly from 0.04 per ppt to 3.35 ppt. TDS also varies a lot. Here is the major ion concentration. Sodium is the most abundant cation, followed by calcium, magnesium, and potassium. In anion, fluoride is the dominant one, followed by bicarbonate, sulfate, and nitrate. Here is the coefficient correlation matrix. Except bicarbonate and nitrate, TDS shows strong and positive correlation with sodium, potassium, magnesium, calcium, chloride. sulfate. Okay. In particular, sodium and chloride show very strong relationship with TDS. That means it is a clear indication that the overall mineralization of the groundwater is controlled by these two ions, sodium and chloride. Okay, the elevated chloride and higher proportion of sodium related to other ions suggests that there is a possibility of dissolution of halide. Okay. Moreover, excess of chloride, it comes other than from dissolution of halide, that is the cation exchange process, because there is excess of chloride and there is a strong correlation between magnesium and chloride and calcium and chloride. Another potential source of sodium is dissolution of sodium sulfate and silicate weathering. Okay, groundwater in this study area has a higher ratio of sodium and potassium versus total cation, which indicates the silicate weathering. This high ratio also shows that silicate minerals might come into solution by the dissolution of plesioclase to kaolinite, montmorillonite, or gibbsite, etc. Okay, here is a diagram.
1 minute.
Okay, sir. Here is a diagram diagram of sodium and potassium versus total cations. All of the points show below the 1:1 ratio. That means it's silicate weathering. I have told also in my previous slide. Okay. Is another diagram. It also shows that most of the points fall into the zone of silicate weathering and evaporation dissolution. That is the combined effect of silicate weathering and evaporation dissolution affects the groundwater composition. Here is another diagram, also suggests the silicate weathering. Okay, the milligram equivalent ratio of sodium plus potassium divided by chloride suggests that the average value is 1.16. That is also suggests silicate weathering. This diagram suggests the evaporate dissolution because all of the points fall, not all of the points, most of the points follow below the 1:1 line. Okay. The calcium divided by sodium ratio is close to 0.16, and that is it also suggests it is silicate weathering. Okay. Other than the silicate weathering, calcium, magnesium comes from the dissolution of calcite and dolomite. Okay. Other than silicate weathering and dissolution of calcite and dolomite, iron exchange is another important mechanism that controls the groundwater composition. It is evident from this diagram. All of the points would plot along the line with gradient -1. That's just there is an ion exchange process. If we look for the chloroalkaline index, we see that 80% of the groundwater sample show positive positive alkaline index, and 20% show the negative chloroalkaline index. So in conclusion, silicate weathering is the dominant process influencing the groundwater composition, followed by the evaporate dissolution, that is calcium and magnesium comes from the dissolution of calcite and dolomite. Chloride and sodium comes from the halide dissolution, and silicates ion exchange also play a significant role in determining the groundwater chemistry. Thank you, sir.
Okay, thank you. Thank you for the presentation. And now, is there any question? Open for question. If not, then we can go on next slide.
I have one question, sir.
Okay.
I'm just only very small question. I'd like to ask the Farhana, this is the deep aquifer. So he didn't just mention what depth actually you have. I mean, the samples were taken.
Okay, sir. Greater than 130 meter.
Greater than 130 meter, how do you say this is, I mean, the deep aquifer, or maybe it might be, I don't know, maybe in Kumilla area, how do you say this is deep aquifer? Deep aquifer means actually it's more than that, maybe more than 200 meter.
Because there is no more beyond this aquifer or below this aquifer. This is the last one.
You didn't show any, I mean, the aquifer classification, or I mean, the hydrogeological cross sections, and that your study area. Actually, you must
actually,
show.
sir, part of my work, I cannot afford all of the slide. It's a small part of my work.
As you were just saying this about the, I mean, this is because this is very sensitive thing, because you are talking about the salinity. When the more saline cases there. So is there any chance, or there is is it a connect water, or maybe there is the, or you see this is the evaporate. I mean, the evaporation from the salts actually. But actually, yeah. This is how do you say? This is the maybe the recent water or old water or anything. This is study actually. You have done it when you were. This is not in when you are in isotope hydrology lab, or beforehand you did it.
So
before I say, okay, I understood that. Okay, thank you very much. But you must give the cross section of the, when you're showing any about the talking about, you must show the geological cross section. This is very much important.
I have to do that.
Thank you very much, Nasir bhai. Very interactive. Thank you very much.
Okay.
Thank you, sir.
Okay. Now our next presentation, just ES04. Sensitivity of microphysical parameterization scheme for the simulation of orographic rainfall event of 18 April 2015 over Bangladesh using WRF model. Will present Mr. Umar Farooq. Okay, start your presentation.
Okay, good morning to everyone. Probably I missed the presentation title. It is wrong. Okay. The actual presentation title is
this is not the presentation.
Yes, no, it is presentation, but the title is missing. My actual presentation title is Sensitivity of Microphysical Parameterization Scheme for the Simulation of Orographic Rainfall Event of 18 April 2015 over Bangladesh using WRF model.
Okay, start that one. This is not one.
Outline the presentation, introduction, experimental setup, data use methodology, resultant discussion, and finally conclusion. We know Bangladesh is a tropical country, situated mainly on the deltas of large river flowing from the Himalayas. Most of the areas are plain. Only northeastern and eastern part of Bangladesh is the hilly region. The orographic rainfall mainly occurred in the hilly region of Bangladesh. This is the mechanism of orographic rainfall. We know this is the core climate season of Bangladesh. Mainly summer season, or pre-monsoon season, rainy season, or southwest monsoon season, post-monsoon, and finally winter. We know orographic rainfall, when orographic rainfall occurred for some days over northeastern part of Bangladesh, the areas is affected by flash flood, damages the crop, injures the economy. So it is very important to predict the orographic rainfall for predict the damage of crops and lives. The slides is the special annual and seasonal observed rainfall calamities of Bangladesh during 1981 to 2018. Here it is found that the northeastern part of Bangladesh is experienced the highest amount of rainfall for all season and also annual special analysis. This is the monthly average rainfall calamities of Bangladesh. We know July is the highest rainfall month of Bangladesh. WRF model. WRF model is a next generation message scale numerical weather prediction community model. Data use and methodology.
Here I use NSAP high resolution global MNL data, 1 by 1 degree resolution, and 30 degree USGS geological survey data. Also, for validation purpose, we use I use BMD observation, ECMWF observation, and TRMM model data. This is the experimental setup of my presentation. Last part is the physics option. There microphysics use all microphysics use. That is 15 microphysics I used, and finally selected microphysics 17. Cumulus physics 1, PBL physics 1, surface physics 1, and long wave and short wave physics also on. Globular microphysics. Microphysics 1 is Kessler physics, Kessler scheme. This scheme is a simple unclouded scheme that includes the microphysical forces included are cloud water, cloud vapor, cloud water, and rain. The microphysical forces included are the production, fall, and evaporation of rain, the accretion of water conversion from cloud water, and the production of cloud water from condensation. Microphysics 2 linear scheme. 6 classes of hydrometer are included in this scheme. That is water vapor, cloud water, rain, cloud ice, tsunami, and group L. All parameterization production terms are based on linear 1983. And
Mr. Umar Farooq.
Yes, sir.
No need to discuss microphysics. Which one you discuss ball? You say that I use this one. No need to details. Go to the details. We have not enough time.
Okay, I use this 15 microphysics, and finally selected is 17 microphysics. That is the National Civil System Laboratory 2-moment scheme. This scheme is the 2-moment scheme, and hydrometer is cloud data, rain, cloud ice, tsunami, group L, and hell.
Okay.
Okay. Go to the result and discussion for
Go
time
to the
constraint.
result and
Also use another physics. This is the sensitivity of microphysics. To check up the sensitivity, I use a case of 30 May 2015, using based on the using of 00 ETC of 29 May 2015 data. So from the special analysis, all microphysics show the good result, but microphysics 17 is the best match to the observation. Also, I found from the time series analysis, microphysics 17 and of that are very close to the observation. Also, I use a root mean square error of all microphysics, but combination 12 I found the lowest error, that is 11.0 millimeter. The case study, the multi-cell cloud was developed over Sylhet and adjoining area, which passed over Sylhet region during 12 ETC to 1930 ETC. মোর ভাই রেজাল্টে যান, অন্য সেশন ওয়েট করতেছে, আমাদের অনেক পিছিয়ে গেছি। হ্যাঁ, from the wind flow it is clear that the southwesterly wind is blowing from the Bay of Bengal and it carries moisture, and it is banded to easterly by the friction of hill and all of its component affected. And from the upper wind flow, westerly flow is continue. So due to the conjugation of this westerly dry and cool wind and southwesterly moist wind, the cloud formation occurs over Sylhet region and heavy rainfall occurred. This is the analysis of vorticity analysis.
Also from the analysis of relative humidity, the moisture is found over the northeastern part up to 450 100 SP level, 450 SP level. Also, I use Cape and scene analysis. Also, I use thermodynamic diagram for predicting the orographic rainfall. The different indexes are shows that the conditions are favorable for forming the cloud and orographic rainfall.
Sir, Farooq, 2 minutes left. By 2 minutes, you have to finish your presentation.
This is the analysis of rainfall. From the special analysis, it is found that the northeastern part is the observed highest amount of rainfall. Also, the model also predict the northeastern part is the highest amount of rainfall. And from the 24-hour computational rainfall, it is found 48 hours and 78 hours model run is very close to the observation. But PRMM and ECW is the underestimated because of lower resolution. Conclusion, the NSL 2 moment microphysics scheme with temperature scheme and Yangshan University scheme option predicts best prediction of thunderstorm which pass over northeastern part of Bangladesh. The mean sea level pressure of Sylhet region is found 1005 to 1009 HPA, which is very close to the observation. Also, the model captured the southeasterly wind. Also, the vorticity of our northeastern part of Bangladesh at 50 HP level are positive and positive of magnitude 6 to 10 to 10 to the power -5 per second. Also negative, also 8 to 10 into 10 to the power -5 per second, which is the dominant for further advancement. The model prediction positive vertical wind shear also 10 to 40 knots. The RS also found 75 to 100% of Sylhet and adjoining area, which is the very close to the observation, and 40 to 8% moisture is extend up to 250 SP level, and 40 to 100 moisture is extend up to 600 SP level. The highest amount of moisture is the source of energy per point of air and ultimately cloud formation. Also, the Cape is found 400 to 800 joule per kg as at development, and the maturity state is found 800 to 1000 joule per kg or more. All thermodynamic indices are favorable for occurring cloud formation. So, Doppler simulated rainfall is overestimated by but close to the observation. Finally, the Doppler is able to simulate predict the orographic rainfall over northeastern part of Bangladesh reasonably well. Though there are some special and temporal biases in the simulated rainfall pattern. Thanks, everyone.
Okay, thank you. Just okay, if you have maybe no question there are, but I have one question.
Yes, sir.
I have one question. So you have predicted the orographic rainfall. What is the when maximum rain occur, and in when model simulated, how much time gap, and what is the space deviation? Observation কখন পাওয়া গেছে বেশি, মডেল কখন সিমুলেট করছে বেশি, এবং মডেল কোন জায়গায় সিমুলেট বেশি করেছে, অবজারভেশন থেকে কত কিলোমিটার দূরে?
স্যার, আমার মডেলের যে প্রেডিকশন সেটা 3 আওয়ারলি ইন্টারভ্যালে, ফলে আমি ওই মাঝখানের ইন্টারভ্যালের পয়েন্ট আমি করি না।
না, আমি জানি, বাট অবজারভেশন কখন পাওয়া গেছে সেটুকু বোঝা যাবে যে আমি এই সময় পেয়েছি। অবজারভেশন ওটা 3 ঘন্টায় ডিলে আছে না 6 ঘন্টা না 12 ঘন্টা ডিলে, আর কতটুকু ডিস্টেন্সে আছে সেটুকু আমি জানতে চাচ্ছি। যেহেতু অরোগ্রাফিক রেইনফল আমরা প্রেডিক্ট করতেছি, যেহেতু সাম বায়াসেস আছে, সেই বায়াস কতটুকু আর আমার কতটুকু রেইন হইলো সেটুকু আমার জানা দরকার। আমার কোশ্চেনটা হচ্ছে এটা।
স্যার, আমার যে অবজারভেশন হইলো 16 UTC তে।
হ্যাঁ,
16 UTC এই যে স্যার 16 UTC তে হলো মেইন রেইনফলটা যেটা অবজার্ভ হয়েছে সেটা
না না এইটা ফিগার দেখা দরকার না। আপনার বিএনডি অবজার্ভ করেছেন না যে এতটুকু রেন হয়েছে?
জি স্যার,
বিএনডি অবজার্ভ করেছেন ওই সময়ে ওই দিন কতটুকু সময় ম্যাক্সিমাম রেনটা যখন হয়েছে তখন কতটুকু রেন হয়েছিল, আর আপনার মডেল কি সিমুলেট করেছে?
রেইন হয়েছে স্যার ভাই ভ্যালিডেশন মানে কম্পেয়ার করছেন না মানে অবজার্ভ রেইনফলের সাথে 77 মিলিমিটার হইছে টোটাল 24 আওয়ার্স স্যার।
হ্যাঁ এর মধ্যে 24 আওয়ার্স কিন্তু একটা সময় তো ম্যাক্সিমাম হইছে।
ম্যাক্সিমাম হইছে স্যার 16 UTC তে।
হ্যাঁ আপনার মডেল কখন ম্যাক্সিমাম করেছে?
মডেলে ওটা স্যার ডিউরেশনের মধ্যে আছে যে 12 থেকে 18 এর মধ্যে মডেল দেখাচ্ছে।
হ্যাঁ তো কত মিলিমিটার সেখানে?
সেখানে যখন আমি 48 আওয়ার্স অ্যাডভান্সে রানতেছি তখন টোটালি তো ওইখানে ওইটা আর ভ্যালিডেশন করে দেখিনি, আমি টোটাল 24 আওয়ার্সে ভ্যালিডেশন করছি। তখন 24 আওয়ার্সে দেখা গেছে যে 89 মিলিমিটার আর 72 আওয়ার্সে 79 মিলিমিটার।
আর মডেল যখন ম্যাক্সিমাম যে জায়গাটা করলো সেই জায়গাটা আমার এক্সাক্ট পজিশন থেকে কতটুকু দূরে?
পজিশনটা ওরকম আমি আসলে ভ্যালিডেশন করে দেখি না। ওমর ভাই লোকেশনটা স্যারের কোশ্চেন ইজ ভেরি ফাইন, ইউ হ্যাভ টু ক্যালকুলেট দা লোকেশন এরর ফর মডেল এন্ড অবজার্ভ।
আমার তো দরকার এইটা, আপনি বলতেছেন যে আমার বৃষ্টিটা হবে খুলনায়, বৃষ্টিটা হইলো গিয়ে বরিশালে, আমার তো এটুকু জানা দরকার। আমার যদি প্রতিটাই ক্ষেত্রে খুলনার জায়গায় বরিশাল হয় তার মানে আমার এই 100 কিলোমিটার আমি ডেভিয়েশনটা ধরে আমি ক্যালকুলেট করতে পারি সবসময়, তার মানে আমাদের কিন্তু এটা জানতে হবে।
কিন্তু স্যার আমার মডেলের এই যে অবজারভেশন মানে মডেলের আউটপুট আছে এখানে এবং ওই অবজারভার
না আমি ওই ফিগার দেখতে চাচ্ছি না তো, আমি চাচ্ছি একটা অ্যাকুরেট অবজারভেশনটা হইলো আর মডেল কি করলো কতটুকু ডেভিয়েশন হচ্ছে আমার কিন্তু সেটা জানা দরকার।
কিন্তু স্যার আমি ওই যে টাইম ইন্টারভ্যাল এটা ভ্যালিডেশন করে দেখি নাই।
শুনেন এটা না, আপনারা যেহেতু ফোরকাস্ট করবেন, বিএমডি যেহেতু ফোরকাস্ট করে এগুলা, তার মানে এই জিনিসগুলো বিএমডি কে এগুলা একটু হ্যান্ডেল করতে হবে যে আমি যে মডেল বললাম যেটা হয়ে গেল তা না, জাস্ট আমার ডেভিয়েশনটা স্পেসটা কতটুকু ডেভিয়েশনটা হচ্ছে, টাইমটা কতটুকু ডেভিয়েশন হচ্ছে, প্রতিটা ক্ষেত্রে যদি এরকম হয় আমি কিন্তু ওইটাকে তখন আমরা একটা এরর হিসাবে ধরে ওটাকে আমরা শিফট করে নিয়ে আসতে পারি। কাজে এই জিনিসটাগুলো কিন্তু আপনাদের হ্যান্ডেল করতে হবে।
স্যার এগুলো আসলে ইন্ট্রোডিউস করা হয় ওই ওমর ভাই হয়তোবা করে কিন্তু এখানে করেনি। মূল বিষয় হলো স্যার মানে হাই অ্যামাউন্ট অফ রেইনফলের পয়েন্ট ডিস্ট্রিবিউশন ওই রকম মডেলের সাথে ওই রকম কিন্তু মিলে না, সেই জন্য স্পেশাল ডিস্ট্রিবিউশন দিয়ে ওয়ার্ল্ড ওয়াইড দেখানো হয়, কারণ পয়েন্ট ডিস্ট্রিবিউশন অ্যাড হয়, সেই কারণে আমরা বলি যে স্পেশাল ডিস্ট্রিবিউশন অফ রেইনফল ইজ বেটার রাদার দ্যান পয়েন্ট ডিস্ট্রিবিউশন। এই জন্য সাধারণত করে না ওমর ভাই আর কি স্যার। থ্যাংক ইউ স্যার।
আমরা যেহেতু ফোরকাস্টে যাচ্ছে, বিএমডি যেহেতু আগের চেয়ে ফোরকাস্ট কিছু ভালো দিচ্ছে, কাজে এইগুলো কিন্তু বিএমডি এগুলা করতে হবে যে আমার কেন এই এররটা আসতেছে আমি বলতেছি, আমার এটা মডিফাই করতে হবে। আমি বলতেছি না যে আমরা পারবো একদিন।
না নিশ্চয়ই স্যার, নিশ্চয়ই একদম ঠিক কথা স্যার।
মোহাম্মদ আব্দুল বাসিত, ওকে ইউ জাস্ট আস্ক দ্য কোশ্চেন। Abdul Basit, you
now someone unmuted me. So just আমার একটা কোশ্চেন, জাস্ট একটা কমেন্ট আর কি, যে আমরা আসলে যেহেতু সময় কম আমাদের, হ্যাঁ, যে আমরা আমাদের কনস্ট্রাকটিভ সাজেশন গুলো দিয়ে দিলেই বেটার আর কি, আমরা যাতে ডিবেটে না গিয়ে আমরা সাজেশন গুলো দিয়ে দিই যাতে আমাদের স্টুডেন্ট উপকৃত হয়, এটাই জাস্ট আমার একটা কমেন্ট, নাথিং এলস। থ্যাংক ইউ স্যার।
জাস্ট আমরা আমাদের এই সেশন শেষ, আমরা শেষ করতেছি। সবাইকে ধন্যবাদ এই সেশনে উপস্থিত থাকার জন্য। আমরা পরবর্তী সেশনে তাদেরকে শুরু করার জন্য অনুরোধ করছি। ধন্যবাদ সবাইকে।
হ্যাঁ, থ্যাংক ইউ।
জি মল্লিক ভাই।
থ্যাংক ইউ নাসির ভাই।
জি।
হ্যালো, আমাকে শুনতে পাচ্ছেন আপনারা? হ্যালো,
ইয়েস
স্যার, শোনা যাচ্ছে। ওকে, ক্যান উই স্টার্ট? ওকে, আসসালামু আলাইকুম and good afternoon. Let me welcome all of you in this session. Professor Jamil from Duet is with me as co-chair. I hope this session will be interesting. We have one invited talk and 6 contributory papers in this session. We shall begin with invited talk by Professor Mohiuddin, a young energetic researcher from the Department of Physics 2A. May I now request Professor Mohiuddin to present his talk entitled Magazines 5th Generation 2D Materials Go Beyond Graphenes. Professor Mohiuddin, please.
So thank you very much. Can you see or can you hear me?
Yes.
Okay. So assalamu alaikum. Thank you very much. First of I would like to thank the organizing committee of the BPS National Conference to invite me. So today I would like to talk about the magazine materials. The 5th generation 2-dimensional materials go beyond the graphene. So this is the outline of my talk here. I would like to say some few words regarding the 2D materials, because in this conference, most of the people are well-known to the 2D material. So then I would like to show some synthesis route for the 2D synthesis the magazine 2D material. And for the time constant, I would like to show you very exclusive application of the magazine material here. And finally, I will summarize and give some outlook of the magazine material in future. So the 2D material is come to the point in front for the discussion after the graphene rediscovered in 2004. You know, by this graphene rediscovered by the Jain and Novoselov. And after that, in 2010, they awarded the Nobel Prize for this graphene. And after that, the scientists are more interested in the graphene because the high mobility and high conductivity of this material. So, is there graphene is the only the 2D material? No, this is the 2D material world. Graphene is one of them, and there are many materials are competitive with the graphene. I would like to show you some magazine. One of them here, the very exclusive competitive member of the graphene, and I will show you the magazine. So, question is that why there is the distinct 5 different the 2D material you can see in the periodic table. The scientists have developed 5 groups, general 5 groups. You can see here the magazine. These are the 2D material: magazine, genes, TMD, nitrite, and organic material. So, question is that why I choose the magazine material? Because since 2014 in our group we have already been published 20 more articles on the max phase materials. You know, later I will show you the little bit detail about the max phase material. So because of the max phase material is used as the precursor to synthesize the magazine material, that's why, because our group, we have published the more articles on the max phase material under the computational related. So we like to one step forward to another, the next generation material is magazine. That's why I choose the magazine material here today. So I would like to show you the very simple synthesis route of the magazine 2D materials. So there are different the synthesis method for the 2D material synthesis. You know that we can divide it into 2 general methods for the synthesis of 2D material, top down and bottom up. So maximum the bottom up technique is used only the physical vapor deposition, also CVD method also. And the top-down method is included the mechanical explosion using CAP technology. People are well known with the positive technology to produce the graphene from the graphite by using the positive, that we can separate the single layer of the graphite, we can call the graphene. Another one is the liquid phase explosion method. We have the chemical synthesis or the green synthesis method. And we also, another method is the ion intercalation method. So, but now we can say, I would like to show you some very basic of the max phase material. Max means MAX. M means the transition material element. In there you can see the color of the periodic table. And A means the 9 to 16, the element of the periodic table. And X means carbon or nitrogen. So this max weight material has attracted much attention for the combined properties of this material, metal and ceramic. You can have the two properties in the max phase material. You can see here is the very big list. Already this max phase have already been synthesized or computationally predicted. So till now, more than 80 phases, this max phase material has already been identified. And if you consider the solid solution, for example, if you change the X, then if you have the minimum, means you have the much option to synthesize the max material, just changing the ratio. So in our lab, we have, I already told you, we have published the max phase material, the different articles of the max phase material, and you can see there the different phase of the max phase material: 211, 312, and 413. In this structure, very if I like to say it simply, you have the layer NX layer, and between two NX layer you have another A layer. We are interested on this point that we would like to remove this layer, how to remove this layer, and then you can get the next phase material to magazine material, two-dimensional material. So problem is that as the graphene, we cannot apply the mechanical expression technique to synthesize the magazine material from the magazine material, because the strong bonding between the M and A, I will show you the max with MAX. So a strong bonding between the M and A, that hinders this technique, hinders us to apply this technique. We cannot apply the mechanical expression technique as the graphene. So if you can show you here, this is the max weight NX2, and here the A layer, and this is you have the different NX layer, and between that you have the A layer. So, but another advantage we have, metallic bonding Na is weaker than the ionic bonding MX. It means if you apply the chemical synthesis or chemical etching method, we can remove this A layer very easily. So this the graph, this schematic show the summary of the synthesis of the magazine material. For example, we use the next material as the precursor. You know there is a different the MX layer, and between this MX layer you have the A layer like that. And if we apply the chemical etching, for example, if we apply the hydrofluoric etching chemical, then we can remove the A layer between the MX layer. And if we remove the A layer between, from the next phase material, then you have the mixing with the surface states, because you have used the already chemical, then you have the next phase material, but between the next material you have the OH radical or fluorine or oxygen. And after that, if you apply the sonication, then you can easily separate the next phase sheet. We can say the flake or magazine sheet. This is the very simple method. So, but the scientists always would like to avoid the hazardous HF chemical etching, because you know if you apply the HF type of chemical, then you have to follow the very strict protocol for the safety of the measurement. That's why people are discover another rule. If you use the HCl and lithium fluoride, then you can have also the same thing. You can have the very high quality magazine sheet. So this is the another rule. This is the another rule. You can apply the anyone. It depends on the skill, experimental skill. So if we can see here that TM shows that 2D sheet of the very clear 2D two-dimensional material, we can see in the TM measure. So here this slide shows that this is the how we can see the different CM image of the magazine material from the max material. Here use the max phase material, titanium aluminum carbide as the precursor, and we can get the magazine material, titanium carbide. And this is the max phase material, this is the magazine material. And of course, we have also used the solid solution, also the max phase material. And after that, we can have the magazine material also in solid solution. If we summary the word of the 2D material, then we can say the magazine is the largest 2D material family. Of course, you can see this slide shows that there are many magazine materials have already been synthesized, and many of them are computationally predicted, and many ordered or solution has already been synthesized and predicted also. So after that, I would like to show you some the exclusive example of this magazine material, and we are very interested to the energy storage, the material as the magazine material. Then I would like to show you very quickly to the optical property. If we can see the optical property of the magazine material, you can see the absorption peak of this magazine material. It means you have the more option to choose the material. It depends on your desired application. You can have the different option. You can choose the material if you whatever you have, you need depends on the absorption. For example, the titanium carbide is the well-known magazine material. It has the absorption at the near infrared region. So in this slide, you can see different color and different magazine material are commercially available in the market. And if you can use this magazine material at different application. So this optical property of the titanium carbide, we can use the cancer therapy. And in drug delivery, you can use the magazine material because, for example, this is the one example. You have the magazine material by in this synthesis method, and this magazine material, magazine layer, between the magazine layer, you have the gap, and this gap, your drug can accumulate it. This magazine material can retain your drug, and if you push this magazine material to carry your drug in the near the cancer affected cell, and after that, if you apply the laser of the NER, then the magazine material will absorb the NER region, the light, and it will be heated and kill the cancer cell. This is the efficient application of the magazine material in the photothermal therapy, and also the another superparamagnetic iron oxide nanoparticle of the magazine material are widely used in MRI and CT scan also now. So if we look at the mechanical properties, we are also this mechanical property of the magazine we can compare with the graphene. This competitor in two-dimensional world is competitor with graphene and also hexagonal boron nitride, because if these two well-known the magazine material, recently the scientists are synthesized this magazine material, and this magazine material has the 0.5 terapascal scale young modulus. This can be well compared to the magazine material. And of course, the panel shows that if with a single layer, if some single layer of graphene and single layer of the magazine material, we can compare the strength. We can attain that we can very much close to the graphene. We can compare also the magazine material with the graphene for single layer also. So another one most important application of the magazine in the fifth generation technology, because nowadays you use the credit card, you use the another card, and also simultaneously we use the mobile phone and also laptop. And this electronics material, it always emits the electromagnetic radiation. So to protect the body, we need the electromagnetic interference shielding to protect our body from this electromagnetic radiation. So magazine material is the efficient, the candidate in this fifth generation world, because if we compare in this slide shows the efficiency of the EMI shielding, efficiency of the magazine material. Here is the graphene. Here is the graphene, even though from the graphene you can fabricate the very thin layer of the magazine material, and magazine material shows the very large EMI shielding, and we can efficiently use this magazine material to shield the EMI radiation from our devices. And because another advantage of the magazine material, even by spray, by using the spray, you can deposit the magazine material on the chip in the credit card or other devices, and very easily we can protect our body from the EMI electromagnetic radiation. Optoelectronics application recently people published there. People are using the ITO based in solar cell material. Usually use the ITO based is the photon OLED, but magazine material shows the almost similar characteristics, optical characteristics of the ITO based. Then this is another efficient candidate in the renewable energy sources to use this magazine material as the different the IGO-based absorption material here. So now I would like to show you very exclusive the study of application of the maximum material in energy storage devices. This is one example. In 2016, more than 1,200 papers are published in this topic, and you can see from this pie chart, most of the portion is occupied in the energy storage device, because now the burning question in front of the scientists to search the efficient energy storage material, because energy can be produced the different source by using the different sources, but how to store the energy efficiently and mass level, and after that you can use this energy in your desired time. So before going to the energy storage, how to we use the maximum material in the energy storage material. Before that, I would like to show some very basic of the lithium-ion battery, how to work the lithium-ion battery, and how graphite is used for the energy storage material. You can see from this list, the lithium has the large electrochemical potential, for example, 3.09. And from the electronic structure, we can see only one electron in the outer shell. Okay, so in the metal structure, lithium is bounded in the metal. So if we can remove the lithium atom, somehow the outside, then after some very small energy, we supply the very small energy, we can separate this electron from the outermost shell, because it's loosely bound. Then you have the free electron and you have the lithium ion. And after that, if we can guide this electron and lithium ion somehow to go the original point again, then we can get the electricity, because movement of the electron is the electricity. So if we guide like that way, then this electron and lithium ion can accumulate, can meet the original point, and by this way we can produce the electricity. So that phenomena is used in the lithium-ion battery. Here's the lithium, and here the graphite to store the energy, and we can use here we use the electrolyte. So what is the method? Is that if you charge the battery, then what happened? This positive charge attract the electrons comes to here and store the graphite, and also lithium ion can penetrate with the electrolyte and store here. And if the charging, full charge condition like that, we can ride the hill, and we have the top of this hill with it fully charged. And whenever we discharge from the charge and we connect the load, then it's having that electron goes to these places, and lithium also can penetrate by the electrolyte and comes to original point. Like that analogy is
Speaker, you have 2 minutes.
Okay.
Please.
Okay, sir. Thank you. Get down from the top to bottom. And this is used in the practical cell. For example, here use the Tesla cell, and this mechanism is used in the Tesla car also. The problem is that people are searching how we can change this graphite with the more efficient material that can store the more energy. Now people are searching that if we can change the silicon to the graphite, then we can increase the cycle of the battery from 3,000 to 10,000. Then after 25 years, Tesla announced that after that 25 years, if we can achieve this goal, then after 25 years you can replace your battery, and this is a huge market. So now I would like to show you, this is the graphite, this is the maximum material. This maximum material has the advantage because it has the open space between the two layers, and it can accumulate the various ion here. And this is of course, this is the experimental result. We can, this maximum material can store the large energy, and this is the predicted result, the storage capacity of the maximum material. But in practical case, we can in maximum material, it has the larger than the predicted storage capacity, 410. Same as the graphene. Graphene has the 280 milliampere per hour capacity. It is the 75% of the theoretical capacity. So now we have the different in battery. You have the capacitance is the phase shift, and this, if we can use the maximum material, we have the schedule capacitor or super capacitor. It can charge very quickly. And the electrochemical also, the application, if we use the magazine material as the electrode, it has very efficiently we can use because it has the value larger than the recently. Nowadays, people are using the supercritical ruthenium oxide. So we have this another advantage. So I would like to summarize my the talk here. More than 50 magazines have been reported so far, and we have the much more option to synthesize. And also redox reaction in the magazine material is very useful for the energy storage devices. And also we can have the elastic property and mechanical strength. And this storage material, energy storage material is good for the magazine and another much more application. So the outlook of the magazine material, we can say these two, people are saying that these two material, monolayer, is very effective for the next generation energy storage material. And this M can be replaced by titanium, vanadium, and zirconium or scandium also. Now, so what we are doing here? Our department recently we have awarded the project, and we have taken the initiative to simulate the computationally simulated the well-known magazine material, and parallelly we have taken the initiative to synthesize this magazine material from the max-phase material also. So we have the strong group here, and we have the collaboration also different people from the different corner of the world, and we are always welcome the students to join in our group, and also of course we appreciate always the collaboration with our collaboration with us, and I would like to request all participants to request that a student they can join with us the postgraduate admission in the JUET. That is knocking the door. The deadline is 24/8. Thank you very much for your kind attention.
Thank you so much, Professor Mohiuddin. I am seeing that two hand raises. First, Professor Muhammad Abdul Basit.
Yes.
Please.
Okay, thank you very much, Professor Mohiuddin, for your nice talk.
Yes.
Can you please show me the slide 9 or 10?
9 or 10, right?
You kindly go there.
Okay.
So in your group, I am seeing one of my students. He is actually well trained on mechanical exfoliation.
Of course, okay. We are always looking for that people.
Yeah. So while you will do the mechanical exfoliation by sonication, will you do it by proof sonication or ultrasonic bath? My first question is. Second thing is that, and how you will control the energy actually, by controlling the power of the bath or by controlling the time of the duration of the sonication, right? So did you start it, or did you start any synthesis by this mechanical exfoliation? And I will get a brief idea about how much energy is required actually.
Okay, thank you very much for this question. So as far I know, from the father of this the magazine material, Professor Gogotsu, he said that during the sonication, they applied only very small heat. For example, sometimes they the 70-degree very short time. One answer is that they use the heat during the sonication for the very short time. And another question is that pro sonication is good. If you have the pro sonication, and then because if you have the direct sonication, you sonicate the long time. For example, some people say that 4 hours, some people say that 5 hours. For our case, it's very difficult to continue sonicate or observe the 4 hours or 5 hours. Then if we have the pro sonication in this technique, then it will be better, I think.
But there is a problem of probe sonication is there, because here the direct energy is passing there. So sometimes surface or some edges actually becomes different from the rest of the part of your sample, right? So that is actually a serious problem of probe sonication. So in that case, I may suggest that bath sonication, if the time duration is higher, but if it works with the bath sonication, right? Then that is easy to control and easy for your sample actually, and it is very cheap actually also.
Okay, thank you very much. Thank you.
Okay, most welcome. Thank you very much.
Thank you.
Okay, thank you, Professor Basit. Now may I request Muhammad Akhtar, please.
Thank you very much. Assalamu alaikum. Alhamdulillah, it is nice talk. So my question is that how can you purify this material? This is my first questions. Purification process, and second questions, which metal responsible for this redox properties for electronic system?
Your first question is that the purification, because we use the max phase material as the precursor. We recently ordered buy the max phase material. Of course, this is the mostly purified. And if we apply the etching chemical, of course, we have the much more surfactants for the surface and on the inside the layer also. So after the sonication, most of the researchers showed that if we have the experimental speed, there is no other interruption beside the mixing material, I think. But in the practical field, I think we have faced many more. I think this is right. You can say how to purify. So in this state, I can say up that one, the people are saying that if you have this, the etching and sonication properly, as the Professor Basit suggests that, then you have the very good quality mixing material. Another question is that, sir, I forgot what you say.
Regarding the electronic properties, which component is the most responsible for this structure?
This structure is electronic properties, of course, the redox reaction. If you would like to use this mixing material for especially for the energy storage devices, so these surfactants, for example, OH radical, or if you apply the lithium fluoride, you have the fluorine surfactants on the surface, and this surface can boost up the electronic property, store the more energy. But it is difficult to say how to maintain the quality. It depends on the experiment, of course. This depends on the experiment, and of course the maintenance strongly depends on the skill.
Thank you so much.
Okay, thank you so much, Professor Mohiuddin.
Thank you, sir.
Okay. Let us proceed for the contributory papers. First, I request to present performance optimization of TCO-less back contact dye-synthesized solar cells utilizing iodine and polypyrene sensitizer based on cobalt electrolyte. Mohammad Jaman Mullah.
Thank you, sir.
Okay.
Am I audible?
Yes.
Oh, thank you, sir. And thank you all for being present here. Now I will be talking about that is performance optimization of TCO-less back contact dye-synthesized solar cells utilizing indoline and porphyrin sensitizer based on cobalt electrolyte. So first, let me start with the question: why dye-synthesized solar cell? Recently, we know that dye-synthesized solar cell has got its main attention from material scientists around the world because they are very simple in its structure and they can be fabricated in normal ambient conditions, and they can provide low manufacturing cost. They are very much cost effective because they can produce the very competitive efficiency. They can be printed on flexible substrates, and they work efficiently on indoor light as well as at wide angles. However, to be cost-effective outdoor applications by these photovoltaic devices, three important combinations are to be regarded. One is high efficiency, low cost, high stability. All these three things have to be improved simultaneously. Then, if you analyze the production power of devices utilizing this dye-sensitive solar cell for 1 megawatt peak per year, reported by Kuhn et al. In 2007, you can see that running cost contributes 40%, TCO plus 16%, various materials 14%, steam printable paste contributes 14%, investment cost is 9%, and die cost is 15%. But if the production is increased from 1 megawatt peak per year to 4 megawatt peak per year, you can see the cost, especially by TCO glasses, increases mostly from 16 to 24%, which is the stumbling block for commercialization of dye-sensitive solar cells. So to make it more cost effective, we know that in normal traditional dye-sensitive solar cell, two TCO glasses are utilized. That is one in the counter electrode side, another in the quantum electrode side, that is of titanium oxide test. This front electrode TCO glass is replaced in our structure by metal mesh to make it more cost effective. And you can see that the metal mesh is situated at the back side of this titanium oxide film. Electrons are collected through this back side of this metal mesh. So device is named back contact dye-sensitive source. And basically, we know the working principle of dye-sensitive solar cell, like upon photo excitation from say incident sunlight, that the dye gets excited from HOMO to NOMO level following an electron injection into the conduction gun of titanium oxide semiconductor film, which then travels towards the external circuit through this TCO glass. And consequently, the dye is oxidized, and the oxidized dye is regenerated again by electron donation from this cobalt-2 species. Then cobalt-2 species, after donating electron, oxidized to cobalt-3 species. This cobalt-3 species travels this electrolyte layer to the counter electrode, and it is reduced back to cobalt-2 species by electron donation from through this platinum catalyst. And if you see the zoom in view of this titanium oxide stained with the dye, you can see that dye molecules are say attached to this titanium oxide film. The thickness of the titanium oxide film can be from say 5 to 20 micron, and the particle size of this titanium oxide film can be varied from 20 to 30 nanometer. Here is the fabrication process of this dye-sensitive solar cell. You can see that first titanium oxide is placed, screen printed over the metal mesh by screen painting technique. Following its baking into the furnace at 450 degrees Celsius for 30 minutes. After the say sintering flexible metal mesh is dipped into the dye for optimum dye absorption. The device is assembled like first platinum spartan F2 glass is taken over which PTFE film is placed to soak the electrolyte. Then above this electrolyte layer, we place the titanium coated metal mesh. To hold this metal mesh, we use normal slide glass. Then device is sealed after inserting the electrolyte from this capillary tube. And you can see this our TCLS structure. You can see the metal mesh at the top side. Because of its flexibility, it can be bent in any direction as per required. So this is the one benefits of this structure. And we know that there are some recombination process in DSC. Say electron can recombine from the bare metal mesh as well as titanium oxide to the electrolyte species in the electrolyte. So then to suppress the back electron reaction in one, we use thin layer of titanium metal by spartaning process from the both sides, so it is properly protected by this thin layer of titanium film. And you can see that we can block the back reaction from this metal mesh electron to the electrolyte species in the electrolyte. At first we use D205 dye, and we can see the absorption spectrum of this dye from 350 to around 620 nanometer region. And we utilize different thickness of titanium film to protect the metal mesh, 120, 240, 360, and 480 nanometer. And if you see the IB curve, we can see device with 240 nanometer shows the RJSC and DSC, and as compared to other thicknesses of. And for this improved efficiency with this 240 nanometer can be understood from this dark current. We can see that dark current is lowest for device with titanium film protected metal by 240 nanometer is lowest. That means charge recombination is less. Better conversion efficiency here. So then to increase the efficiency, we utilize different nanoparticles of titanium oxide with 30 and 15 to 20 nanometer. We can see that In this case, we utilize a dimixture of D131 and 205, D205 with 1:1 volume ratio. You can see device with larger particle of titanium oxide with better conversion efficiency, DOC and JSC as well. And that is well reflected from this IB curve. And the reason for this improved efficiency can be understood from the CIS measurement. You can see that high electrolyte interface shows lower resistance for device with larger particle of 15 to 20 nanometer. And ion division resistance also decreases utilizing this 30 nanometer particle size. Because we know that cobalt has diffusion limitations because of its larger and bulkier size. So diffusion enhances because of this larger particle as compared to smaller particle sizes that provide the larger surface area to give better diffusion. So in this case, we realize that the larger particle size is better for cobalt electrolyte. Then you optimize the thickness of titanium oxide film to get the even better conversion efficiency utilizing porphyrin sensitizer that has large optical window as compared to our previous 131 D205.
Your speaker, you have 2 minutes.
It has large optical window from 350 to 700 nanometer region. And if you see the IB characteristics, we can see the device will vary the thickness from say 8 to 23 micron. 8 micron, 10 micron, 15 micron, and 23 micron. And here we can see that the 10 micron shows that it's the highest JSC as compared to other devices with lower thickness as well as high thickness. And JSC also followed the same trend of this JSC. And if you see the thickness variation with the efficiency, you can see initially the efficiency increases with increasing the thickness of titanium oxide from 8 to 10 nanometer, but beyond 10 nanometer with increasing the thin film thickness of titanium oxide film, the efficiency decreases. The optimum thickness of titanium oxide film was 10 micron to give the better auto conversion efficiency as well as DOC and GSC that we can see from this table. So finally, we can see the same images of this different titanium oxide film. The paste was coated, and we can see that these all the thickness variations are same images of 8 micron, 10 micron, 15 micron, and 23 micron. So in summary, we can say that TCLS back contact dissociated solar cell employing cobalt electrolyte was successfully in layer of titanium metal protecting the sus mesh from both sides, and by utilizing titanium oxide with comparatively bigger particle size of 30 nanometer from our previously reported 3.5% efficiency as compared to the smaller particle size of 15 to 20 nanometer, and obtain enhanced photoconversion efficiency due to lower resistance of the observed at the tier 2 dielectrolyte interface, going to its larger particle size of nanoparticle titanium oxide film. And to enhance the efficiency even further, we utilize porphyrin sensitizer because of its large optical window to harvest enough photon. And then we saw that the tier 2 thickness of 10 micron was best to give the best conversion efficiency of 5.26 as compared to our previously reported 4.84 efficiency. So thank you all.
Thank you, Mohammad Jamal Mullah. Only one question we can take from Professor Bashir.
Okay, thank you, sir. Thank you, Jamal Mullah, for your nice presentation. Just, you know, the conversion efficiency largely depend on the reduction of the recombination rate of charge, electron charge pair, right? Yeah, so you said that your charge recombination rate was reduced, but without performing any time dissolved photoluminescence spectroscopy measurement, or even just to a less extent without any steady state photoluminescence spectroscopy measurement. How did you predict that your recombination rate was reduced? Did you do those experiments, or any is there any other way?
Thank you very much for a nice question. Actually, we did the dark current measurement only as compared to other measurements. You can see that dark current is lowest for the device with the 240 nanometer thickness of titanium film as compared to other thicknesses. So dark current is nothing but the leakage current. So if you can reduce the dark current, that means leakage currents are also suppressed. That means the recombination is suppressed.
That is actually a very indirect measurement. Just I will suggest that this is very nice work actually, and I think it would be very nice if you could do the time resolved photoluminescence spectroscopy and see.
It could be measured by that technique also.
If you can exactly quantify the recombination rate, some other people can do the theoretical prediction by using your experimental data.
So in that case, we need
local
so,
researcher.
So,
Even if you want to do, did you do this work from Bangladesh?
No, from Japan.
From Japan, okay. So it's okay. Okay, thank you.
Welcome.
Okay, thank you so much, Mohammad Jaman Mullah. Now I request
thank you, sir.
Present the next contributory paper by Ruma Parveen, growth and characterization of lithium cobalt oxide single crystal for the application of all solid-state lithium-ion batteries. Ruma Parveen, are you there?
I'm here.
Okay. Just start.
Just a minute.
Are you facing any problem?
Yeah.
Ruma?
Can you see my screen? Share screen?
No. Is there anybody here to help her?
You have to click on share screen, the green share screen button,
Yes, sir. I am sharing.
and then select.
Okay.
Then select the appropriate screen. That's important.
Yeah. Sorry. Okay.
Yes, we can see.
Now okay.
Okay.
Okay. Sorry for my late. Thank you for giving me a chance. Assalamu alaikum. I'm Ruma Parveen. I'm going to present my PhD research that has conducted Center for Physical Science and Technology, University of Yamanashi, Kofu, Japan. And title of my today's talk is Growth and Characterization of Lithium Cobalt Oxide Single Crystal for Applications of All Solid-State Lithium-ion Batteries. Here I have shown the outline of my presentation. First, I will explain why I am interested to grow LCO single crystal. Then I will show you some previous reports, results on the growth of lithium cobalt oxide single crystal. Then I will show some experimental result that ephemeral tilting effects on growth of lithium filament shape on the growth of LCO single crystal. And finally, I will show the growth of a larger diameter, that is half-inch diameter single crystal of lithium cobalt oxide. And then I had the design of next generation all solid-state lithium-ion battery using my grown LCO single crystal cathode. And at the end section, I will explain the social significance of the research. So here I have shown the reason behind the research of LCO single crystal. Actually, lithium cobalt oxide is a cathode material which is commercially used in lithium-ion battery. So electrochemical properties of the cathode material is important. So for this reason, I have shown the electrochemical properties of three classes of cathode materials: the layer structure, and olivine type of cathode materials. You can see that the theoretical specific capacity is higher of layer cathode material compared to the spinel and olivine type of cathode material. But the practically achieved specific capacity is low compared to the other type of cathode material. At present, in lithium-ion battery, lithium cobalt oxide polycrystalline material is used as cathode material, and probably you know that in polycrystalline material has a grain boundary, and this grain boundary acts as defect, and that affects the true intrinsic properties of materials. And another properties of polycrystalline material is it shows isotropic properties. But in the case of single crystal, there is no grain boundary because the atomic arrangement is periodic, and it gives true intrinsic properties. And these true intrinsic properties is precious for industrial and technological applications of materials. And another important advantage of single crystal, it has anisotropic conductivity. So it in different direction it shows different properties. And according to high anisotropic conductivity in lithium cobalt oxide single crystal, if we prepare lithium cobalt oxide single crystal thickness perpendicular to the c-axis due to high anisotropic conductivity, so it is expected to enhance the capacity of lithium-ion battery. So here I have shown some previous result on lithium cobalt oxide single crystal different technique, transport technique, and FZ growth technique, and also TSFZ growth technique. And you can see that in all the cases the diameter of the grown using crystal is small, that is limited to the 5 millimeter diameter. But for practical and industrial application, half inch diameter single crystal is strongly required. But up to now there is no, there has no reported data. So my goal was to grow high quality, larger diameter, that is half inch diameter single crystal, and design of next generation of solid state battery using the ASU single crystal cathode materials. So here I have shown the experimental section of the TSFZ, that is traveling solvent floating zone technique. First starting material was lithium carbonate and cobalt oxide powder. So I mixed lithium carbonate and cobalt oxide powder in stoichiometric ratio, and then dry mixing, and then calcination process, then preparation and feedback sintering. And here excess solvent was and then crystal and then characterization. You can see the furnace of the crystal, and here shown the schematic the growth. Actually start the polycrystalline ratio and then attach solvent, made the
Please unmute.
We have lost Roma. Oh, she's back. She's back.
Roma, we can't hear you.
Please unmute. Roma.
Please unmute.
Sorry, you can see that at 10 degree tilting condition, convexity is lowest. So slightly convex interface shape is in that the lamp power was lowest at 10-degree tilting condition. So 10-degree tilting condition is the best for the growth of 7 millimeter diameter single crystal. And
What is happening here?
maybe in it. Now, okay. Then I have studied.
Please go first. Your time is almost over.
The effects of, so maybe net problem.
You have only 2 minutes. Please.
Okay. Then I have studied of solvent amount, and you can see that in the case of 1.1 gram solvent amount, the grown crystal was stable compared to the 0.8 gram. So optimum amount of solvent for the growth of 7 millimeter in the single crystal was 1.1 gram. Then I have studied the effect of mirror tilting. So you can see that 0, 5, 15 and 10 degree content is the best position, because in that tilting condition the molten zone was stable, but in the other case there was no molten zone was not stable due to the contact problem. And here I have shown the effects of the lamp filament shape, because when we large diameter single crystal, stability is important, because when we want to grow larger single and contact occurs. So we need efficient heating zone. So cylindrical filament type lamp is effective for the growth of larger diameter single crystal, because in the case of cylindrical type filament shape, lamp filament length and filament width is heating efficiency and also focusing condition was central in the cylindrical filament type lamp. And I have also studied the effects of the excess lithium content to the stoichiometric ratio for the growth of larger single crystal. And you can see that in the case of 2 mole% excess lithium content, the molten zone to the other condition, because when 5 mole% excess lithium content was used, the crystal surface was dark, because due to the deposition of excess lithium oxide on the crystal surface. When 3 and 2 mole% excess lithium content was used in the stoichiometric feed rod, then contact problem was occurred. So the molten zone was not stable. So for the growth of 10 millimeter single crystal, optimum condition was found at 2 mole% excess lithium content. And finally, I have tried half inch diameter single crystal, and finally success to grow half inch diameter that is required for the lithium ion battery. In the case also, in the case 3 mole% lithium carbon content, the molten zone was stable compared to the 5 to 8% lithium content. I'm using my grown single crystal,
Time is over. Please show your concluding remarks.
So in the case of larger single crystal, diameter single crystal, the capacity was enhanced, that is 145 milliampere hour per gram, but at present commercially lithium ion battery capacity is lower. So if we use the single crystal cathode in lithium ion battery, so capacity enhancement is possible in my research. And also I have tried to design almost all solid state battery, because when we use leak as inside, the leakage problem and firing may occur. So partition So when we use gel as electrolyte, so I prepared almost all solid state battery using gel electrolyte, and my single
Please go to your conclusion slide. Please go to your
but all solid state battery is not succeed due to some problem, and this is my conclusion. Yeah, this is my conclusion slide. So again, ion battery can be used in the medical section because capacity is high, it is small size, and it's safety. So in heart pacemaker and in headphone and hearing aid, we can use my designed lithium-ion battery. And I have also applied for Japanese patent because first time we confirmed that lithium single crystal is possible to use in commercial. So thank you for your attention, and sorry for my later.
Thank you so much, Rua Parveen. As time is very short, I can only take one question from Professor Dr. Saleh Hassan Naqib. Please.
Thank you, Professor Farukudjaman. Ruma, it's nice to hear from you. It's an interesting talk. I just have two very short questions.
Thank you, sir.
Yeah, nice to hear from you. Is there any epitaxial growth? I mean, the growth direction, does it have any relation to the crystallographic axis? For example, your growth direction, is it related with the c-axis, or what is the direction of the growth with respect to the crystallographic axis?
Yes, sir.
Yeah, so
this crystal direction is perpendicular to 0, 0.
Oh, okay. And the second, yeah, and the second question is, in this traveling solvent floating zone technique, sometimes you have problem with stoichiometry. Have you checked the stoichiometry of your crystal? I mean, the nominal composition is lithium to cobalt.
Yes.
You have checked your stoichiometry.
Ratio.
Yeah.
Yes, sir. From XRD data, as I have checked stoichiometric ratio using XRD. Yeah, but here.
You can use inductively coupled plasma method.
First, we have checked the spectral ratio and then try to proceed.
Okay, I'm not sure how X-ray will give you the correct stoichiometry. Anyway, okay. Okay, thank you.
Okay, thank you so much, Professor Naqib and Ruma. Now I request to present the next contributory paper, effect of vanadium substitution on structural, magnetic, and transport properties of nickel zinc cobalt tride. MD Hussain, are you there, MD Hussain?
Yes, sir.
Okay.
Now I start, sir?
Yes, you can.
Welcome to the presentation. I am MD Dulal Hussain. Today I would like to talk about effect of vanadium substitution on structural, magnetic, and transport properties of nickel zinc cobalt tride. Outlines of my presentation, introduction and motivation, objective of the present study, sample preparation methods, characterization process of the study sample, results and discussion, conclusions. First, I introduce introduction and motivation. Ferrites are used widely in electronic devices due to their high saturation, magnetization, high resistivity, low magnetic losses, mechanical toughness, chemical stability, and their low cost. High saturation magnetization with high frequency stability in an important requirement application where low coercive field or high permeability are the critical parameters. Nickel zinc cobalt mixed ferrite has been used in different electronic areas due to their enhancement electrical properties.
But the main problem is the reduction of electrical resistivity, that the increase of ET current. To increase the resistivity containing the high magnetization is the main challenge. The properties of ferrites can be modified by variation of composition methods of preparation, substitution, or addition doping. Vanadium substituted nickel, zinc, cobalt ferrites are attracted considerable attention for handling magnetic and electrical properties. Objective of the present study: preparation of vanadium substituted nickel, zinc, cobalt ferrites by the solid state reaction technique. Study the effect of non-magnetic vanadium substitution on structural magnetic and electrical properties of above ferrites as theoretical and experimental point of view. Scientific and technological impact. It would offer a new knowledge to find out optimum composition, centering temperature for high magnetization, high permeability, high resistivity with minimum magnetic loss factor. It would offer a new direction for more suitable future memory device materials and nanoscale spintonic device applications. Our sample prepared by solid state reaction technique. This is a flowchart of sample preparation. Final product of the such as pellets and toroid shape are prepared hydraulic press. Our sample are characterized structural analysis, morphological analysis, magnetic analysis, and electrical analysis. Now I discuss result and discussion. Structural analysis by XRD. This is X-ray diffraction pattern. All the sample confirm the formation of single phase cubic spinal structure. Lattice constant and crystalline size are calculated from 311 peak. Lattice constant and crystalline size decreases up to 0.10, and then increase as the increase of vanadium content with similar manners. Morphological analysis. The grain are formed over surface background. The grain size decreases with increasing vanadium content up to 0.10, and then increase at higher content, whereas porosity increases with increasing vanadium content. The decrease of grain size, might be due to the mechanical stress of the smaller ionic radius of vanadium compared to iron. This is a Raman spectra curve. All the samples show five Raman active modes: 3 F2Z, 1 EZ, and 1 A1Z. First F2Z, EZ, and A1Z come from tetrahedral side. Second F2Z and third F2Z comes from octahedral side. This is FTI spectra of the spectra curve. All the samples exhibit two major vibrational bands. Higher vibrational band consists tetrahedral side, and lower vibrational band consists octahedral side. This is a applied field dependence magnetization curve. So saturation, magnetization, magnetic resonance, and coercivity calculated from this curve. All these values decreases with increasing vanadium content. The narrow hysteresis loops assure the soft magnetic nature of all the samples. This is temperature dependent magnetization curve for the Curie temperature and the exchange interaction calculated from this curve. Curie temperature decreases with increasing vanadium content. Curie temperature shifts towards the lower temperature as the increase of vanadium content. As a result, reduces the strength of exchange coupling constant. This is frequency dependent permeability. Permeability curve. Permeability decreases with increasing vanadium content up to 0.10 and then increase. Frequency permeability follows the globus duplex relation. Permeability depends on saturation, magnetization, grain size, and anisotropy constant. The relative quality factor calculated from this equation, and relative quality factor increases with increasing vanadium content. The higher relative quality factor obtained, the higher vanadium concentration. This is frequency dependent dielectric constant and AC resistivity. Dielectric constant decreases with increasing vanadium content, whereas AC resistivity increases with increasing vanadium content. The dielectric constant is inversely related to AC resistivity. The dependence of dielectric constant, the resistivity on contents can be explained by assuming two mechanism. Grain of growth conductivity are separated by the grain boundaries of high resistivity. This is temperature dependent DC resistivity curve. DC resistivity increases with increasing vanadium content. DC resistivity decreases with increase in temperature, confirming the semiconducting nature of all the study sample. DC resistivity increases with increasing vanadium content. As a result, reduces the ED current loss, and follow this equation. Finally, the conclusions. XRD pattern reveal that vanadium doped nickel zinc cobalt ferrites are found to be single phase cubic spinel structure. The formation of spinel cubic ferrites are also confirmed from Raman and FTR spectra. The values of lattice constant indicate the shrink of cubic cell with vanadium doping due to the smaller ionic radius of vanadium ions than that of iron ions. FESCM images show the distribution of grain where the average grain size is found to be decreased all the vanadium contents. All samples show soft ferromagnetic nature. Saturation, magnetization, and coercivity decreases with increase of vanadium substitution due to non-magnetic nature of vanadium. The initial permeability of the study sample is followed to globus duplex relation. The Curie temperature decreases with vanadium substitution. As a result, reduces the strength of exchange coupling constant. The electrical resistivity and dielectric constant are strongly influenced by the vanadium substitution. The enhancement of electrical resistivity with vanadium substitution in nickel zinc cobalt ferrites are observed, which can be lowering of the ED current loss. This suggests the vanadium substituted nickel zinc cobalt ferrites can be more suitable future memory device materials and nanoscale spontaneous device applications. Acknowledgement. Thank you very much for kind attention.
Thank you, Mr. M.D. Hussain. I can just take one question from Farhad Said.
Yes, sir.
Please unmute.
Yes, sir.
Farhad Said, can you hear me? Unmute yourself.
Hello. Now I can. Yeah. Thank you very much for giving me opportunity to ask a presenter a question. I would like to see the Raman and FTIR spectra slide. Can you please go to the Raman and FTIR slide? I'm not expert on it. Just I like to know. Can you?
Yes,
yeah. So you use same sample both for Raman and FTIR, I guess, right?
Yes, sir.
In
the Raman spectra curve and FTIR spectra curve.
So in here, nitrate and carbon nitrate. So is it residual inside your sample? Is it beneficial or detrimental for your sample? In FTIR, I can see some functional group. Is it beneficial?
FTIR, sir, mainly the FTIR and Raman spectroscopy come from the extrastructural.
I understood, but I can see some peak which is coming from nitrate, NO3 and CN, and I'm not sure whether about
Yes, sir. The octahedral and tetrahedral bonding confirm the FTI spectra.
I have no question about Raman. I'm asking you whether this I mean the organic residue is all or beneficial.
Yes, sir.
I cannot hear you. Sorry.
Yes.
What I am asking in your FTIR, I'm not expert on it. Please, I just have queries.
Symmetric and asymmetric bending for FTIR and Raman spectra. Symmetric and asymmetric metal এবং oxygen bending, sir. Metal and oxygen bending symmetric or asymmetric bending tetrahedral and octahedral site.
Okay, thank you.
Okay, thank you so much. There was another hand raised, but I can't take any more question right now. Now I would like to request Emar Islam to present his article, Analysis on HTS Inductor Design for Optimum Energy Storage in SMES. Please.
Maybe absent. We can go next presenter.
Okay. Then our next presenter is Muhammad Osman Goni. Impact of lanthanum ions on structural, optical, and magnetic properties of cobalt zinc ferrite. Muhammad Osman Goni, please.
Can you hear me?
Yes, we can. Please go ahead.
Assalamu alaikum, everyone. Welcome to my presentation. Today I am going to present of lanthanum ion on structural, optical, and magnetic properties of cobalt zinc ferrite. Let's move to the slide. This is the outline of my presentation, including introduction, application, aim of the study, methodology, result and discussion, and conclusion. In the introduction slide, at first I will discuss about the ferrite. What is the ferrite? Ferrite is a mixed metal oxide consisting of iron oxide phases combined with other one or more metal oxide. Here iron as a main component. Ferrite found as a 4 crystalline forms: spinel, garnet, orthoferrites, and hexaferrite. It has excellent properties such as excellent magnetic and electrical performance, sufficiently low losses over a wide range of frequencies, easily recovered and used, high mechanical hardness and environmental stability, exact mechanical dimension, cost-effective, and low magnetic losses. In the application slide, I will discuss some recent application. Ferrite used as a magnetic carriers, used as electronic devices, absorbents, and microwave devices, and used in the transformer also. In the next slide, this is the aim of the study. Preparation of cobalt zinc lanthanum ferrite by Sol-Gel autocombustion method, where 5 concentration included, and to perform structural characterization of the sample, to perform optical characterization of the sample, to study the surface morphology of the sample, to study magnetic properties through vibrating sample magnetivity. This is the flowchart of my sample preparation. Here we found sintered powder at 700 degrees centigrade for 4 hours.
Next, in the slide, I will discuss about the result and discussion. First, I will discuss about XRD analysis. By XRD analysis, we confirm that it is the single-phase cubic spinal structure. The appearance of this plane in the diffraction angle assured the formation of cubic spinal structure. The highest peak was obtained around the diffraction angle at 36 degrees for the sample with respect to 311 plane, which confirmed the spinal ferrite. The emergence of the sample orthoferrite plus lanthanoferrite also appears with the lanthanum content. In the tables, we found we analyzed the crystalline size, lattice parameter, X-ray density, cell volume, coping length. The crystalline size of the ferrite decreases from 41 to 26 cm with increasing dopant concentration. In the FTIS slide, we confirm the spinal ferrite. True stressing vibration of the tetrahedral and octahedral side found around 600 and 400 centimeter respectively. We observed the highest one is observed in the range 600 to 500 centimeter, and lowest one is observed in the range 397 to 450 centimeter. In the field emission scanning electron microscopy slide, we see that the microstructure of the synthesized undoped and lanthanum doped cobalt zinc ferrite exhibit spherical in the morphology and fairly uniform and homogeneous distribution. From the field emission scanning electron microscope, we found that you see that in the graph, average grain size initially decreases with the increasing lanthanum content. After certain time, with increasing concentration of lanthanum, grain size increases also. It is mainly due to the sample composition, preparation technique, and sintering temperature. In the next slide, I will discuss about the magnetic properties. The magnetic properties is confirmed by the VSM at room temperature, whose applied field is 20 kilo oersted. All the sample we see that show narrow hysteresis loop, which indicate the soft ferrite nature. From the table we see that low coercivity found in this all sample. We know that low coercivity determines soft ferrite. In the next slide, I will discuss about the energy dispersive X-ray analysis. In the from the energy dispersive X-ray analysis, we found the all sample cobalt, zinc, iron are present. And here with two graphs are shown. One is undoped and another is doped. And I mentioned that lanthanum is present. In the next slide, I will discuss about the UV analysis. From the diffuse reflection graph, we found that all the sample absorb the energy within the range from 500 to 600 nanometer. The crystalline size reduction can cause decreases optical band gap energy. And from the talk plot, band gap energy from diffusion reflection that I will see that obtained band gap energy increases with increasing lanthanum concentration of the sample. It increases the absorption capability of the obtained material in visible range, also application in photocatalysis and photovoltaic devices. In the conclusion slide, I said that we have successfully synthesized single-phase cubic spinal structure of cobalt zinc lanthanum ferrite nanoparticle using solvable autocombustion method. The average crystallite size as well as average grain size of all the ferrites lies in nanoparticle range, and it verifies the formation of nanoferrite. On lanthanum substitution, average grain size of the ferrite was decreases. The FTIR confirmed and the presence of metal at 594 centimeter corresponding to stressing metal oxide bond respectively and corroborated the spinal structure of the sample. The obtained VSM results showed that the prepared lanthanum doped cobalt zinc nanoferrite has got a soft ferromagnetic nature
The saturation magnetization from 29.19 to 146.45 EMU per gram increased with an increased lanthanum concentration. Has the combination of structural, magnetic, and optical activities makes cobalt, zinc, lanthanum ferrite nanofer highly useful for reducing false signal in the electronic devices, and it's highly suitable for microwave frequency application. Thank you all for patient.
Thank you, Mohammad Osman Goni. We have one question from Professor Basit. Please, Professor Basit.
Okay, thank you, sir. Just not question actually, just one suggestion. Can you please go to your data table for the coercivity? Coercive field, you have calculated coercive field. So here, yeah, yes, previous slide. Coercive, no, data table for the coercivity. Yeah. You see here, we have written the coercivity by coercive field 122.65, 29.19. So actually, by using the most sensitive magnetometer, for example, if you use for quantum interface device magnetometer, by using that magnetometer, none can actually calculate such a low field, right?
Yes.
So more than I mean, at just 2 or a step can be measured, right? So this is very, very low value, and this is not practical. This is completely impractical. So I will suggest you to write only 29 order state or 70 order state. So never please write 29.19 order state. This is very impractical to calculate. So this is just one solution. Okay, thank you very much.
Okay, thank you, Professor Basit. Now I shall request S.M. Rubaitul Islam to present his paper, Dielectric Properties and Impedance Spectroscopy of Vanadium Oxide Added Lithium Zinc Ferrite. And after this paper 10 will be presented by Jahangir Alam. So now I request S.M. Rubaitul Islam.
Sir, Assalamu alaikum.
We are hearing from you, no problem. Please go ahead.
Cannot hear.
Rubai, please unmute yourself. We cannot hear you. Rubai, we can't hear you, please.
Sir, can you hear me, sir?
Yes, now we can.
Sorry for the interruption. This is S.M. Rubaitul Islam, MSc student, Department of Physics, BUET, under the supervision of Dr. Mohammad Saminullah, Associate Professor, Department of Physics, BUET. Thank you, BPS, for giving me an opportunity to present my research topic titled on dielectric properties and evidence spectroscopy of vanadium pentoxide added lithium zinc ferrites. And outline of my presentation: first introduction, spinel ferrites, lithium zinc ferrites, additive vanadium pentoxide, objective sample preparation, resultant discussion, and conclusions. Water ferrites. Ferrites are advanced ferromagnetic materials which play a significant role in modern technology due to their various potential applications. These are some equipments of used ferrites in telecommunication and electromagnetic equipment. And then I am going to talk about this one. Structure is AB2O4, where A is a divalent metal and B is a trivalent metal. The general formula of it is MFe2O4, where M is a denoted a divalent metal ion such as Co2+, Cl2+, 2+, zinc 2+, etc. In inverse spinel ferrite, a part of the iron 3+ ion is occupied in tetrahedral A side, and rest part of the iron 3+ ion is occupied octahedral B sides. And then I will talk advantage of lithium ferrites. Lithium zinc ferrites is a soft magnetic materials which has been used in electric industries, information and communication technology due to their falling properties. And then why I used vanadium pentoxide, it was found that vanadium pentoxide was used as an additive because of its liquid phase during sintering process and effect on microstructure and electromagnetic properties in the spinel ferrites. Objectives of the present investigations: first, preparation of various lithium zinc ferrites plus Xv2O5, where X equal to 0.0, 0.4, 0.8, and 1.28% composition using solid state reaction method. Then observation of the crystal structure of the prepared samples using diffraction technique. Investigation of surface morphology using field emission scanning electron microscope. Then observation of the complex magnetic permeability as a function of frequency range 20 Hz, 120 MHz at room temperature. Then finally, observation of the relative dielectric constant as a function of frequency 20 Hz to 120 MHz at room temperature. How we prepare our samples? We prepare our sample using the methodology of solid state reaction method. Raw materials: lithium carbonate, zinc oxide, vanadium pentoxide, and ferric oxide. This is the way of prepare our lithium zinc ferrite samples, and the sample products we prepared for further investigation. I am going to discuss about structural properties. Figure 1 shows the excited pattern of vanadium pentoxide added lithium zinc ferrite centered at 1050 degrees Celsius. The excited pattern is ensured that the single phase cubic crystalline structure. Figure 2 shows the variation of bulk density of lithium zinc ferrites with vanadium pentoxide content centered at 3 different temperatures. Among 3 sintering temperature, the optimum sintering temperature is 1050 degrees Celsius due to higher bulk density. Table 1 shows the lattice constant, X-ray density, bulk density, and porosity of lithium zinc ferrite with various vanadium pentoxide content. The bulk density is increased with the vanadium pentoxide. Figure 3 indicates the variation of bulk density and porosity of lithium zinc ferrites with different vanadium pentoxide content. In this figure, where the bulk density is maximum, the porosity is minimum, and X equal to 0.88% vanadium pentoxide, the bulk density is maximum. Then I am going to talk about surface morphology analysis. The microstructure result is strongly influenced by the doping of vanadium pentoxide, and the vanadium pentoxide doped for the grain size is increased with increased vanadium pentoxide. Then I am talk about the result of permeability measurements. Figure 4, variation of the real part and the imaginary part of the initial permeability with frequency. The initial permeability is increased with the increase in vanadium pentoxide, and to satisfy it with the Stoich's relations, and also consistent with the average grain size effect. And then dielectric constant. Figure 5, variation of the real part of the relative permittivity and B loss tangent with frequency. The dielectric constant is decreased with the increase in frequency, and so increased. The dielectric result is increased with vanadium pentoxide, and it is the dielectric constant is associated with the maximum anti-polarization. The loss tangent is decreased with the increase in frequency, and in higher frequency the loss tangent is almost 0. Figure 6, A and B is the impedance spectroscopy of real and imaginary part. The real and imaginary part of impedance is decreased with the increase in van der Waals oxide, and also decreased with the frequency. And in higher frequency region, the impedance is almost due to there have no surface charge polarization. In figure C, refer to Kulkul plot known as Nyquist plot. We found the semicircular line suggesting the non-debator relaxation process. And finally, I will conclusions. The excited patterns confirm that the prepared samples were cubic phase spinal structure and no change in crystallinity of the ferrites with vanadium pentoxide addition. Then in surface morphology study, the evidence says is directly influenced with increasing vanadium pentoxide. The complex initial magnetic permeability was increasing with increasing vanadium pentoxide additive up to x equal to 0.8% vanadium pentoxide, then slightly decreased due to average gain size effect. And then it is shown that both dielectric constant and loss tangent decreases as frequency increases, having usual dielectric behavior, which is due to Maxwell-Wagner type polarization. The complex impedance spectroscopy, though Kulkul plot revealed that the conduction process is dominated by only grain boundary of the samples. My thanks to Go Department of Physics, BOET, Department of Glass and Ceramic Engineering, BOET, Material Science Division, Atomic Energy Center, Dhaka. Thank you all for your kind attention.
Thank you so much for your presentation. I don't see any hand to ask any question. However, our time is also very much limited. May I now request Jahangir Alam, Mr. Jahangir Alam, to present.
Thank you also, sir. Thank you also.
Okay, thank you. Jahangir Alam for the next article, analysis of the HTS inductor design and optimum energy storage of SMES. Sir, Jahangir Alam, are you there? Jahangir Alam, are you there? Please. Can you hear me? Okay. Jahangir Alam. We can't hear you. Mr. Jahangir Alam, please, can you unmute yourself?
Jahangir Alam cannot hear. Please unmute.
Alam, please unmute yourself.
No, please, now you can.
Yes, we can.
Yes, sir, assalamu alaikum. Hello?
Yes, we can hear you.
Okay. Thank you, sir. I also like to thank Bangladesh Physical Society for organizing national conference. I am Jahangir Alam, a physics research student of Sitawang University, and Professor Dr. Rafiqul Islam is my supervisor, and Muhammad Abdullah Al-Jahan is my co-author. So let us go to my talk. The title of my talk is Analysis of the HTS Inductor Design for Optimum Energy Storage in SMASH. Abstract. This study discusses the design optimization for a superconducting solenoid made of silver-sheeted high-temperature bismuth, strontium, calcium, copper oxide tape conductor, and consider various practical issues regarding the choice for a prototype. We also have performed the inductance calculation for a specific design
and shown the effects of variation of parameters related to it. Introduction. Actually, we are dealing with the energy storage system. The energy storage system can store excess energy that is generated during optic periods when the load is low, and then deliver it back to the grid when the demand is rises. That means in peak periods. Among various energy storage devices, SMASH is a promising energy storage system that stores energy in the form of a magnetic field created by the flow of direct current in a superconducting coil. So the coil is the main part of this technology, and the inductance created in this technology in this coil is determines the quantity of the stored energy. On the schematic view of the system, here we like superconducting coil. We know the electrical energy stored oil can be written as E equal to half L is the current flowing through it. If we source, then we have in there only the inductance value.
We have lost Jahangir.
I think he is disconnected again. Actually, I think I have to go post him again. Oh, now he's.
আবার এসেছে স্ক্রিন দেখাচ্ছে আবার
Yes, sir. Okay, sir.
Okay, you may proceed.
শোনা যাচ্ছে না
Please unmute.
Yes, sir. So, are you hearing me?
এখন শোনা যাচ্ছে হ্যাঁ
Thank you.
Yes.
Thank you. This is the figure of our theoretical model for calculating the inductance of a solenoid. Here we see in there the our solenoid is stacks of this is on pancake layers. The capital DI is the inner diameter of the coil, and capital D naught is the outer diameter of the coil. Small a is the width of the tape conductor, and this the capital is the total height of the coil. Now we employ a formula Now we employed the formula for calculating the inductance like equation 2. Here capital L is the inductance of the coil, and small capital N is the number of turns in the coil. Alpha and beta are the size ratios. Alpha is the size ratios. That means it is the ratio between the outer diameter to inner diameter. Beta is the size ratios between capital S. That means it is the total height of the coil to the inner diameter. Numerical calculation. For inductance calculation, in this case, we have fixed the width, the thickness, and the outer diameter of the coil, while we vary the inner diameter and the height of the solenoid. We already have been mentioned that this calculation have been performed for the bismuth, strontium, calcium, copper oxide tape. This tape possesses some properties like this. With the width of the tape is 4.2 millimeter. The thickness of the tape is 0.31 millimeter. Here we have seen that the critical current density increases with decreasing temperatures. So, taking these parameters, we take a numerical calculation. Our numerical result has been tabulated
2 minutes.
Table. Here we have seen that from the beginning the inductance value is increasing with the increasing of layers, the number of turns of the coils, and certain specifications, the inductance value is maximized, and beyond this layers in inner diameter does not increase, rather it decreases. Is our optimum the parameters for which this value is obtained? It is our optimum parameter. Now we can show the value in graphically, like the first graph is showing the variation of inductance with inner diameter. Here we have seen
I think he is again disconnected.
আবার আসছে দেখা যায়।
Mr. Jahangir, please unmute yourself. We can't hear.
Unmute. Sir, in this graph, we have shown that the inductance decreases with the increasing of inner diameter, and the maximum inductance is obtained for minimum inner diameter. Here, the inductance reduces because with the increasing of inner diameter, the thickness of the coil reduces, and finally, the volume of the materials is all reduces, and ultimately the inductance value reduces. In this graph, we have shown the inductance value with the size ratio. Here we have seen that when the size ratio is small, that means when the number of Franke layers is small and the height of the coil is small, then the inductance is minimum. And as the increasing of the height and Franke layer, the inductance value increases for a certain value, 372 at last. This is our optimized value. Finally,
time is over. Please go to the conclusion.
Yes, sir. Finally, we have shown that if we design an inductance for employing such parameters in this way, we have got the optimized value. So this is our optimum design. Conclusion. For the optimum design of the coil, we need to have a small inner diameter with a large outer diameter and coil height. That means optimum design yields maximum inductance with per size issue. Thanks to all.
Thank you, Mr. Jahangir Alok. Thank you so much. Is there any question? I think no. So,
maybe Professor Rafiqul Islam.
Okay, sir.
মিস্টার সেভেন শুনতেছেন আমাকে?
জি স্যার শুনছি।
আপনাদের একটু কষ্ট দিব সময়, আমি অবশ্য এই পেপার বা কাজটা আমাদের সম্মিলিত, তো আমি ও চাচ্ছে যে এটা কিছু বলবে। এটা একটা স্মল পার্ট স্টোরেজ ডিভাইস, যেটা সুপার কন্ডাক্টিং ম্যাগনেটিক এনার্জি স্টোরেজ। এটা অনেকগুলি পার্টস আছে, এর মধ্যে একটা হলো কোয়েল, যেটা আমরা সুপার কন্ডাক্টিং কোয়েল। সেটা সে যেটা বুঝাতে চাচ্ছে, আমি সংক্ষেপে যেটা আমি এটা ব্যাপার, সেখানে জাস্ট যে একটা আমাদের মেইনলি সুপার কন্ডাক্টিং ওয়্যারের স্পেসিফিক অপারেশন যেটা আসবে সেটা কারেন্টের উপর ডিপেন্ড করে এবং সেটা স্পেসিফিক। এখন আমরা চাই যে এনার্জি স্টোর করতে হলে একটু এনার্জি স্টোর করার আরেকটা পদ্ধতি দেখছি আমরা, ফর্মুলা অনুযায়ী কারেন্ট তো ঠিকঠাক রাখতে হবে, তবে আমাদেরকে ইন্ডাকটেন্স বাড়ানো যায় কিনা। আর ইন্ডাকটেন্স বাড়ানো যায় যদি তার ডিজাইনটা স্পেসিফিক হয়। তো স্পেসিফিক ডিজাইন করতে গিয়ে আমরা অনেকগুলি প্যারামিটার দেখাচ্ছি, ক্যালকুলেশন করে বুঝাচ্ছি যে ম্যাক্সিমাম ইন্ডাকটেন্স পাইতে হলে আমাদেরকে এই অবস্থায় যেতে হবে। এর চেয়ে আমি যতই বাড়াই, হাইট বাড়াই কিংবা কমাই, এগুলি আমরা দেখাতে গিয়ে লাস্টে একটা রিকমেন্ড করতেছে যে এই ভ্যালু আমরা ম্যাক্সিমাম পাবো যদি আমরা এই প্যারামিটারকে এই রাখি। তারপরে আমরা যাইতে চাই যে হাই টিসি ফার্স্ট জেনারেশন, সেকেন্ড জেনারেশন সুপার কন্ডাক্টর, এগুলি দিয়ে আমরা এনার্জি স্টোরেজটা বাড়াতে পারি কিনা। অ্যাকচুয়ালি এখানে আমি বসে আছি ঠিকই, কিন্তু 3বার 4বার কারেন্ট চলে গেছে, আর ইন্টারনেট কতবার যে গেছে বলা যায় না। তো সেজন্য সরি, আমি আমারই পেপার, হয়তো সে একজন ফিল্ড স্টুডেন্ট হিসেবে সেইটার উপরে কাজ করছে, খুব একটা ভালো বলতে পারছে না, আর এখানে খুব ডিস্টারবেন্সটা আছে। তারপর যদি কোনো প্রশ্ন থাকে আমাকেও সরাসরি আপনারা করতে পারেন। কাইন্ডলি
I think if there is any question, if any, he or she will definitely contact you and ask you the question. In conclusion, I can say that 1 invited talk and 6 contributing papers have been presented in this session. I hope some new ideas will be explored that will be helpful for our young scientists and researchers. I would like to thank Mr. Co-Chair and you all, and like to conclude this session. Please stay safe and thank you all. Assalamu alaikum.
Thank you.
Sir, this is me, Ratan Chandra Ghosh. Actually, we are running out of time. So firstly, I would like to thank Professor Farukjaman sir and Professor H.M. Kausarjan sir and all the presenters of session material science group. Since our next invited speaker from abroad, so we would like to continue next session. So I would like to request Professor Dr. Shurabjan Kumar Das and Professor Dr. Abdul Wasnat Abrubel, please continue your session. So thank you very much.
Okay, thank you. রুবেল কি শুনতে পাচ্ছো? রুবেল শোনা যাচ্ছে? শুনতে পাচ্ছি স্যার। আচ্ছা, ওকে। Ladies and gentlemen, good afternoon. You are cordially invited to the session number 9 of National Conference on Physics 2021, session named Health Physics. In this session, we have 1 invited speaker and 5 contributory paper presenters. So, every contributory papers presenters will have 8 minutes presentation and 2 minutes comments options. And for inverted, you will have 20 minutes. So now, our today's I welcome David Bradley, professor at University of England and head of the Center of Applied Physics of Radiation Technologies at Sanoa University, Malaysia. He was the secretary of International International and Radiation Physics Society, editor-in-chief of the British Journal of Radiology, and consulting editor of Elsevier Journals, Applied Radiation and Isotopes sections. He is the author of over 250 publications. Main interest, fundamental interactions of radiation, as well as their applications in biomedical area. So now I request Professor David Bradley to show you slides, development of radiations, radioluminescence sensors. Please start.
Thank you very much, Mr. Chairman. I assume everybody can hear me and see the my presentation. So I'm going to talk to you about, I'll give you a little bit of an introduction. I'll talk about radioluminescence at elevated doses and dose rates. I will then look at something called norm, which is naturally occurring radioactive material and its sensing, and then look at some future prospects, including a couple of extreme situations. So, of course, the popular solution for passive dosimetry are phosphodoped materials, and you can see these in various forms here: chips, powders, rods, etc. They are typically a few millimeters in dimension, which is quite large, given some situations such as in radiotherapy, where you want to do guided radiotherapy, sometimes at less than a few millimeters. So you need high spatial resolution. Also, so the alternative is one of the alternatives is to look at glass, and this is just doped fibers for optical communication. They are doped so that they produce total internal reflection. And if they were perfect, you would only see light coming out at the end, and you wouldn't see light coming from the sides. So total internal reflection, of course, is true at a particular wavelength and is not true at other wavelengths. But what we're trying to do is to do a search for sensitive and robust materials of high spatial resolution, ones that could be immune to electromagnetic interference. So the very latest radiotherapy linear accelerators come together with magnetic resonance imaging, so that electromagnetic we have a range of issues to deal with. So the one that I'm showing you here is to try and get from very low levels, environmental monitoring, through to very high levels. So I'm talking about going from milligray to kilogray. And in the milligray range, so you know that you get a couple of milligray by just living on the Earth's surface from naturally occurring radioactivity. And so we tried to create for ourselves something from the optical fibers, and this is called a photonic crystal fiber. You pack lots and lots of small fibers together, and then you melt them down and pull them. So this is just 100 microns across here, and you can see that by doping these individual fibers, that you can get an enhancement in sensitivity. So actually we have done these sorts of measurements. You can see here, here's a very famous Bangladeshi name. Professor Kandaka, who works with me. And we've done some work in looking at around a rare earth facility to see if we could detect any contamination. And it works. You can see the difference between 2 months, 4 months, 6 months, 8 months, etc. These are impervious to water, so it doesn't really matter that there's rain, tropical rainstorms, etc. in Malaysia, which is where I'm now living. And at the other extreme, but before I do that, I'll just show you these beads, by the way. One of my ex-PhD students was complaining that the optical fibers were causing a problem with eyesight. So here are 1 millimeter glass beads, the same sort of glass beads you can buy in any craft shop, the sort of beads that women sew onto their dresses. And it's, of course, they are doped because they have, they are of different colors. And so we have found that these are equally as sensitive at radiotherapy doses to optical fibers. The optical fibers, by the way, that we're using are generally germanium doped. They're around about 4 molar percent dopant concentration. And here we've looked at doped silica in a kilogray range. The reason that we're looking at kilograys is because in some situations for radiation processing, you want to do cross-linking, you want to produce wires that are resistant to very high temperatures inside motor car engines, and so they're being irradiated to kilogray ranges. And you can see here our optical fibers are giving us linearity up to round about so close to 100 kilogray. So we've gone from milligray to kilogray, so that's a factor of 10 to the 6 change in intensity. So the dosimetry principles, I assume that everybody really understands these. So of course, you can use thermoluminescence, releasing so these are amorphous materials, generally glass. So you've got traps produced by the dopant and also by strain-related defects. This is a 2-step process. You irradiate and then you use heat to detrap. Whereas in this situation here, optically stimulated luminescence, you're using, of course, laser light to do the detrapping for you. So both of these are 2-step processes. You irradiate and then subsequently, maybe a day later, you do a readout. Whereas in radioluminescence, it's spontaneous luminescence during the period of irradiation itself. So I'm just comparing here TL and OSL, which are this sort of model, against the radioluminescence model. And of course, you will now notice that I'm adopting a crystalline model. And of course, it's true that many of the features of a glow curve that evolved from using an amorphous material are very, very similar to the glow curves that you see in a crystalline model, such as for lithium fluoride or calcium sulfate. So we've adopted this model to try to understand the situation of spontaneous luminescence during irradiation. All right, so we've produced ourselves optical fibers using a modified chemical vapor deposition method, because we initially thought that if we start from a 4 molar percent germanium doped optical fiber that you can buy off the shelf, that if you increase the dopant concentration, you will get an increase in sensitivity. It turns out that is not true, that as you increase the dopant concentrations beyond around about 4 molar percent, that retrapping occurs as you detrap, so that actually you're not squeezing any more sensitivity out of it. And ironically, the off-the-shelf commercial fibers are just about as good as you can get. So anyway, so we set up a photomultiplier tube. These are things that gives you maybe 10 to the 7 increase in magnitude of the light. The light that's giving off from these optical fibers is very tiny. And if you don't use a completely blacked out situation, of course, you'll drown out the light that you're trying to measure. So this is a photomultiplier tube, conventional one, with a beam splitter here because we wanted to look at both RL and optically stimulated luminescence. And we have a lab view system to look at our arrangement. So here's the linear accelerator, our optical fiber sensor, around about 100 microns diameter, about the width of a human hair. Here's a PMMA, is a very low response to radiations. And then we have our photodetector here and our counting unit, etc. So you can see this is a linear accelerator. The interesting thing about is that these are electron linear accelerators that are mainly used in hospitals. They produce Bremsstrahlung if you put a target in the way, so a tungsten target, for instance, and produce X-rays in the MeV range. But the important thing is that the radiation is delivered in short pulses, around about 3 to 5 microseconds, so that in around about a second, you've got around about 400 pulses being produced. And so we've looked here at the increases in dose rate, and here we've looked at fixed dose rate and different doses. So you can see that we've got very nice response to these. We've got a flat top, which is very, very important, I should point out. We've got almost a square wave where we've got to baseline is quite rapid. You can see that it's not very, very rapid. Look, you can see here, the return to baseline is relatively slow. I'll tell you the reason why I'm saying relatively slow, because right now radiotherapy is given in around about 2 to 3 minutes to give you 2 or so a day. Whereas now this year, they're starting to talk about something called flash radiotherapy, where you can deliver the same dose in around about 150 milliseconds. So timing is going to be extremely important in the future. So I can look, so you can see here, this is the radioluminescence in counts per second against dose rate and centigrade per minute. And you can see for photons and for electrons, we get very, very nice, smooth and linear curves. And you see, here is another of our colleagues from Bangladesh who was working on this during their work on radio for their PhD. And reproducibility is very good. You can see here that we've just done 10 different irradiations and you get the same response to within about 1%. And we've been using this device now since about 2016, and we're seeing no reduction in the performance of these devices at these dose rates, which are quite high. I mean, it's 1,000-fold more than you get in diagnostic radiology. Interesting thing is that if you looked at aluminium oxide, so this is ruby, you don't see a flat top, and that's because aluminium oxide materials are used for optically stimulated luminescence, in which you, subsequent to radiation, you read out the decay, which is this one here. So it's a slower decay, and that's what's needed for LSA. Whereas for radioluminescent spontaneous detrapping, you want a very flat response here, so that you know that you've got a particular dose. Okay, so diagnostic radiology, you're cutting down now by more than 1,000-fold. So the doses that you get in a chest radiograph is about 0.1 milligray. Similarly for extremities, broken wrists, sprained ankles, etc. And effectively, you're getting a single pulse in the millisecond range. And you can see here, these are different current time products. And you can see that if we look at the different current time products against radioluminescence, again, you get a nice straight line. And so you can be sure that this could actually be used in quality assurance to check that your X-ray tube is actually working as is intended. And this is, we've just used a p-doped, phosphorus-doped silica fiber here, looking at the radiation response against 120 kVp X-rays, which is what you use in diagnostic radiology at these typical times, and at the gate time of about a millisecond. So each of these being captured in a millisecond. And you can see that this is the rise and return to baseline, the characteristics of the RLC generator that's being used. Why are we interested in optical fibers in particular? Well, if you use cylindrical phosphor, of course, you're getting light given off through the sides as well as from the ends. In radioluminescence, the majority of the light is coming out through the ends rather than through the sides. Although, as I mentioned earlier, if they were truly blind to anything other than going through the fiber, you would not see the length of the fiber either. So actually, and later on, I'll tell you that we are now trying to increase the sensitivity by wrapping this with a reflective material. And the best reflective material we can find is one that's got an atomic number of 79, that is gold. And the reason that we're interested in gold is because then we can get photoelectron generation to increase the sensitivity as well. So this is looking at the time resolved measurements. So this is us looking at time resolved measurements. As I told you, is about 2 to 5 microseconds. and we're capturing each of these pulses is about 2.5 milliseconds between each of these pulses. So we can do this, and we know that even though there is a slow return to baseline, relatively speaking, it's good enough for conventional linear accelerator applications. Whether it could be good enough for flash radiotherapy, where you're doing this 150 milliseconds, is a question that we're trying to resolve, and we're trying to get materials with a faster response time than these here by working with the University of Shanghai. But at the moment we've not got into that. Okay. Just want to show you something interesting. Of course, the PMMA is also giving a response, and that's what this orange peak is showing here. But this so-called STEM effect is not only the response from the PMMA, but it's also Cherenkov radiation. So Cherenkov radiation is very, very rapid. It's only there for as long as the beam is on. So each time you're switching on and off very, very rapidly. So in fact, this may well be the clue to us being able to cope with the flash radiotherapy dose rates. I now go to the other extreme, that is norm in oil fields, naturally occurring radioactive material in oil fields, and the oil and gas industry are having problems with this material. There's uranium and thorium in the earth crust. They remain in situ, but the radiums start are soluble in water, accompany the well fluids up the pipelines. Radon gas also is there, is very mobile, and you're seeing it coming out further along in the crude oil storage tank, etc. So the radium is sparingly substituting for barium, strontium, calcium, and the sludge. And so we want to look at the problems that you can get with that. And what kind of problems are we talking about? These are separators, by the way. They separate out the fluids from the gas from the crude oil. The problems are that this is scale formation, and because these are radium, they're alpha emitters. If you try to clean them using mechanical methods, then you'll produce dust, and then you'll inhale, etc. And there's exposure to internal radiation. And just to show you, this is us doing measurements on a whole lot of oil platforms offshore. This is natural radiation levels. This is the radiation levels in a separator. Now you may say, "Oh, this is very small," but we're not dealing here with a few grams of material. We're dealing with many tons of material up at this end. So actually, we want to have Atomic Energy Licensing Board notification levels like that in Malaysia. They want to know whether anything is more than 0.5 microsieverts per hour. Background is around about 0.1 microsieverts per hour, so we need something that's very, very sensitive. There are very sensitive devices like this one I'm showing you here. I'm just checking my time. You can see here that you could actually put this down a little bit of the way, but you couldn't do all the way along one of these that are more than 10-meter long tubes. And of course, if you have this problem like this, where you can't measure anything at all other than putting it down, having something that's very, very fine, like our silicon fiber materials. And of course, the separators are extremely dangerous because there's the gases in there, hydrogen sulfide, etc., killer gases, are extremely dangerous, and some of the gases could be explosive. Ours is just a light system. There is no electrical connection at the business end, so we could actually do surveys inside here before anybody goes in there. And we're trying to look for a traffic light system. Is it contaminated or is it not contaminated? You might think that this is easy, but actually this is the reality in our oil and gas stockyard with many, many of these there. And so we think that we can actually use a system based on the silica fibers to actually inspect these well before you actually have to pull any of them out and do these extra measurements like this. So we're looking now not for a box device, but a minified device. So we're looking for something that's handheld. So we're going to go from a photomultiplier tube standard to a silicon photomultiplier tube, the so-called avalanche detectors that can be operated on a 7-volt battery at this end. So I just want to show you that we want something also that's much more productive in terms of light yield. So we've used lutetiummetry and orthosilicate cerium doped materials now in our latest ventures. This is monazite, which is a tailing from the tin mining industry. And you can see this one here is giving us around about 48 microsieverts per hour using a handheld device. We've looked at monazite, and we looked at xenotime, which are again discards of the tin mining industry and rare earths industry and so on. You can see that we're easily able to measure 48 microsieverts per hour. We're easily able to measure 20. This big fluctuations here is because initially we didn't put enough effort into masking from the light that was being produced in daylight. So we've now been able to, by the way, this is just us tracking our GM survey meter against our fiber optical coupled device. And you can see that they're tracking each other very, very well using a cesium-137 source. This is our latest attempt now with everything blacked out extremely well. This is our sensor. There's about 20 meters of cable here. When we took the scintillator away, this is what we get. When we put the scintillator back on, there's no other radiation source other than natural background here. This is what we're getting. So we can measure 0.1 microsieverts per hour. We're going to try much harder with this to reduce this amount of noise. Other potentials, we look at contaminated land surveys, and here's the IAEA harnessing drone technology. And we think our system is sufficiently light that we can put this onto drones, and we can use telemetry.
Excuse me, Professor David Bradley.
Yeah.
You have 2 minutes to.
Okay, I'm very close to the end now. Yeah. So here's the extremes I've talked about. This is a plasma device. It's a little electrical storm. So each time that you produce a spark, you produce X-rays, or if you can use a gas, you could produce neutrons. But this is nanosecond timing. So you can see our present system is very, very poor. We just captured 2 points on this peak. This peak could be way up here for all we know. So we really do need to be able to have much fast timing arrangements. And the Italians are starting to try and use this to try and do radiobiology at flash dose rates. So we want that. And this is at the other end using an electron beam processing facility that is giving out those kilograys that I talked about earlier on. So this is us, and I'll not look at the spectroscopy. This spectroscopy is showing us variations in the hydroxyl content of the material. But here you can see at 2 particular wavelengths, we're getting quite nice linearity. Each additional milliamp is giving an additional kilogray in this device. So we know that we are doing very, very well. We've gone from 10 to the 9 change in magnitude, and we know that we still have functioning devices. So thank you very much. What we think might end up with in the future is something where you can actually have something that's just on your wrist to actually monitor what's going on at the fiber tip end. Thank you very much for listening to me. I've reached my end. Thank you.
Thank you, Professor David Bradley, for your very nice and informative presentation. I can see 2 hands is rising for a question. Dr. Rashid Lijam. Yes, you can ask your question, please.
Thank you very much, Professor Bradley, for your nice presentation. I hope you can hear me.
Yes, please.
I missed some. Could you please get back to the slide where you showed you are measuring due to the norm effect of some long pipe, which
this one or this one?
You showed that it is because of norm effect.
Yeah. What would you like to ask me?
Yeah. Where you have measured some dose rate.
Yeah.
In some long tube of pipe of iron, maybe. I don't know.
No, this wasn't a round tube. This was just this, just this container holding a few hundred, not even 100 grams of active material. Yeah. So this one is called monazite.
The slide. No, the back side, please. Back.
These.
Yeah, upward. Yeah, go back this. You showed some. Yeah, back. Yeah, here. Yeah, this one. Yes, norm-affected media. I mean, maybe I misunderstood. I don't get the point. What kind of? I mean, you said that here. No, the back. The previous one. Norm-affected media. What kind of effect are you observing here?
This is gamma rays. This is gamma rays. This is just gammas. It is sparing replacement of calcium, barium, strontium with radium. So you're having crystallites of radium inside the material, inside this material. This is alpha active scale.
Yeah, so you mean here we can see some some damage of the material. You mean
No damage. Not at these levels. These are milligray ranges. No. This is just about the problem of flow for the oil and gas industry.
Yes.
This is reducing the flow. So when you get down to these sorts of levels, like this one here,
so that's why I missed the information. What are you? Yes. So that's I missing. So.
Okay,
actually,
I would like to
you just measure the.
You can discuss with Professor David Bradley afterwards. Now I would like to take the next question from Dr. Mohammed Tariq. Dr. Mohammed Tariq, you can ask your question, please.
Yes, thank you very much, Mr. Here and Bradley. I am audible to you, Bradley? Professor
yeah, I can hear you. Thank you.
Yes, I have a just very simple fundamental question to ask you. So you use optical fiber using silicon dioxide optical fiber.
Yeah.
And there is any other possibility to dope this silicon oxide optical fiber with other material other than?
Sure. Yeah. We've done phosphorus, we've done germanium. You could do erbium, you could do terbium, anything where you have a modified chemical vapor deposition method and a pulling tower to pull them into fibers. Yeah.
And just one more just extra question. Is there any relation between the germanium band gap and silicon dioxide band gap relationship so that it can be optimized to go for a radio?
Yeah, probably. Actually, the very first slide I forgot to mention to you all. This one here, of course, is showing the Cherenkov radiation on this blue radiation, of course. So actually, it turns out that these materials are producing at the blue end of the spectrum.
Yes,
so it's around about 3 EV.
Yeah. Yeah, of course, because silicon dioxide has very high large band gap.
Yeah. There's around about three electron volts. So,
yes. Thank you very much. Yes.
Thank you, Dr. Mohammed Tariq. Now we can go the next quick question from Mohammed Khandakar. Mahin Khandakar, please ask your question.
Thank you. আসলে আমি কোশ্চেন করব না, ওই যে একটু আগে যে ফার্স্ট কোশ্চেনটা জিজ্ঞেস করেছিল প্রফেসর ডেভিড ব্র্যাডলিকে, আমি সেটার একটু এক্সপ্লেইন করতে চাচ্ছি। মনে হয় যে কোশ্চেন করছে সে বুঝতে পারে নাই। তো সেটা ছিল যে পাইপিং এ যখন আমরা অয়েল এন্ড গ্যাস ইন্ডাস্ট্রিতে এটা অয়েল এবং গ্যাস সেপারেট করা হয়, যে পাইপের ওখানে স্কেল জমা হয়, অর্থাৎ অপদ্রব্য জমা হয়। যে ওয়াস্টেজ গুলো জমা হয়, ওয়াস্টেজ গুলোতে প্রচুর পরিমাণে, যেহেতু এটা ন্যাচারালি অকারিং রেডিওঅ্যাক্টিভ ম্যাটেরিয়াল, অয়েল এন্ড গ্যাস গুলো মাটির আমাদের লিথোস্ফিয়ার থেকে আসে। তো লিথোস্ফিয়ার থেকে যখন আসে, এগুলাতে প্রচুর পরিমাণ আমাদের ইউরেনিয়াম, থোরিয়াম এগুলা থাকে। যেহেতু ওগুলা ওই জায়গায় জমা হয়, তো প্রফেসর ব্র্যাডলি এটাই বুঝাতে চাচ্ছিলেন যে এটা যদি আমরা ম্যানুয়ালি সেপারেট করি, এটা হচ্ছে আলফা ইমিটার, অর্থাৎ এটা হাই লেভেল রেডিওঅ্যাক্টিভ গ্যামা রে, আলফা এগুলা রিলিজ করে। তো যারা এই কাজগুলা করবে তাদের এটা খুব হেলথ হ্যাজার্ড হয়। এটা তো সামান্য একটা দুটা কাজ না, রেগুলার এবং হিউজ অ্যামাউন্ট কাজ। তো সেক্ষেত্রে আমাদের প্রফেসর ব্র্যাডলি যেটা বুঝাতে চাচ্ছেন যে আমরা অপটিক্যাল ফাইবার বেসড টেকনোলজি এটা আমরা ডেভেলপ করেছি, যে ডিটেক্টর ডেভেলপ করেছি, যেটা দিয়ে আমরা রেডিওলুমিনেসেন্স অটোমেটিক্যালি অনেক দূর থেকে আমরা এটা মেজার করতে পারবো। আমি আশা করি যে কোশ্চেন করছেন উনি বুঝতে পেরেছেন, ওনার অ্যানসারটা হয়েছে কিনা আমি জানি না এক্সাক্ট, এটাই বুঝতে চাচ্ছিলাম।
Okay,
Thank you very much. Thank
Professor.
you. This is my research colleague, by the way, speaking. Professor Mayin
Okay,
and I work
okay,
together.
Thank you, Johnny. Okay. So I would like to conclude your talk, David Bradley. Thank you very much.
Thank you so much.
Especially thanks as you finish your talk within the time. Thank you very much.
Thank you so much. Thank you.
Professor Suranjan Kumar Das, you can call the next speaker, please.
Yeah, now contributory papers. Our first contributory speakers, L. Begum. If you are ready, you can start. L. Begum, study on radiation protection, infrastructure of different X-ray facilities in Hobbygonj.
Actually, sir, we did not find the ID of the HP01 L Begum. Might be can continue next paper right now, and after that, if she come back, and then we can.
Okay. So next presenter, A.B. Rahman Shubho, real-time environmental radiation monitoring in Tezgathan. Real-time environmental radiation monitoring in Tezgathana, A.B. Rahman Shubho.
Can you hear us?
Yes.
Yes.
Okay. I'm just opening my PowerPoint. A minute.
Recording in progress.
Can you see my presentation?
Not yet. Yeah, now you can see.
Assalamu alaikum. Good afternoon. Hereby Muhammad Ashkur Rahman Shubho, student of Department of Physics in Jahangarnagar University. In completing my degree, I had to work on a project named Real-Time Gamma Radiation Monitoring in Tezgathana under the supervision of Professor Dr. Kabiruddin Sikdar sir, and my co-supervisor was Dr. Sohailur Rahman sir. I would like to convey my respect and thanks to Bangladesh Physical Society and my supervisors to give me the opportunity to present myself. As our time is really short, I will go for my presentation first. This is the title of my project. The outline of my project first is abstract, then introduction, objectives, theory and biological effect of the radiation, material and method, then result and discussion, and then conclusion. The main objective is to measure the outdoor gamma dose rate of artificial and natural source in Tezgathana. And lastly, calculate the dose rate and the annual effective dose to the population with excess lifetime cancer risk in public and comparing with other countries. Then coming to my abstract. The measurement was performed using a portable gamma spout detector placed 1 meter above the ground, and tripod and data acquisition time for each monitoring point is above 1 hour. Total 32 monitoring points were selected for the collection of the gamma rays dose rate and were marked using the GPS navigator. This is the introduction, and this is the definition of the actual radiation. This is the classification of radiation as ionizing radiation, then non-ionizing radiation. As gamma is a high energy electromagnetic wave, the work is ionizing radiation form. Now, actually, I use the method that is called the in situ method. It is a very reliable and rapid technique for determination of the local radioactivity and dosage in severe areas. This is the classification of radioactivity. Now, the background radiation. Background radiation is measure of the level of ionizing radiation present in the environment at a particular location. It originates of variety of sources of both natural and artificial sources. In the picture, we can see that there is radon gas, 50% of radon gas. That is actually a natural occurring radiation. This is the theory of definition of absorbed dose. This is the theory of annual effective dose. When I have to implement this annual effective dose and the dose rate, thus I can get my the gamma rays, where is the effective of the and the ELCR, the excess time cancer risk, where we can see if there is any cancer risk in that area or not. This is the theoretical principle of in situ gamma ray spectrometer, where developed in the early 1917. The gamma dose rate can be calculated by the formula. This is the formula. This is the classification of biological effect. If
Recording stopped.
If the sir, can you hear us? Annie?
Yes, please proceed.
Okay.
We can hear you.
Classification of biological effect. The effect is actually the aqueous effect. It can damage the skin and damage of the reproductive cells. Somatic effect can damage our central nerve system. Latent effect can damage our immunization system, and another.
I think you can show the mechanism and the results.
Okay. These are the materials I use. This is the Gamma Scout. This is the GPS meter. These are the area of the 32 location is Tezda Thana. The Thana starts from actually the Sonarga Hotel to actually 38 ward is actually the Jahangir Gate.
Recording in progress.
These are the materials. These are the 32 monitoring points. So the latitude, these are the name of the place, these are the range. This is actually the data of my 32 monitoring point. This is the result and discussion. Frequency distribution observed of Tejgata 100. This is the frequency distribution dose. Result and discussion. The average of the dose measures along a estimated annual effective absorbed dose due to the outer gamma rays is presented. The highest dose rate was observed in Sonarga Hotel, and the lowest effective dose with the perspective was in ETV. The perspective value of Sonarga Hotel is 0.21 plus minus 0.008 mu sievert per hour, and the ETV's dose is 0.06 to plus minus 0.008 mu sievert per hour. These are the maximum and minimum value of the annual effective dose rate and the dose rate. These are the mean of the dose rate 0.128 plus minus 0.08, and the annual effective dose rate 0.242 plus minus 0.015. These are the result and discussion. This was the chart title. This was the ELCA to the public for Tezda Thana. In here you can see the these are the top 0.3. These are the highest level of the conflicted area, where then there can be some cancer risk. These are the some countries I actually compared with in the range of the Tezda Thana. In this data, actually, India's dose rate is actually so high. It's above 0.07 to 0.307, which is actually high from our country. These are the result and discussion. You can see there's the India's top, one of the top countries. They proceed to the effect, the cancer risk. There should be much cancer risk than other countries. Sweden is also one of them. Now coming to my conclusion, outer gamma radiation dose rate at Tezda Thana were measured by this method. The dose rate was actually 0.42. It was the average dose rate. The average and kind of actually this is it. This actually I collected the 32 monitoring points, and this kind of actually measurement should be do where there will be most like Rupur nuclear power plant, where there will be wastes in the nuclear plant and like that, and it will be detect the natural nucleotides and artificial nucleotides producing from the nuclear installation. That's it. It's my presentation.
Any question, please? Any question?
Perhaps there is no question, sir.
Okay, now I think I want to know why you choose Tesgathana.
Sir, because whenever I went to my supervisor, he thinks that the area is overpopulated and there can be some risk factor. That's why he gave me the area to find this thing. That's it.
And you said that you have got the maximum growth in Sonarga hotel area, maybe?
Yeah.
What is the region you think?
Sir, maybe I think the west, and there should be some industrial area behind Sonarga, and the area is actually so populated. Whenever I went there to see and measure the area, I saw too much people, much industrials, and like more buildings, and there the west, mainly the west, too much west beside and outside of this area. That's why I think Sonarga is highly.
Anyway, have you measured the ELC, lifetime cancer risk factor? Have you measured?
Cancer risk factor?
Yeah.
The cancer risk factor.
ELCR, lifetime cancer risk
factor. So actually, the risk factor, it was an average of the total 32 monitoring point, and I actually I actually maintained the risk factor with the other countries. That this is the.
No. I just want to know: have you measured the risk factor Tesgathana?
Sir, no risk factors. Yes, no risk factors, sir. Actually, the risk factor that was I concluded in my project work. That was actually the in a world average. There is some actually a risk factor, but in the Tesgathana, there is no actually a risk factor that I measured from this from those data. No risk factor in Tesgathana. I measured it.
Okay, if no questions, then we can proceed for the next presenter.
Yeah, our next presenter perhaps Kamud Jaman, if I cannot mistaken. Kamud Jaman present here, please.
Yes, I am present here.
Okay, you can share your slide.
Okay. Shall I start?
Please.
Okay, please.
Yes, visible.
You can give the preview of your PowerPoint.
Okay, thank you. So, good afternoon, everybody. So I'm Kamru Zaman. I'm going to present our paper on behalf of our group. The title of my paper, you can see, is Health Effects of Electromagnetic Radiation from Mobile Phone and Towers. Its present scenario in Bangladesh. So, mobile phone is become a part of our life, right? It's very hard to find a modern person in the society without mobile phone. So, mobile phone has converted the whole world into a global village. Now, it's a very important one. Everything has two sides, good side and bad side, good effect and bad effect. The mobile phone is very, it's very important in our daily life, but it also had some bad effects. So I'm going to talk about the backside of the mobile phone and its towers. Okay, so now the number of mobile phone is worldwide is 8 billion, and in Bangladesh it's 160 million in 2021. So, hello, শোনা যায়? Hello, শুনতে পাচ্ছেন?
জি শুনতে পাচ্ছি, প্লিজ।
হ্যাঁ, তো আমি কি বাংলা ইংলিশ মিশিয়ে বলবো না শুধু ইংলিশে চালিয়ে যাব?
যেটা আপনি প্রিফার করেন,
আচ্ছা ঠিক আছে, ওকে। সো মোবাইল ফোন এত প্রয়োজনীয় এখন জরুরি হওয়া সত্ত্বেও আমাদের এই সম্বন্ধে একটু নানা রকম প্রশ্ন উঠেছে সারা দুনিয়া থেকে, বিকজ পিপল আর সাফারিং ফ্রম ভেরিয়াস ডিজিজেস। সেটা দুই রকম সন্ধান করা হচ্ছে, একটা যে মোবাইল ফোন কজেস ডিজিজেস অর ইট এনহেন্স দ্য কজেস অফ ডিজিজেস। এই দুটো নিয়ে খুব ফাইট চলছে সারা দুনিয়াতে। এক পক্ষ বলছে it is not bad, that not bad, আর বলছে it is really bad because it's a very high frequency operating device. সেই জন্য এটার নাম করা is been named, if radiation has been renamed as non-ionizing radiation because its energy is very low, less than 10 electron volt, right? Less than 10 electron volt. So it has been named as this, but there are 30,000 papers published in the last 28 years throughout the world, and out of those papers, it is you can see there are various diseases caused by electromagnetic radiation from the mobile phone and towers. It has been reported by the various scientists from different kinds of world. So I will talk about these various diseases later on. So research outcome is that AMID is absorbed in our tissue in the body, and which generally increase the heat, internal heat of the body, causing damages to various organs and leading to insomnia, discomfort, irritability, appetite loss, nausea, muscle spasm, depression, nervousness, hesitation, concentration difficulties, visual disorders, changing blood pressure, cardiovascular problem, etc., etc. Right? So, from our findings, I am going to talk about our findings in Bangladesh. So you can see this is a difference between electromagnetic spectrum. There is distinct difference between non-ionizing and ionizing radiation, right? Depending on the frequency range. Now, these are the mobile phone used, different models, different categories, and we have the radiation tower. We call it base tower station. Now we have these different type of antennas used in radiation for mobile phone communication, and you can see the satellites, 6,000 communicating satellites is circling the world, covering the whole world, right? So world expression is covered with high radiation from 6,000 satellites, right? So this is a picture of a modern room, right? And you'll see there are some sources. In every modern house, there are some sources of EMF or electromagnetic radiation with different amnesties or devices or appliances we use our daily life. Now, this is the scene you can see. EMF, EMF has effects on our body cells. These are from the health physics people. These are the DC. One thing is induces stress response from the users, very bad, right? So these are some of the diseases reported by or from the epidemiological survey from the different countries of the world. And you can see there are some of the diseases and which has become very acute in the human society. Now, so International Commission on Radiation Protection, Ionizing Radiation Protection, non-ionizing protection, they have a guideline in 1998 for mobile phone and towers, and which has been modified in two times, 1912 and 2019 and 2012. So Bangladesh is following IIC-INFA guideline April 1998. Okay, now it is also found that lower animals are extremely sensitive to EMFs, especially the bees and the other birds, very sensitive. So there are some amazing results that are found from many studies, and I'm going to talk about this later on. Now, why mobile devices are so popular? You see, mobile devices have all these facilities. Yes, it has become so much popular. Now, we have done this research on Dhaka city only, but we hope to spread it and other parts of the Bangladesh in near future. Right. So you see, excuse me, May 31, 2011, the WHO has declared mobile phone as a carcinogenic hazard, right? Why? Because the findings from the scientists from different countries of the world, okay? There are more findings right? The findings are blood effects, blood-brain barrier leading to cancer, hearing loss, and ear tumor, irreversible infertility. Children and pregnant women suffer because it can damage the placental barrier in the stomach or of the woman, pregnant woman. It also affects on animals, birds, bees, insects, and plants, causing ecological imbalance in the nature. It is going to be disaster if you don't take precaution from now on. So actually, it's a message. I'm carrying a message that yes, you make a message that we must use the modern amnesties, but with precautions, so that it does not kill us. Okay. Now, so we have the maximum power dose allowed by ISNIRP. We have the specific application aid.
Sorry, interruption. You have 2 minutes.
Achha. So we have to be very careful using NIR. So I'm going to show you the results. We have this instrument we have used to measure the values from. So I'm going to show you. We have from our findings, Evelyn Salme, maximum complaint of what? It is headache. Then you have ear. Then you have insomnia. Then we had ear pain. Right now we had this age group 18 to 26 generation. Then you had years of ages 6 to 10 years maximum. Then you had maximum hours users every hour a day, just 4 to 6 hours maximum use by user. Then you have 9 types of models of mobile phone to be used in Bangladesh. Then you have this data. We have analyzed the data. Then you have this is radiated power from various models of mobile phones, which you can see in the table 1 in details. And so we have adopted ICNRP regulations in Bangladesh by BTCL, but we must modify it as India has modified it because of geographical situation. We must modify our ICNRP regulations. Now, our since it is a very high frequency communication system, it's like a fire. If you use fire properly, very good, beneficial. If you cannot use fire properly, it may burn your body. So we must be careful while using this. So my only complaint, my only urge to my nations, to the physical society, that we can request the government to set up a national laboratory so that either by in BTCL or BTRC or any national institute of or public university for this purpose, so that scientists who are interested or not interested, we have to be interested. So continue research on the effect of radiation, right, on younger generation, especially. So last word is that smoking is bad for health. There is a sticker on every package, cigarette packet. It took long 40 years to put a sticker on the cigarette packets. You know, after deaths of millions of people suffering from lung cancer. So I also request you that you can also request the government to put a cautionary sticker like is hazardous to our health for the user's safety. So thank you very much, and thank you everybody for giving patient sharing, and thank you all.
Thank you, Kamrujaman sir. I can see 2 hands is raised here. First, I would like to take the question from Main Khandakar.
Yes.
Please ask your question.
Thank you, sir, for your nice presentation. So, as far as my understanding,
yes,
from your presentation, this is a completely survey study. Actually, yes, we all are very concerned about the effect of non-ionizing radiation. Yes. So in your study, what you have tried, you tried to get some relation of the users of mobile phone or user of the mobile phone together with some disease or something like this.
Exactly. Yes.
So my question is that how did you confirm that particular diseases is caused by that mobile due to the use of the mobile phone?
Yes, very good question. Very good questions, right? So, well, we have done the survey on mobile phone users, right? Not on other devices, not offline, not television, not this and that, only mobile phone users, right? And so they had many complaints. So we can easily guess at least that somebody suffering using some devices. So you can have some idea, yes, how he is suffering, what is the causes of sufferings, what are the source of sufferings. There are other people's. They do not have that complaint, but these special users, especially the young generations who use mobile phone 10 to 12 hours, 18 hours even a day, right? Especially the high Facebook users or internet users, okay? So this is, as I said at my beginning, I said, because it's only for me, it's just the beginning. My journey is the beginning, a small journey for near future. So I can guess that someone is suffering from these various diseases, either diseases caused from this device he is using, or device has caused the disease, or which has enhances the causes to get him sick, right? So it will take a long time. It takes long time, 5 to 10 years observation to come into conclusion. Yes.
Thank you, sir. Thank you, sir. May I add a comment on your response?
Yes, please.
Yeah. Actually, we also did some similar study, but my comment is that it is better in order to claim these types of results. Yes. In your study, you should include some parameter data. I mean, as an example, by using of the mobile phone, there are many studies. Use of mobile phone effect on the hematological parameter, as an example.
Yes.
The WBC count, this count, that count, something like that. So, in order to showing these types of blank information, it is better you should include some detailed information that effect of mobile phone based on some other studies, that these things is increasing, these things is decreasing. Then only you can give some information that this mobile phone use can make something like this. Thank you so much.
Thank you for your advice. We don't have any such laboratory in Bangladesh. This is the problem. Yes, we just can do the survey. Okay. Thank you very much.
Thank you for the question. We can take another just quick question from Dr. Rashid Nizam. Please ask your question.
Okay, thank you, sir. Thank you for the presentation for this expert. So I saw a graph where you showed some hazards like insomnia and headache.
Yes.
So please show me the graph again.
Okay.
So I want, was the statistics enough? I mean, how was the sample number here? Number one. And number two question is how you confirm that this kind of hazards come from this non-ionizing radiation or this from the radiation of this mobile phone.
Yes. Well, I tell you one thing. I am doing this survey on this in this field for last 15 years, right? I am collecting data last 15 years. Okay, so from collection of my data, at least I can get something that what is going on in this field. So you see the headache is the highest complaint from the users. Okay, so I had more than 300.
How do you confirm? How do you confirm that this headache due to the?
Oh, these are said they did not have.
How do you confirm that it's insomnia?
Yes. This we had a printed form. We supplied it to 400 users, and with all these questions, users themselves filled up the form, right? And from those, they said I did not have these problems before I started using mobile phone. So after they started using mobile phone, they started all these complaints. Yes, this is one kind of case. Okay.
I think we should stop this discussion here.
Okay.
Because time is over.
Okay, thank you.
Okay, thank you very much.
Thank you.
Our next presenter, MAM Mottali Sarkar. source appointment and health risk assessment of heavy metals from indoor air dust of an industrial area, Sabar, Bangladesh.
Thank you, sir.
Okay, you can start.
Sir, can you see my presentation?
Yes.
Thank you, sir. At first, I'd like to thank Bangladesh Physical Society for giving me a chance to say something in this platform. And Assalamu alaikum and good afternoon. This is Muhammad Abdul Muttalib Sarkar from Bangladesh Atomic Energy Commission. Today, I'm going to deliver a speech on source apportionment and health risk assessment of heavy metal from indoor air dust of an industrial area, Sabar, Bangladesh. My research outline is here. Actually, we are all known about air. Yet, the atmosphere of the Earth is the layer of gases which is commonly known as air. It is a mixture of invisible, odorless, tasteless gas that surrounded the Earth. And this air mainly composed of this gas. Let's know what is air pollution. It's a common issue to everyone. Air pollution occurs when the air contains gases, dust, fume, or odor in harmful amount. The substance that causes air pollution are called pollutants. There are various types of pollutant, such as common air contaminant, persistent organic pollutant, heavy metal pollution, air toxic element. Today, I'll focus on heavy metal pollution in air dust. Actually, dust is a common air pollutant generated by many different sources and activities. It often referred to as particulate matter. And this air dust mainly come from ceramic industry, vehicular emission, vehicle tire erosion, battery industry, paint and varnishes, steel foundry work, and construction building material. And this air dust had the impact on human birth, defect, premature birth. This are mainly happen due to air dust pollution. This is the flow chart for collecting and preparing the dust sample for analyzing heavy metal using EDXRF. We collect our sample in the industrial area Sabar near EPZ. The red point is our sample collection point. From Pearson correlation analysis, we see there is a close relationship among potassium, titanium, iron, rubidium, strontium, calcium, manganese, and zircon in the dust, which suggests these heavy metal in dust are due to anthropogenic and natural activities. On the other hand, no significant correlation were found among copper, zinc, and lead, which indicate copper, zinc, and lead pollution might originate from a separate source compared to the other heavy metal. From cluster analysis, we see there are mainly three clusters. First one, strontium, rubidium, zirconium make the first cluster, where rubidium and zirconium form a subcluster, whereas potassium, titanium, iron from the second cluster, in which titanium and iron form a subcluster, and finally zinc, copper, lead, manganese, and calcium from the third cluster. From cluster analysis, we can say ceramic industry is likely to be the common anthropogenic source for cluster 1 material, and whereas iron and steel foundry work and arc welding are responsible for cluster 2 material. And finally, vehicle tire erosion, vehicular emission, and building construction material are responsible for cluster 3 material. From principal component analysis, we see a total 79.39% of cumulative variance was accounted for this loading, and we got four principal components or four factors. Rubidium and zirconium form factor 1. It suggests these material are coming from ceramic industry, whereas potassium, titanium, and iron from factor 2, and it suggests these are coming from ceramic paint and plastic industry. Lead from factor 3, and that is coming from batteries and paint industries. Finally, zinc from factor 4, that is coming from automobile, galvanization, and battery industries. From non-carcinogenic health risk assessment, we can say ingestion of dust particle is the main exposure route to the children, and it is 1 to 5 order of magnitude higher than inhalation of dust particle. And inhalation of dust particle through the mouth and nose was almost negligible compared to the other route of exposure. Hazard index value for children decreases in the order of zirconium, manganese, lead, iron, copper, zinc, cobalt, and strontium respectively. Whereas for adult, hazard index value decreases in the order of zirconium, iron, manganese, lead, copper, zinc, cobalt, and strontium. It was observed from this study, zirconium exhibited hazard index value 35.5 for children and 15.19 for adults at 95% upper confidence limit, that is too much larger than safe level, that is adult hazard index value lower than that of children indicate that the children are likely to face greater danger as a result of exposure to the dust.
You have to finish in 2 minutes.
Yes, sir. I'll finish. From carcinogenic health risk assessment, we see the only one carcinogenic heavy metal in this study is cobalt. The maximum lifetime average daily dose in milligram per kg per day was found 1.38 into 10 to the power minus 8 for cobalt in the dust sample. The maximum risk level was found to be 1.07 into 10 to the power minus 8 for cobalt. The level of cancer risk associated with exposure to this element in the dust was not fallen within the range of threshold value, and that is lower than that of threshold value. In conclusion, we can say PC analysis shows 4 factors, where both factor 1 and 2 show ceramic industry is the common source for the dust pollution. So it might be predicted that the dust pollution coming from ceramic industry is one of the key factors for the pollution in the study area. Hazard index value for zirconium was found to be alarmingly higher than the safe level for both children and adults. Hazard quotient value of all metal for ingestion of dust particle were 1 to 5 order of magnitude higher than for inhalation. The only carcinogen found in this study is cobalt, which was not falling in the threshold range, and it can be said there is no carcinogenic effect on human body. Finally, the health risk assessment indicates that under the consideration of US EPA, the children are more vulnerable to non-carcinogenic effects, whereas the children and the adult are not sensitive to carcinogenic effects. That's all, and this is the reference that I use in my study, and that's all. Thank you everybody for your patience. Thank you, sir.
Thank you, Mutalib, for your nice presentation. I can see 2 hands are raised here for question. At first, Dr. Mohammed Tariq. Sir, you can ask your question. Is there anybody to help him to unmute? Okay.
Yes.
Yes. Thank you very much. This is a very good presentation. So just for my interest, I just want to ask you a question: is how do you confirm that each type of contamination comes from different type of factory or ceramic industry battery? How can you confirm this? Did you make some distance related spot or sample collection? Just this simple question.
Thank you, sir, for your question. Actually, I confirm this from cluster analysis and principal component analysis. Cluster analysis and principal component analysis are alternative and analytical method for source apportionment. From cluster analysis, we can see from cluster 1 that ceramic industry is the common anthropogenic source for this material. Again, from principal component analysis, we can see factor 1 and factor 2 indicate the ceramic industry for coming this material. That's why we can say ceramic industry is the key source for this heavy metal pollution.
Thank you.
Thank you, sir.
Sorry, no more question. We have time is over. So we have another presenter.
Thank you, sir. Assalamu alaikum.
Analysis of
স্যার আপনারটা আনমিউট করেন প্লিজ।
Okay.
Our next presenter, H. Ara. Please continue.
Can you see my presentation slide, sir?
Yes.
Good afternoon, everyone. I am Hosne Ara, PhD Research Fellow in Nonlinear Biooptics Laboratory, Department of Physics, Shah Jalal University of Science and Technology, Sylhet. Today, I am going to give a short presentation on analysis of circulating cell-free DNA extracted from blood plasma of cancer patients and healthy persons and their G-scan study. The objectives of our studies: to determine the levels of circulating cell-free DNA concentration in blood plasma of cancerous and non-cancerous individuals, and to assess their concentration for early detection of cancer using G-scan technique. My presentation divided into 5 different parts. First one is circulating cell-free DNA or CCF DNA. Second, methodology such as plasma separation by centrifugation, DNA extraction by the Maxwell RSC CCF DNA plasmatic method, and 2, analytical method, nanograph method, and quantiflow dsDNA system. Third, G-scan experimentation. Fourth, result and observation, and last, conclusion. Circulating cell-free DNA are DNA fragments which circulate through the bloodstream and body fluid. And its clinical importance was recognized when researchers observed the difference between the characteristics of CCF DNA from the healthy and diseased individuals. The existence of CCF DNA was first reported by Mendel and Matthias in 1948. Centrifugation is a method of separating molecules having different densities by spinning them in a solution around and exist at high speed. In our study, blood plasma separation from whole blood has been done by the centrifugation method to follow the following step. In our study, blood samples have collected from 40 different cancer patients and 40 different healthy individuals. After separation of plasma, CCF DNA have extracted by the Maxwell instrument with the Maxwell RSC CCF DNA plasma kits. Following steps Following steps are followed here for the preparation of Maxwell curves. As for analytical method, there are 3 different methods have been used for quantification of CCF-DNA: fluorometric method, nanodrop spectrophotometric method, and G-scan. QuantiFluor ds-DNA system is a fluorometric method. It follows these 3 steps. First steps: prepare QuantiFluor ds-DNA diverting solution and dispense in 0.5 ml tubes, and then add prepared blank standard and unknown sample to 0.5 ml tubes, mix and incubate for 5 minutes, and last stage is measurement. Nanodrop spectrophotometer is an innovative sample retention system that uses the surface tension to hold and measure the microvolume sample between 2 pedestals without the use of cuvette or capillaries. Our analytical method is G-scan. This is a closed aperture G-scan setup. Here, sample is translated along the axis of a focused Gaussian beam. The on-axis phase shift depends on the nonlinear property of the material. Omega naught or del phi is calculated by the following equation. Result and discussion. In our study for statistical analysis, descriptive statistics t-test for 3 samples assuming equal variance and graphs are performed with Excel. This figure shows the result of CCF-DNA concentration level in cancerous and non-cancerous individuals. Here, the identity of population and concentration of CCF-DNA along the X and Y axis respectively. The particular color represents the category of populations. Red color for cancer patients and blue color for control populations. From this figure, we can see that there is a significant difference in the level of CCF-DNA concentration between cancerous and non-cancerous individuals. This figure also shows the quantitative measurement of CCF-DNA in nanogram per microliter, which is done by nanograph. Same type of results are also seen here. This graph shows the nonlinear response from normal sample for different incident power, and this graph shows the nonlinear optical response of cancer sample for different incident power. And this graph shows the difference in concentration between cancer and non-cancer sample with the same in del phi with the power. Observations. Differences between cancer and control population for all the 3 methods are statistically significant. The CCF-DNA concentration of cancer patients, where mean is 1.07, standard deviation is 1.32, and observations quality are found to be greater than those of control populations, where mean is 0.033, standard deviation is 0.096, and observation quality according to fluorometric method. The CCF-DNA concentration of cancer patients where mean is 3.36, standard deviation is 1.10, and observation quality are found to be greater than control populations, where mean is 1.44, standard deviation is 0.28, and observation quality according to nanodrop spectrophotometric method. Nonlinear phase shift for cancer sample are significantly distinguishable from those for non-cancer sample at different powers, according to G-scan method. So, in conclusion, we can say concentration of CCF-DNA in cancer patients are greater than those of control populations. CCF-DNA quantification may be used as a diagnostic marker, and G-scan might be a valid technique for CCF-DNA quantification. I would like to acknowledge to all. Thank you. Thank you.
Thank you, ma'am. Now, floor is open for question. Perhaps we can accept just one question. Any question, please, from audience? Respected chair, perhaps there is no question.
No, so, okay. Thank you very much. So now I conclude this session. In this session, we have one invited speaker and 4 contributory paper presenters. Invited speaker, Professor David Bradley, he nicely presented towards the development of radioluminescence sensors. And our first contributory presenters, he presented the real-time environmental radiation monitoring. This is very important because for the baseline data and our before starts our Rupur power plant. And another health effects of electromagnetic radiation from cell phone. This is very related to our life. I think it is a very important topic. He nicely presented his papers. And another paper, the health risk assessment of heavy metals, that means air pollution. I think it is also very related to our life. He also nicely presented his papers. And lastly, Hosne Ara, he also presented his papers very nicely. I thanks all the participants of these sessions. I also thank to my co-chair, Mr. Abul Hassan Rubel. Thank you all. Thank you very much.
Thank you, sir. Thank you very much.
Okay, dear audience, thank you very much, sir. So I am from Professor Dr. Mohammad Mohiuddin. So dear audience, now the time is for the thinking session 10. So in this regard, I would like to request the Professor Jivan Putta sir and Dr. Muhammad Tariq Chaudhary to take over the charge of this session as chair and co-chair. Dear audience, the thin film session 10.
Good afternoon. Am I audible?
Yes, sir. Yes, yes.
Okay. So all distinguished speakers, participants, scholars, ladies and gentlemen, I myself, Jivan Poddar and Dr. Muhammad Tariq Chaudhary will chair this session. So I can see many of my good friends here today. So my feeling is that the virtual conference is more attractive than the physical conference, because we have in the audience, even after the lunch, about 60 participants, 60 members in the audience. So it is really very encouraging that in the virtual conference, we have a very big audience. So the title of these sessions, already you heard that the films session, and these sessions consist of the one invited paper and the 5 contributory papers. And first of all, these are 20 minutes is allotted for the invited talk, and then the 10 minutes for each oral presentations. So first of all, I would like to introduce Dr. Muhammad Akhtaruzzaman. So he's going to present the invited talk, the materials for stable perovskite solar cells, that is advances, challenges, and opportunities. So may I invite Dr. Muhammad Akhtaruzzaman to give your presentations, and I would request again to strictly follow the time, the 20 minutes time for your invited talk. Yes, yeah.
Am I audible?
Yes. You can do actually that the slide presentation mode, so it will show that bigger screen actually. So can you show in slide mode?
Okay, just one minute, please. Just start with now.
Yeah, it's okay. Please carry on.
Okay, thank you. Sorry. Assalamu alaikum and good evening. First, I'd like to thank the chair of the session and also thanks the organization committee of Bangladesh Physical Society to arranging such a wonderful conference. So I'm very delighted to present my work here. So I'd like to thank all of my friends, colleagues, those who are in Bangladesh and outside, and all of the participants. My name is Mohammad Akhtar Jaman. I belongs to the Solar Energy Research Institute of University Kebangsaan, Malaysia. University Kebangsaan, Malaysia is one of the top research university. This research university is the now 141 in QS World Ranking, and our research institute, one of the top research institute in this in this university, and we have 21 academic and 30 supporting staff members, and more than 100 PhD and master students. In our Solar Energy Research Institute, we have 6 research areas. Like one is the solar photovoltaics and advanced solar cells. Second one is solar thermal technology. Third one is the wind and marine energy turbine. And fourth one is a low energy architecture. Fifth one is the energy management, economics and policy. He is our director, Professor Kamruzzaman Sufyan. He's one of the highly cited professor in Malaysia. I'm also very happy to share my group. We have the 4 postdocs and 14 PhD and master students, and also 4 associate fellows that we are actively working together. Alhamdulillah, a few students from Bangladesh, and 2 of them getting the Bangabandhu Fellowship from Bangladesh. Thank you so much for your kind support. So this is our one of the unit that the solar photovoltaic and thin film solar cells. I am leading this organic thin film solar cell. In the organic inorganic thin film solar cell, most of type solar cell actually we are fabricating and trying to improve the solar cell performance, stability and efficiency. The main issue is the clean energy, that is the fulfill the sustainable development. The solar energy is one of the most clean energy in regard to sustainable development. Amongst that, silicon wafers, that is we call the first generation solar cell, including the crystalline or multi-crystalline solar cell, and second generation solar cell, that is we call the thin film solar cells, are often commercially available, not high as compared with the silicon technology. But their performance, like the cadmium telluride, cadmium indium, gallium arsenide, all performance around 15 to 20%. The next is the third generation or the next generation solar cell that we are working on. Mostly our students are working on that area. In third generation solar cell, including the perovskite solar cell, dissensile solar cell, bulk heterojunction solar cells, and so on. So to compare with the solar cell technology, in terms of the efficiency, cost, weight, stability, and the environmental issues like the scalability and the toxicity, fresh water.
Excuse me, the speaker. I cannot see that the change of the slides actually. That is the first slides is still remain on the screen. Really? Is it with everybody or?
Yes, sir. We cannot see the next slide, sir.
Okay. Please.
Now you see this one?
No, that is the first slide still remains on the screen. So
yes, it's still the first slide.
Yeah. So I am also confused to see whether I will react it or not. Please.
I am sorry. In my slide is moving, but can I actually stop and take in?
Yeah, please. Keep in mind that the time is 20 minutes, please. Yeah.
Is it moving now?
No, we cannot see your presentation slide. We are seeing your face.
I think you can actually, restart or again start from the first slide and then move quick.
Yeah, now the desktop appeared. Now is okay, I think.
Now is okay. Yeah. Please carry on.
Okay. I think I'm talking here. Okay, regarding the environmental issue that among the three solar cells, that is the first and second generation solar cell, we have some issue like silicon technology. You can see, even though the production cost is gradually decreased, but it requires large amount of energy, especially for the fresh water or accessible, or the very big area of land, and also using some hazardous material in the processing. Now, therefore, if we compare with the other solar cells, eco-friendly, the next generation solar cell is more